The future is the great unknown. One day, we'll turn our plastic problems into worm food.
We're doing that.
The best time to own the unknown is now. The University of Queensland.
Curiosity, collaboration, and courage to think outside the box are at the core of science and technology in defence. From developing high-tech capabilities to creating new technologies, defence researchers are at the forefront of our scientific advancement. We aim to inspire the next generation of scientists, researchers, and engineers. And our collaborative partnerships help solve some of our nation's biggest problems and protect our way of life.
Good morning and welcome to Science at the Shine Dome 2022. My name is Paul Richards and I'm the Director of Communications and Outreach at the Australian Academy of Science. I'd like to start by acknowledging and paying respect to the Ngunnawal and Ngambri peoples, the traditional owners of the lands on which the Academy office is located. The Academy also acknowledges and pays respects to the traditional owners and the elders, both past and present, of all the lands on which the Academy operates and its fellows live and work. They hold the memories, traditions, cultures and hopes of Aboriginal and Torres Strait Islander people in Australia. Well, we have had an incredible evening of the Prime Minister's Prizes for Science, and just an hour ago a breakfast here at the Shine Dome for all the recipients at the Home of Science. Now the celebration of science continues with a full program of events across 3 days. And you have a front row seat right here at the Australian Academy of Science webpage. I'd also like to take this opportunity to thank all our sponsors that have made Science at the Shine Dome possible. Our platinum partners, CSIRO and Defence, our major partners, the University of Queensland, who are also supporting diversity and inclusion initiatives at the events like childminding, the University of Sydney, who are also supporting our gala dinner tomorrow night, the Department of Education, who are the live stream partner for Science at the Shine Dome, the ANU and University of New South Wales, our gold partners, proudly including the Department of Industry, Science and Resources, Deakin University and the University of Melbourne. And we also thank QUT, Evans and Partners, the University of Adelaide, Nature Portfolio and the University of Newcastle. And thanks to all the organisations who have made it possible for early and mid-career researchers to attend our event. Well, it's been 3 years since we've gathered here at the Home of Science for the Academy's flagship events. Take a look.
Science at the Shine Dome celebrates excellence in Australian science.
Australian scientists have made major contributions.
It's also the top networking event for researchers from all disciplines and career levels to meet the country's most influential scientists.
We have lots of early and mid-career researchers come to Science at the Shine Dome. They can develop networks, they can develop mentorship with some of the leading scientists.
There are workshops, presentations and a gala dinner featuring political and industry leaders. More than 400 people attend from all over the world.
I've had 4 amazing spaceflight experiences.
And around 500,000 people are engaged on social media. Science at the Shine Dome is a unique Australian science event and networking opportunity.
Well, if you were in Canberra yesterday, you might have wondered if it was May, not November. We had wind gusts up to 70 kilometres an hour and cold rain falling sideways here at the Shine Dome, and the temperature only reached 12.9 degrees. It was a reminder of the severe hailstorm that damaged the roof of the Shine Dome back in January 2020. But despite the enormous challenge of repairing the roof of this heritage-listed building in the midst of a COVID-19 pandemic, the Shine Dome has now been fully restored.
The Shine Dome needed a new roof because it was so severely impacted by quite a freak hailstorm.
Canberra took a beating.
It dented all of the roof tiles.
I mean, obviously the building's over 60 years old now, and the hailstorm did cause some damage, but it really just, I think, triggered what was already a situation where, like all things, as we age, it doesn't work so well anymore. It was prone to potential leaks and the elements were getting in a bit. And so it was really a wake-up call that, hey, it's time to really redo this to modern standards so that it can withstand that sort of challenge.
When the dome was first designed, the people involved in that, of course, were the Fellows of the Australian Academy of Science, and they were really keen to create a big, bold concept, something that would last the test of time, that would be unique.
The methodology they originally used, which is now part of the heritage, is not a waterproof system. So the challenge then was to come up with a secondary shell on top, which is not fixed into the concrete at all.
So the replacement of the roof isn't quite a replacement because the existing copper tiles are staying on and a second copper tile layer is going over the top.
We needed to come up with a more modern way to recreate that pattern and the seaming joint on how it came together, which was a bit challenging.
There are two waterproofing layers. There are some wooden batons and layers in between, but all of that put together creates a gap between the existing copper layer and the new copper layer. And effectively that gap operates as a ventilation system. And in doing so, it creates a lot of energy efficiency for the dome in terms of heating and cooling.
Once everything is finished, nobody will notice that this is actually a new shell on top of it, and the whole dome has risen by probably 65 mil.
We believe that copper was originally chosen for the Shine Dome because it would allow it to be a particularly stunning building, a unique building.
Copper is produced and it comes out of the mill. It has that orangey, glary look on it, which is referred to as copper mill finish. Once copper is exposed to the elements, it reacts with oxygen and it creates a patina.
And as you know, it goes from a lovely shiny colour, the shine dulls off a little, and then over time it becomes a blue-green-grey. And that is really time cemented onto the dome in many ways, or aged onto that copper.
The Shine Dome really, of course, is the home of science in Australia. Being an iconic building in the national capital, it represents the importance of science and innovation and discovery in the well-being of our society.
The Australian Academy of Science.
Because questions need answers.
And President of the Australian Academy of Science, Professor Chinapati Jagadish, joins me live this morning. Good morning, Jagadish. It's good to see you.
Good morning, Vig.
Now, how happy are you to be back at the Shine Dome, at the home of science for Science at the Shine Dome?
Oh, I'm absolutely delighted that after 3 years we are able to really meet at the Shine Dome to be able to celebrate science and scientists. As you know, it's been a very challenging time for the last 3 years with the hailstorm damaging the Shine Dome, and also the COVID pandemic not allowing be able to host the events which we were very keen on hosting to celebrate science. It's a great opportunity to celebrate science, and we are excited and delighted to be able to see so many of our colleagues, those who are really doing great job in terms of doing excellent science and also promoting science as well.
How have the trials of the last 3 years or so really given a renewed purpose to the Academy?
So the last 3 years has been challenging, particularly for early and mid-career researchers. So they have really bore the brunt of this impact of the COVID-19. So that also made us aware that how important it is to create a sense of hope for the next generation, and that's what I keep on emphasizing whenever I meet the Prime Minister or these other ministers, the need for really nurturing the next generation, because science has an important role to play in the society, in our economy, and improved quality of life for all the people.
You became president in May this year. This was just as COVID restrictions were easing and international travel was starting to resume. But with urgency for action on climate change and the need to address a myriad of issues to support the future of science in Australia, what are some of the biggest challenges and opportunities you think that face science today?
So the science, climate change is the major issue for not only for Australia, for global community and to the planet. So that's why we need to really address climate change as a priority, and science has an important role to play. And again, we also need to bring the policy makers along with us in order to be able to really create the right environment and right support in order to be able to address the climate change. And we have also seen during the last 3 years the role of the pandemics and their impact on the society. For example, COVID, again, we keep on getting the new variants. And again, we need to think globally. Because for example, people, those are in the rich countries, and then these pandemics will mutate and then come back with the virulent strains. So that's why it is important we look at as a global community, whether we talk about climate change or pandemics, and then we really work together. And so thereby we can progress together as well.
It's a fascinating point because science has always operated beyond borders, but really crises like the COVID-19 pandemic and also climate change are a great way to level the playing field, as it were, and we need to be able to address both the pandemic as well as issues around climate change at a global scale, and without just choosing those who are from richer countries or most fortunate.
Absolutely, and in fact I've attended the G20 Science Academies meeting in Jakarta last month, and that's where the major discussion has been, recovering together and recovering stronger. And so that's a theme of that particular meeting, and everybody has pointed out how important it is we work together as a global community to address the problems like climate change and then the pandemics.
Now, the Shine Dome was officially reopened not long after you became president, and an initiative was launched called Celebrate Science, which seeks to recognise scientists who are now literally part of the foundations of the home of science. First fellows and science organisations, and now anyone can make a pledge and dedicate a tile to a scientist. And I've picked one for the late Professor Bob Crompton, who died only in June this year. The dedication left for him reads, Professor Robert Crompton, AM FAA, pioneer in electron collisions in gases, meticulous experimental physicist, scattering cross-sections, diffusion and drift, humble science leader, generous supporter of students and colleagues, wonderful mentor and friend, devoted husband and inspirational father, and elected to the Australian Academy of Science in 1979, served on Council and FinCom, and Secretary of the Physical Sciences from 1984 to 1988. And this dedication was made by Professor Jim Williams. It's now a lasting legacy in his honour. What would you say to someone watching now and considering making a pledge of their own?
Yeah, the Celebrate Science campus campaign is an outstanding campaign, and we really need to celebrate science and science teachers as heroes of the society. And it's a great opportunity for anyone in the country or globally to be able to dedicate a tile on the Shine Dome to recognize and acknowledge contributions made by the scientists and science teachers to our society. Now, and I had the chance of donating 5 tiles, and then also I'm planning to donate 2 tiles for my science teachers, those who have made all the difference for me in my life.
Oh, and we've just seen that again with the Prime Minister's Prize for Science recipients this morning, the need for amazing teachers working in STEM subjects right through to fellows like Professor Trevor McDougall, who won the main prize, and really it takes a broad cross-section of different people working in research and working in teaching to produce the sort of science that we make our lives better.
Absolutely, and science teachers really play an important role, and many of us have been inspired by science because of the fact that we have had some wonderful science teacher really taught a physics or chemistry or maths or biology, and that really made us to choose that particular discipline. So these teachers really play a very, very important role in the society. We really need to celebrate our teachers much more than we do currently as a society, because they are the pillars of the society for us. And as you point out, that the full spectrum of scientists need to be recognized, young researcher to senior researchers, and it's a full spectrum. We need to make sure that we are really acknowledging everybody, including science communicators as well.
Jagadish, we're about to get underway with Science at the Shine Dome. What makes this event so unique on the science calendar?
So this acts like a real, celebration of science and excellence in science in Australia, and also inspire the next generation to really aspire to be fellows of the Academy or winners of the awards, so that if they really choose to really put the hard work needed and put the passion to continue to do their science, one day they can be recognized with these recognitions like awards and fellowships of the Academy. This is really an exciting time, not only to celebrate science, but also inspire the next generation as well.
Well, Jagadish, you have an incredibly busy day ahead, welcoming 3 years of fellows formally to the Academy. Thanks so much for giving us some time this morning.
Thank you, Viv. It's a pleasure, and we are absolutely delighted that we're able to celebrate 3 years of fellows and 3 years of award winners as well during this week.
Well as our fellows and teachers and people are needed for science to be successful, there's a whole range of infrastructure that is necessary in order for science to function. Let's take a look at one of those key pieces of infrastructure that has become iconic in Australia.
The Parkes Radio Telescope is by far one of the greatest telescopes in the world.
There's a smell and there's sounds, and every part of it I love.
My first experience at Parkes was just crazy. The second you see the 64-meter big telescope there with wonderful weather, blue sky, I was really shocked. I saw this is the way to do astronomy.
It's 1,000 tons of steel that sit up on 4 big wheels and can point to almost any direction in the sky. I mean, as an engineering feat, it's amazing, but it's aesthetically marvelous.
It's 64 meters across. That's in the biggest of the big telescopes.
The bigger your telescope, the more energy you collect.
So it's very sensitive. And the people here at CSIRO are very good at building actually receivers, we call backends, the computers to process the data, which makes the telescope really powerful.
The most recent upgrade was just a couple of years ago with a very wideband receiver system that allows us to observe the radio waves over a much wider bandwidth than any other telescope on the Earth.
So we are in the southern hemisphere. When you look up the sky, you see the galactic center. So this is the best location if you want to study freedom objects in our Milky Way.
And then we have another advantage in Australia, which is that we don't have very many people. And radio telescopes are perpetually swamped by the radio signals of all the things that we have around us. Our computers, our mobile phones, our microwaves, radio stations, everything else that happens at radio frequencies. So if you can build your radio telescope where you don't have a lot of people, then that's a much better place for it to be.
The Australian Academy of Science, because questions need answers.
The Shine Dome is not just a meeting place for science, it is also home to the Fellows Archives. Professor Hans Backhaur is joining me now, along with the Academy's archivist, Claire McClellan. I got it out. Good morning to you both.
Good morning.
So to begin with, Hans, why are the archives so important to fellows and to society?
Well, we are looking at the building here, but we really would like to look at the people. And luckily, they left the loft behind in their notes, in their books, in their words. We didn't have videos in those times, so we're largely relying on written material. But that, to me, is as important as what we have behind us in the building.
Yeah, it really is the record of the incredible work that has gone into some of the most important discoveries of our time, and we're going to take a look at a few of those in a moment. Now, Claire, how long have you been archivist now, and what did you think when you first came to the Academy and saw what lay before you?
I've been at the Academy a little over 3 years, and I think my first impression was just how nationally and globally significant some of the material that's kept in the building behind us actually is.
And I mean, you've just heard Hans talk about, you know, how important this is to him and all our fellows. So it must make you very proud to be a custodian of taking care of those records.
Very much so, yes.
Yeah. So Claire, you've recently obtained a very special piece of equipment to scan and digitise material, and you brought along a selection of some of those digitisation scans so far. Let's start with some of the early designs and images of the Shine Dome. Can you tell us a bit about what we're looking at here?
Yeah, I can. So in addition to being a major repository for the collections belonging to Fellows of the Academy, the archive also contains the history of the organisation itself. So we have here some early concept art by the architects of the Shine Dome, who were Roe Grounds, Fred Romberg and Robin Boyd, who it's widely believed actually received the commission due to producing beautiful work like this that allowed the founding Fellows of the Academy to really imagine what the building might one day become.
It does capture the imagination, doesn't it? And we've got some of the design features here as well. Hans, you know, what catches your attention when you consider the design of the Shine Dome?
Well, to me, it's like a focus, right? You look at that and it brings us to the center of the image, which is where people actually communicate. This was designed to bring people together. There was no place for a symposium in Canberra, and I think it does that exceedingly well.
Yeah, fantastic. And we're also got a range of other pictures of the construction of the Shine Dome in its early phases. This is a shot of overhead of the design itself, but do we have the picture there of the construction actually taking place here? Look at that. I mean, in some ways it reminds me a little bit of what we watched a bit over a year ago, but this was 67 years.
This would have been 1958 here, and one of the main goals of the construction was for the Academy to have something that was forward-looking, to have something that wasn't a traditional building and wasn't like anything else in Canberra or really any other major city at the time. And if you look at, say, Old Parliament House or the Institute of Anatomy, this looks like a bit like a spaceship that landed in a field. So it was quite different, and they really succeeded on that front.
Yeah. So allow me to add something technical. I mean, that was actually almost an experiment. The technology was brand new. How to do a dome that is covered in concrete but self-supporting. And that was brand new technology. You see that in other important buildings around the world, in the US and in Europe. And they just pushed the limit of what they could do. And also it's very sustainable. You know, this will last another 50, 100 years. The embedded energy is fully there, covered by copper.
That's absolutely fantastic. And we also saw a picture a moment ago of a feature that no longer exists within the Shine Dome. It was, I think, of a fountain.
Yes, well, it's technically still there, but it has been covered over. You can see in the illustration, beautiful fountain, looked wonderful when it was installed, but there is nothing to stop people from falling in, and so they did. And
we needed to prevent that then.
Yes, we did need to prevent that, and you can sort of see the water and the beautiful terrazzo tiles were maybe not a great mix, and it was quite slippery when the building was crowded. So the fountains still exist, and the heritage value of the building has been maintained, but they have been covered over because they were a bit of a hazard to life and limb.
Well, good to see the way that they iterated on that early experiment, and the design evolved, and we have a beautiful dome that we're going to be enjoying for the next 3 days. Now, Claire, you also have some remarkable pictures to share of Professor Frank Fenner. Can you talk us through what is happening in this picture?
So, yes, this is Professor Frank Fenner, who was the chair of the Global Commission for the Eradication of Smallpox, which was a program that ran through the World Health Organization for 10 years. And this is the World Health Assembly in 1980, where he stood up in front of basically the whole world and declared that smallpox, which was an ancient disease that had killed 300 million people in the 20th century alone, was completely gone from humanity. It had been eradicated.
I mean, Hans, capturing moments like this, and these are some of the notes I understand around that reaching that moment and that declaration. This is history, but also so relevant for now too.
Yes, I invite everybody to read it, and luckily it's digitized and accessible, and Claire can tell you how to get to it. It's probably very understated if you think about the vision and the energy that was there to actually eradicate a disease, which they succeeded in doing. I think it's exemplary, and I think it's a motivation for what we want to do now.
Yeah, well, that's really important as well on a number of levels. So finally, we have a selection from one of the early Antarctic expeditions. Hans, how would you describe the value of preserving this kind of history?
Well, look at images like that, study the text, and you feel the people actually doing it. You see why they're doing it, what the challenges was. So I think this is complementary to what we know from our books. We know the facts, but I think this brings it to life, and that's why we have an archive, and that's relevant to the challenges we have now. Right? To look back, it's only 60 years ago, people were pushing the limits, and we want to do it again.
And Claire, we're seeing some of the pictures of some of those early expeditions. What can you tell us about?
We are. So these are actually pictures taken by Professor Frank Stillwell, who was a fellow of the Academy of the Mawson expedition in 1911. And this is, they camped on what was they essentially called a river of wind. They were in a state of constant blizzard. And you can really get a sense of that looking at their tents here, which are terribly flimsy and we probably wouldn't use in any circumstances anymore. But as Hans said, these were difficult things that had real scientific value and significance, and learning what people's experience were and their successes, their challenges, it can be relevant, it can underpin and be relevant to how science and how large projects are approached today.
Yeah, fantastic. Well, Professor Hans Bachoor and Claire McClellan, thanks so much for stopping by and keep up the great work.
Thank you.
Thank you.
Thank you. Well, we're not far away from the official start of Science at the Shine Dome. We're going to take you to a live shot inside the theatre. You might be able to see a few people milling around, starting to find their seats. We have some of the officials of the Academy who are standing up the front, getting ready. They've got a really big role to play today, a full day of admission ceremonies for 3 years of the fellowship. A lot of fellows have waited a very long time for this moment to have their opportunity to sign the charter book, and then we'll get to see and hear a bit about all of their incredible science as well. So do stay with us. We have lots of other news coming up and interviews. Very shortly I'm going to be catching up with the head of the Early and Mid-Career Research Forum because they, as we've heard already this morning, play such a crucial role in the work of science and the success of science within Australia. So we will be talking very shortly to Rafaela. So stay with us. The sun is beautifully shining here outside the Shine Dome. We're going to be conducting interviews here all day, so do stay with us. Why don't we take a look now at some of the scientists who help make the Academy what it is, and really take a look at why science matters.
Science matters to all of us.
We're living in science. We're a world that's driven by science.
A world without science would be a desolate sort of place.
No technology, no electricity, no travel, no planes, no medicine.
A good scientist is someone who can ask a really good question. Once you've answered it, it will have an impact on all sorts of other fields.
With science, you're trying to uncover something no one else has ever managed to discover.
I think the moment of discovery is a really interesting moment. The point where you realise that you're studying something that could be profoundly interesting, and you can almost taste the discovery.
It's the biggest buzz you can imagine, the aha moment that, oh my God, we've got it.
We live in a world of extraordinary challenges. The solutions to those challenges are more science and technology, not less.
If the public have a deeper understanding of science, that allows them to make more informed choices about the way they live their lives, the way they interact with the planet. and being healthier, which ultimately impacts their families and their communities.
The future doesn't happen to us. We get to decide it. Those decisions will be about how we best use technology and science to solve the very many problems that are facing us.
We have come a really long way in scientific discovery and innovation over the last 100 years, even in the last decade. But there is still so much that we don't know.
The beauty of the universe.
Understanding the basic building blocks of life.
The beauty of how things work.
With science, you can solve problems. With science, you can make discoveries that none of us could ever have imagined.
Well, if you're just joining us this morning, my name is Paul Richards. I'm the Director of Communications and Outreach at the Australian Academy of Science. Welcome to the Shine Dome here in Canberra, where the sun is shining, I'm thankful to say, after the wild weather that we had yesterday. We're going to learn more now about the EMCR Forum and the Early Mid-Career Researcher Network. The Forum Chair, Dr. Rafaela Debakhelis, is joining us. Good morning, Rafaela.
Good morning.
Could you start off by telling me, have you come to Science at the Shine Dome before? Is this your first experience, or have you been previously?
No, I've never been. So I'm very looking forward to attend these 3 days and see what happens and connect more with the Academy and the fellows.
Oh, it's so fantastic. And I mean, the anticipation from, not really being able to hold this event in person for 3 years, but then to be able to bring people, you've come across from Western Australia to Canberra as well. And there are many early and mid-career researchers who are attending Science at the Shine Dome this year as well. How important is that to be able to connect with fellows of the Academy and a range of people from disciplines that you might not normally spend time with?
Well, to me personally, my network has always been my strategic asset, in the sense that sometimes it's only through connecting to people that you get to know about opportunities, and you get the chance of spreading out the word of the research you're doing, so that you may even get collaborators, or you may get introduced to people that collaborate with you. So it's a whole bunch of opportunities that come with networking, and so I think that is the biggest benefit of being here today.
Now, not to put you on the spot too much, but are there any people in particular, fellows in particular, that you're looking forward to catching up with while attending the event?
Well, I'm very looking forward to catch up again with Professor Dorit Jacob. We worked a bit together, but then we kind of disconnected for reasons that everyone has their
research goes different directions.
Path, but yeah. I'm really looking forward to have a proper catch up with her. And see whether there's anything that we can work together again.
Now, the EMCR Forum is a very large and dynamic group. Tell me a bit about how the Forum works to support EMCRs and also how the Forum interacts with the Academy.
So the EMCR Forum is run by EMCRs for EMCRs. Our focus is on advocating for career agility, career sustainability, for a fair, accessible funding system, and more generally on equity and diversity. And we do that through a variety of ways, including policy submission, position statements, connecting to our network through media, which is quite important to maintain a two-way communication between us and our network, but also communicate with those on top of us. Then we also organize professional development specifically for EMCRs, or support events that are already being organized. And overall, we work really hard to make sure that the voice of EMCRs and the diversity of this voice gets to the table where decisions are made.
Yeah, that's not an easy task, is it?
No. Yeah, I want to take the opportunity to thank all of the executive members. So it's 12 of us, and we do work on a volunteer base, often on our free time, and tireless throughout the year. So a big thank you to all of them and all of the people who support the forum, including the diversity and inclusion team at the Academy, and more generally, all of those institutions, people, bodies that do engage with us.
Well, you've experienced the value of a network like the MCR Forum firsthand as a mid-career researcher right now. You've faced numerous barriers to career progression in STEM career breaks, carrying responsibilities, and now advocate for more inclusive and flexible research environment. How do you think Australia is going addressing these issues?
I think it is going. So things are happening. Unfortunately, things happen slow. But compared to other countries, I wasn't born in Australia. I come from Europe, and there are at least conversation is happening. So people are talking about these issues and are talking openly and honestly, which doesn't solve the problem, but at least puts the problem on the table, which is already a big step.
Yeah, and your own experience in moving to Australia from overseas is actually incredibly common among EMCR Forum members, I'm sure.
Yeah, it's quite common. I come from Italy, and there's been a point where funding has been less and less and less, and people in STEM, in research, people with a PhD, whoever could leave the country, kind of did. Because some people had the opportunity to stay, but a lot of people just decided to leave because of the lack of funding. So I want to avoid the same thing happening in other countries as well.
Yeah, and your area of research now, let's talk a little bit about that, is the study of how minerals form from coral reefs to the human body. And you use computational methods to conduct your work. What's exciting you in your field at the moment?
So my research is basically, yes, modeling minerals, so and materials more generally. So all materials are made of those tiny particles called atoms, and depending on how they put next to one another, so imagine to be very small and sit on one atom and look at what's around you. So it's what we call mineral structure or material structure, and depending on this structure, it's also that come the properties, how mineral grow or react with their environment. So it is a pretty exciting field, because if we achieve enough accuracy in our modeling, we can actually predict things and also help. What you can't see experimentally, we can kind of direct experiments to see things that they wouldn't see normally.
And what do you enjoy most about this kind of research and discovery? It's pretty complex and also fundamentally important too.
So yeah, that's the hardest question I've ever had. So when I was 12, I was at high school, and there was this lecture about water molecules, how they are made, how they interact with each other in the liquid, in vapor, in the solid, how they reorganize, and I just said, wow, I want to do that. And so I've always choose the chemistry focused curriculum throughout high school and then university, and then I got a PhD, and then I work in the field. If I had to tell why, that's really hard, but I really love it.
But I mean, it started with that curiosity, and amazing you say 12. That's the age that we really need to provide those opportunities to spark that curiosity.
Yeah, I think we need. So one of the privileges I had is that I had a number of very passionate teachers and very skilled and qualified that just came to classroom, and it was just amazing to listen to them, and so I think it is really important to support education from a very early stage. I see with my children, it's really easy to get them excited about things, and you need this kind of passion in teaching, this kind of commitment to support the next generation grow.
Now, just lastly, Rafaela, if there was a message that you could share with fellows of the Academy about how to better support EMCRs, what would it be?
To listen. So I think there's no future without research, and research in any field. I'm not talking just about STEM. I'm also talking about non-STEM field. So the future, so research and education. There's no future without research and without education. And we need the voice of early to mid-career people, and also of people at an earlier stage of career, PhD students. We need the voice of the next generation to be heard and to be really at the table where decisions are made.
A great message to start off our 3 days of Science at the Shine Dome. Dr. Rafaela Demichelis, it's a great pleasure to meet you in person, and thanks so much for spending some time with me this morning.
Thank you very much.
And as we just heard, that international collaboration is critical to the way that science functions. Let's take a look at one such example.
From the air, it looks like any other farm, until you fly a little further and discover this. These are the remarkable greenhouses of China's Zhejiang University, the workplaces of some of the world's leading plant scientists. Big facilities for a big challenge.
China feeds 21% of the world population with 7% of the world land. So there is a tradition of agricultural research.
But that research now has global implications. To feed the world in 2050, we will need to increase food production by 70%. And it's not just climate change making that more difficult. High-yield food crops such as wheat and rice rely on phosphate-rich soil to grow. But soils have become increasingly phosphate deficient, forcing farmers to purchase phosphate fertilizers. That's created a raft of other problems, such as fertilizer compounds entering our water systems. The industrial scale of the process has also depleted high-quality sources of phosphate. Fertilizers are therefore becoming more expensive, meaning so too is food.
These are common problems to Australia and China and other parts of the world, and it's essential we solve them to actually maintain food production.
Professor Jim Whelan says we have taught plants to be lazy.
But in our cropping systems, we have bred plants under high phosphate conditions, so they're phosphate hungry or inefficient. What we now have to do is to go back and understand how plants can be productive with limited phosphate nutrition.
And that's what brings Professor Whelan to Zhejiang. His team at Melbourne's La Trobe University studies plants at the molecular level. Here in China, he's able to test his findings on a grand scale.
Without these facilities, we really can't translate our work. We can carry out the research, we can come up with a hypothesis, but we actually can't see will it be improved crops. So it's really been beneficial to be able to try that in a real-world system.
His research collaborator is Professor Sohui Xia. She helped pioneer the development of more nutrient-efficient rice and soybean crops. Together, they're trying to figure out how to maintain and even increase farm yields with less resources and less reliance on phosphate.
So the problems faced the food production are not limited to any one society. They are common problems to the world, and so we should work together to solve them.
Professor Whelan has been working with Chinese scientists for more than 15 years and believes cross-border relationships should always be valued.
It's very important socially. Working on agriculture and food production helps us all to understand each other a little bit more.
Let's take you straight to Science at the Shine Dome.
This occasion with you and have everybody back in the Shine Dome face to face to celebrate scientific excellence and to celebrate your election to the Fellowship of the Australian Academy of Science. It has already been a massive week for science. We've had the Prime Minister's Prizes for Science last night and the breakfast this morning, and it's not even 10 a.m. Tuesday. My name is Anna Maria Arabia. I'm the Chief Executive here at the Australian Academy of Science. I'd like to begin by acknowledging the traditional owners of the land on which we meet, the Ngunnawal people. It's upon their ancestral lands that the Australian Academy of Science was built. And as we share our knowledge, our teaching, learning and research practices, may we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. To welcome us to country and to open Science at the Shine Dome 2022, please join me in welcoming Ngunnawal elder and treasured friend and advisor of the Academy, Auntie Violet.
Thank you, Anne-Marie. Thank you so much, and what a pleasure it is to be here once again. Oh, I tell you what, I'm getting sick of this cold weather. These old bones don't run. I need warm weather, so if you scientists can do something, please do it. Wave your magic wand. But I was just talking earlier to a couple of young people. I first did a welcome for the Prime Minister's Science Award many years ago, and this young couple sat at my table, and he said, Auntie, if I win a prize tonight, I'm going to give you this. He won a prize and he gave me a gift, what he invented. And I thought it was earphones, but it's not. So I've got this gift that has been sitting in my cupboard for so many years and I still don't know what it is, so I'm going to have to bring it and get someone to sort out and tell me what it is. Because I thought it was earphones, but it's not earphones. So I might have to bring it along to Professor Jagadish and maybe he might be able to tell me. So I'd like to welcome you all this morning to the land of the Ngunnawal people. Before, I'd like to acknowledge Professor Jagadish, other distinguished guests in the room, and ladies and gentlemen. I believe a welcome to country is a traditional Aboriginal blessing, symbolising the traditional owners of the land welcome you, but it also shows respect for the first peoples of the land you're meeting on. I suppose it's a little bit about not going to someone else's home or house unless you're invited. The reason for this custom is to protect your spirit while you are here. I am a proud Ngunnawal woman as I carry my ancestors in spirit, walking into the future, teaching the next generations about the oldest culture in the world, my culture. I'd like to pay my respects to my elders past, present and emerging, and extend that respect to the other Aboriginal and Torres Strait Islander people here in the room or online. I'd also like to acknowledge you beautiful non-Indigenous people as well, here and online. And I would also like to congratulate all the new fellas, 2020, 2021 and 2022. It's been that long, thank heavens we're back face to face. So in keeping the general, once again, I'd like to welcome to the land of the Ngunnawal people, and on behalf of my family and the other Ngunnawal families, I say welcome, welcome. In keeping the general spirit of friendship and reconciliation. But I tell you what, if I've still got time, maybe or after, please come up and talk about the Uluru Statement for the Heart and the Voice to Parliament. We really, really need your support with this, the non-Indigenous people. We do not want you to walk behind us or in front of us. We want you to walk beside us and vote yes in the referendum, because I reckon the Prime Minister will go to the vote. This is just me, in November next year, but he won't go beyond November, but he won't go beyond 2024. So please learn a bit more about it, because we really want your support and we want you to vote yes in that referendum. Thank you all so much, and a big congratulations to all the new fellas. Thank you so much, Auntie Violet. It's so wonderful to have you with us again. I think you've got a vote right there. Make that too. We value your ongoing friendship and the guidance you provide the Academy all of the time. So thank you. Before I hand over to our President, may I please ask that you place your phones or any mobile devices on silent, but don't turn them off. We do encourage you to share your experience with us today and over the course of Science at the Shine Dome using the hashtag ShineDome22.
I'd also like to make a very special mention of all of our guests joining online. There is a live stream going throughout the event with exclusive content that's available to our online audience. You will have seen the marquee outside, and many will be pulled into that marquee for interviews during the breaks. So it's a really lovely way to enjoy the event if you're part of the online audience, or as a recording after this event if you're here with us face to face. We strongly encourage all attendees to practice good hand hygiene, and we've provided hand sanitizer for you throughout the venue, and also masks should you wish to wear one. For everyone's comfort and out of an abundance of caution, we're going to forego handshakes throughout the admission ceremony this morning. The lovely members of the Executive Committee and myself will be meeting with many people over the course of the next 3 days, and given there is a bit of a COVID-19 peak at the moment, we'd like to keep everyone as healthy as possible. One final note before I welcome Professor Jagadish to the microphone: official portraits of all of our new fellows will be taken during breaks today and tomorrow, and I invite all new fellows to please make their way to the Becker room. It's to the left as you come in from the main entrance at some stage today, so that we can capture your portrait and this occasion. Please now join me in welcoming President of the Australian Academy of Science, Professor Jagadish.
Thank you, Anna Maria. Thank you, Auntie Violet, for that warm welcome. And I also pay my respects to the traditional owners of the lands we meet, Ngunnawal people, and I pay my respects to their elders past and present for their contributions to our nation and our land and our waters and our space. Thank you. Colleagues, it's an honor to welcome you to the Australian Academy of Science this morning. In my first year as Academy President, I could have not asked for a better start to my tenure than our return to the Shine Dome after an extraordinary 2 years, and to be celebrating excellence with you over the next 3 days at Science at the Shine Dome. Australian scientists are among the best and brightest minds in the world. At our core, we ask questions and seek answers to understand our world better, and we look for ways to secure the future of our nation and our neighbors all over the world. Taking up this challenge isn't easy. The questions are hard, and the answers sometimes harder. So it is important to recognize outstanding achievements and inspire our upcoming generations to continue to question, innovate, and create. The admission of our new fellows is a time-honored tradition established by the founding fellows of the Australian Academy of Science and the fellows of the Royal Society of London before them. Upon admission to the Academy, and by signing the Academy's charter book, you subscribe to the following obligation. I hereby solemnly promise to promote, declare, and disseminate scientific knowledge and to serve the Academy according to its charter and bylaws. The charter book was a gift from the Royal Society and has been signed by every fellow of this Academy. Your signatures today will sit alongside those of some of the world's most esteemed scientists, and you are welcome to look through what is a significant piece of Australian history at the conclusion of the ceremony to see how deep the traditions and knowledge of this learned academy run. To officiate the formal admissions, please let me introduce Professor Jim Williams, who was a Vice President and Secretary for Physical Sciences in 2019 and 2020, and the current Vice President and Secretary for Biological Sciences, Professor Helene Marsh. Jim and Helene will announce the names of each new fellow and read your citation. I will invite each new fellow to come to the stage at the conclusion of their citation and reading to sign the charter book and receive their certificate and lapel pin. A photo will be taken on stage before we enjoy a brief video summary of your achievements. Fellows will be called in alphabetical order to come forward and join me at the charter book. The first fellow will call upon is from the biological sciences. So now I'll hand over to Helene. Helene, please.
Good morning. My name is Helene Marsh and I'm a Vice President and Secretary Biological Sciences of the Australian Academy of Science. I too would like to acknowledge the traditional owners of the lands on which we meet and work, and to acknowledge their elders past, present and emerging. We begin proceedings with an opportunity to admit 2 fellows elected in 2019 but were not able to attend the admission ceremony at that time. Professor Lynn Beazley. Lynn Beazley, AO, is a distinguished neuroscientist and the 2015 West Australian of the Year, who's made major contributions to the promotion and direction of science in Australia. She's been a champion of gender diversity and science in the classroom, in addition to shaping science policy. Lynn is also well known for promoting science and technology in the media.
It's one small step for man, one giant leap for mankind.
I was standing in my high school looking at the television along with hundreds of millions of people all over the world, and was truly inspired by looking outward rather than looking inward.
Professor David McClelland has been looking outward ever since, trying to unlock the mysteries of the universe.
A lot of the universe is dark. It doesn't emit light, so we need some other way to discover what might be on the dark side.
One such way is gravitational waves, created by violent cosmic
Professor
events.
Lynn Beazley's love for science began as a teenager when she visited the home of Charles Darwin.
I actually looked through his own microscope at his specimens, and I was hooked. I wanted to be a scientist.
She studied zoology, but then by chance attended a lecture about repairing the brain after injury.
It was a big call. People thought we couldn't do it then. It's still a hard call, but we're working towards it. And that became my life's work.
That work has focused on the regeneration of brain and spinal cord nerve cells. There's been progress, but there's one thing Professor Beazley craves to see.
If we could get nerves to grow 1 or 2 centimetres, that could make the difference of being on a respirator and having very little function, to being able to feed yourself, write your name, even drive a car. That would be absolutely awesome.
Professor Beazley was Western Australia's chief scientist from 2006 to 2013 and continues to be one of science's most passionate advocates.
One of my heroes is Sir David Attenborough. He's putting it on the line now. We have to get people on board. So scientists have to speak in simple, straightforward terms.
Just like Sir David, Professor Beazley has a fascination with biodiversity, especially in her home state.
We have 1,500 new species of flowering plants in WA we've yet to actually name.
But a species of sea sponge discovered off Rottnest Island in 2005 does have a name. Hers.
Manahini Beazleyi. It's one of the greatest honours in my whole life.
She hopes that being elected as a fellow will allow her an even greater platform to champion science.
I believe Australia has to be science central for the world, for a better planet, environmentally, economically, socially and culturally. The Academy very much is a leader in that. To play a part within that for me is really special.
Good morning. I am Jim Williams and I was Vice President and Secretary of Physical Sciences of the Australian Academy of Science when the Fellows we're celebrating this morning were elected in 2019 and 2020. Our first new Fellow from the Physical Sciences is David, Professor David McClellan. David McClellan is a gravitational wave scientist who has played a crucial role in improving gravitational wave detection sensitivity and in designing, installing and commissioning instrumentation that has underpinned the discovery of gravity waves. David.
It's one small step for man. It's one small step for man. One giant leap for mankind.
I was standing in my high school looking at the television along with hundreds of millions of people all over the world. I was truly inspired by looking outward rather than looking inward.
Professor David McClelland has been looking outward ever since, trying to unlock the mysteries of the universe.
A lot of the universe is dark. It doesn't emit light, so we need some other way to discover what might be on the dark side.
One such way is gravitational waves, created by violent cosmic events.
They cause the fabric of space and time to ripple.
First predicted by Albert Einstein, they weren't detected until 2015. The LIGO detectors in the United States included crucial components developed by Professor McClelland's team at ANU.
When this signal came in, a signal which is a billionth times smaller than the width of a human hair, we were quite astonished.
But LIGO is now even more powerful, thanks to advances in a technique called squeezing.
So I've been working on this idea of squeezing for 25 years using nonlinear optics, which is a process where you put light into crystals to change their wavelength, to squeeze the light to make one property more precise to be able to use that in a measurement.
Professor McClelland's pioneering work on squeezing means gravitational waves are now being detected more frequently.
The discovery of gravitational waves and the discovery of a new event in the universe really told us this was the beginning, not the end.
Congratulations to Lynn and David, our 2019 Fellows. We now move to the admission of the 2020 new Fellows. Professor Tim Bedding. Tim Bedding has played a leading role in establishing the field of asteroseismology, the study of stellar oscillations, where he pioneered the detection of stellar oscillations with ground-based telescopes, including the first clear detections of oscillations in sun-like stars and determining which red giants have started to burn helium deep within their cores. David. Tim. Congratulations, Tim. Please sign it. Welcome you as a fellow of the Australian Academy of Science.
For many, Dr. Annabelle Bennett spent 13 years as a judge of the Federal Court of Australia. But a law career wasn't always the plan.
My father talked me out of doing law.
For many of us, stars are a thing of awe and mystery.
We can look up at night and see these things out there. What do they do? How are they made? What are they made from? How long do they live? What happens to them when they die?
Remarkably, we can answer many of those questions thanks to the work of astrophysicists such as Professor Tim Bedding.
A star is a big ball of gas and it will vibrate and pulsate, and we study those pulsations to learn more about the stars.
Professor Bedding and his team are particularly interested in red giant stars.
When a star becomes a red giant, the core of the star contracts and gets hot enough for helium to start fusing into carbon and oxygen.
Using data from NASA's Kepler mission, they discovered that when that happens, oscillations of the star change. Given our sun will one day be a red giant and make life on Earth impossible, understanding the process is of particular interest.
And so by studying the oscillations of red giants, we were able to tell which red giants had started burning helium in their cores.
Professor Bedding obtained his PhD from the University of Sydney before taking up a fellowship at the European Southern Observatory in Germany. He returned to Sydney in 1995 and is now considered a world leader in astroseismology.
It's really exciting to know more about our place in the universe, but there's still a lot we don't know, and that's why it's exciting to keep pushing on.
Dr. Annabelle Bennett. Annabelle Bennett is an internationally recognised leader in intellectual property patent law, specialising in scientific, medical and information technology issues. As a federal court judge, also with a PhD in biochemistry, she delivered nearly 500 decisions concerning intellectual property, including patent medicines, trademarks and copyright.
Welcome you as a fellow of the Australian Academy of Science. Thank you so
much. Dr. Annabelle Bennett spent 13 years as a judge of the Federal Court of Australia. But a law career wasn't always the plan.
My father talked me out of doing law, and by process of elimination I decided to do science.
She completed a PhD in cell biology before ultimately following her legal ambitions. But Dr. Bennett says a grounding in science didn't go to waste while practicing law.
Both involve logic and analysis, so there's no real difference when things come down to it, although people assume that there is. Certainly for me, I took the same approach to both, really.
That approach saw her become a leading expert on intellectual property, both as a senior counsel and later as a judge, ruling on many landmark cases. Dr. Bennett has little doubt about the value of patents to scientific research.
If you tell us what your invention is and how to work it, society will give you a monopoly for a period of time. And I think that's a really good contract, and it's worked pretty well since they started doing this in 1623.
Her unique insights in science serve her well as Chancellor of Bond University and Chair of the Australian Nuclear Science and Technology Organisation. She has a passion for research and wishes there was a greater mainstream understanding of the process.
When you hear people saying now with the COVID crisis, people are saying, well, how can they not know? There's sort of an assumption that everything has to be worked out immediately, and how can good researchers simply not know answers immediately? I think that we don't understand, a lot of society doesn't understand the years and years of work that go into the amazing inventions that we see.
Dr. Bennett says given her primary background is the law, she's particularly honoured to have been elected a Fellow of the Australian Academy of Science.
It's also a wonderful message, I think, that goes out. The Academy is looking for direct and indirect contributions to the advancement of science. Personally, of course, I'm thrilled to bits. Well, who wouldn't be?
Dr. Wenju Tsai. Wenju Tsai is a world authority on climate variability, ocean dynamics and ocean atmosphere interactions. His work has revealed the links between climate change forcing factors and changes in the global ocean circulation, extreme climate and extreme weather, including Australian drought and bushfires. His work has led to fundamental improvements in climate simulations and climate projections. Welcome. Bye. Congratulations. I welcome you as a fellow of the Australian Academy of Science.
Australia is surrounded by 3 oceans, and temperature changes in these oceans impact our climate.
And sometimes the Pacific impact and the Indian Ocean impact are opposite, and sometimes they're superimposing. So Australia is actually a very sort of tantalizing place to study climate variability and impact.
Professor Wenju Tsai is a physical oceanographer who studies ocean and sea temperatures and how they interact with the atmosphere. He's an expert on the Indian Ocean dipole, which is the balance of sea temperatures in the tropical Indian Ocean waters. When the dipole is negative, much of southern Australia gets above average winter and spring rainfall. When it's positive, it can lead to a dry winter and spring in southern Australia, making our bushfires worse and causing problems for farmers. Meanwhile, other countries affected by a positive dipole may experience very wet weather with floods or landslides.
Many people often get displaced because of these oceanic temperature changes. Eastern is cool, Western is warm in the tropical Indian Ocean. And so these kind of events then now is used to predict the severity of Australia's bushfire season, because it has a lead time of 6 months.
A world authority on ocean dynamics and climate variability, Dr. Tsai's interest in weather came from growing up on a farm in southern China. He moved to Australia in 1986, and his research has highlighted the influence of climate change on extreme weather events.
I feel extremely honoured to be made Fellow of Australia Academy of Science. I'm thrilled that people recognize the science, the importance of the area of science that we do.
Professor Peter Currie. Peter Currie is a world-renowned developmental, evolutionary and stem cell biologist who studies the genetic basis of skeletal muscle stem cell action during development, evolution, regeneration and disease. His key discoveries utilise several animal models to define the genetic and evolutionary basis for muscle formation and growth.
Welcome you as a fellow of the Australian Academy of Science.
It's hard to believe we have a lot in common with a zebrafish, but we share 70% of the same. It's hard to believe we have a lot in common with a zebrafish, but we share 70% of the same genes as them. Even more remarkable is that 84% of human genes that cause disease are also found in zebrafish. As a result, they are widely used in scientific research to improve human health and understand diseases.
I study the science of developmental biology, which is trying to understand how organisms are put together from embryos into the adult form. And we study how different genes control that process.
Professor Peter Currie is a well-renowned stem cell biologist. He's been instrumental in developing zebrafish as a model for regeneration biology and muscle disease in people.
The progress has been immense, to the point where we can take a cell of our body, turn it into any other cell type in our body practically, and that's all happened in the time that I've been studying this amazing science of developmental biology.
Professor Currie's key discoveries include using zebrafish models to determine the genetic and evolutionary basis for muscle formation and growth in people.
We actually make animal models of muscular dystrophy, which is a genetic condition of muscle wasting, and we try to understand molecularly how that process occurs within this tissue.
This research could lead to new therapies for muscular dystrophy and for people experiencing muscle wasting, like the elderly.
Frailty is an actual physical disease, and it results from a pooping out of our stem cell populations in our muscle. So if we could rejuvenate our ability to create new muscle mass, this would also impact nearly every person on the planet.
Born with a thirst for knowledge and an insatiable curiosity, Professor Currie says he enjoys the scientific process.
I'm addicted to the process of discovery, and I'm interested in knowing the things that I want to know. That will not stop till the day I die.
Professor Aurore de Lagle. Aurore de Lagle is internationally known for her innovative contributions to mathematical statistics, where she has made transformative contributions in several statistical subfields, including functional data analysis and measurement error. Aurore.
Congratulations, Aurore.
I welcome you as a fellow of the Australian Academy of Science. Statistics are used in many aspects of our life to collect and interpret information and to understand the world we live in.
I like the fact that you can turn real-life problems into some equations, and then you just solve the equations and whoop, you have the solution and you can solve the real-life problem.
Professor Aurore de Lagle is a highly regarded statistician who analyses medical and nutritional data to help doctors understand and predict disease in patients, such as heart disease.
So we try to measure, knowing the type of food that you eat, or knowing your cholesterol level, or knowing your blood pressure, or knowing all of those, we try to construct a curve that indicates your chance of having a heart disease.
Professor de Lagle has also developed methods to reduce the impact of measurement errors. They're used by statisticians around the world and enable practical applications.
Many of the methods require the choice of what we call a tuning parameter. So that's a number that we have to choose, and it's important to choose that number well. It makes the method work or not. And I've developed a few methods for choosing that number. It's called a bandwidth, a smoothing parameter.
Born in Belgium, Professor de Lagle initially studied mathematics, but found her true passion in statistics.
I really like to be a statistician. I need to be driven by real life. I like abstract things, but first I need to start from a concrete problem.
For her contributions to mathematical statistics, she's been elected a Fellow of the Australian Academy of Science.
I'm very happy, very surprised, and it's an honor to be part of such a group of eminent scientists.
Dr. Cathy Foley. Cathy Foley has made outstanding contributions to Australian science through promoting and supporting science across the wider community, including as the first dedicated Chief Scientist of CSIRO. She has made distinguished contributions to high-temperature superconductors and to the development of field-deployable superconducting devices that locate valuable mineral deposits. Cathy.
Congratulations, Cathy.
Dr. Cathy Foley is one of our brightest minds, but in primary school, she often struggled in class.
I'm a bit dyslexic, so I ended up having to go through and be able to do things the hard way, I guess, but in the process, figured out how to create tricks and ways to be able to do the things that are necessary to learn. And then once I figured that out, things took off for me.
In a big way. While doing her PhD, she was labelled the grandmother of indium nitride.
Back then I was not that old, so it was a bit of a put down, but doing that fundamental materials work, which led to what eventually became white light emitting diodes, is something I was proud of.
It was one of many achievements on her way to becoming Chief Scientist at CSIRO. She's renowned for creating superconducting systems, including Lantum, which became a powerful tool for mineral exploration.
It's really hard to find minerals that aren't poking out through the surface of the Earth. You know, it's not like the Earth is a glass Earth.
Lantum uses superconductors to create three-dimensional maps of underground ore bodies.
Our Lantum system's now commercialised and has been used for about the last 15 years. And discovered a lot, or helped delineate a lot of mineral deposits around Australia, but also in Canada.
Dr. Foley has one of the most senior roles in Australian science, but says many women are held back by the competitive nature of the system.
If women are at a point in their careers when they're trying to build up the number of publications, and they're also at a time when they're potentially having children and raising a family, often they're not in a position to be as competitive as colleagues who aren't in that situation. And I think my challenge, I guess, is to the community is saying, do we have to do science in such a competitive way? Are we able to look at truly the way we operate, the way we work, the way we assess and decide what is merit?
She says Australia's future is tied to the quality of our science. And that means we need to learn how to recognise our best people.
Professor Gary Froyland. Gary Froyland has made major contributions to the fields of dynamical systems, ergodic theory and discrete optimisation. He has reshaped scientific views on how to characterise complex fluid flow and has also successfully applied his research to physical oceanography, atmospheric science and open pit mine optimisation. Gary.
Congratulations, Gary. I welcome you as a fellow of the Australian Academy of Science.
What does mathematics have to do with treating cancer patients?
The radiotherapy machines that are treating these patients are becoming more and more sophisticated. The algorithms that run the machines also need to be developed at a similar pace.
And that's where UNSW Professor Gary Froyland comes in. The mission for this world-renowned mathematician is to reduce radiation doses to patients while maintaining the treatment's effectiveness.
There are limitless new things to discover, and as different sciences progress, then you have different problems coming up in engineering and chemistry and biology and physics. These get passed down in some form to mathematicians to analyse. So there's always a rich source of new material.
Professor Froyland's work has impacted a wide range of industries. His research has helped to optimise the planning of open pit mine projects around the world.
Almost all of my collaborators are overseas. We don't need laboratories. All we need really is to talk to one another. So mathematics lends itself very much to international collaboration.
But his interests extend well beyond industry optimisation. He's just as curious about the complex nature of our climate.
The wind today is different to the wind tomorrow. In fact, the wind, 6 hours later, the wind has changed.
Despite that, Professor Froyland managed to develop a dynamic map of global ocean flows, shedding light on the fate of plastic and other floating debris.
One of the reasons mathematics is important is because it lets you get at the heart of how things work. You always get to learn new things, you get to discover new things, you get to work with brilliant people, and you get to make the world a better place.
Professor Kevin Galvin. Kevin Galvin's research is in the field of mineral processing, where he has made seminal contributions to the behaviour of fine particles in laminar shear flows. His research led to the invention of the reflux classifier, an innovative separator for recovering and concentrating high-value minerals such as iron ore, chromite, coal, manganese and lithium. Kevin.
Congratulations, Kevin. I welcome you as a fellow of the Australian Academy of Science.
Professor Kevin Galvin is a renowned innovator.
I'm a scientist, I'm an engineer, but I'm also an inventor.
And it was this invention that's now helping to transform mining. Called the reflux classifier, it's capable of recovering valuable minerals from waste materials by separating them through gravitation.
This is the boycott effect, and if we tilt, we get a dramatic improvement in the rate of settling. So we can exploit that on a large scale by replicating those inclined channels across a large space. And what that does is it creates the hydrodynamic environment for imparting the forces that we need on the particles to affect the kind of separation that we're after.
The classifiers are now being deployed around the world and have the potential to save the sector billions of dollars.
It's the application and the impact in this particular area where material was previously a waste stream, creating a tailings dam, for example. You are now securing additional resources, reducing water consumption, energy consumption.
Professor Galvin got his first job at the age of 18, working in the research laboratories of BHP. He's seen plenty of changes since then, including an increased focus on making mineral processing more energy efficient.
People want copper for electric vehicles, they want copper and rare earth magnets for wind turbines and so forth. If you're going to be able to do all of those things, you do need to reduce that environmental footprint.
Professor Galvin continues to undertake world-leading research at the University of Newcastle, where he encourages students to find innovative ways to achieve zero-emission mining.
Be prepared for a lot of hard work. You may well succeed, and you may well transform the whole way in which people think about things or the way people do things.
Professor Kate Jolliffe. Kate Jolliffe's research is in the fields of supramolecular and organic chemistry, where she has made world-leading contributions to organic synthesis, anion recognition, and molecular self-assembly. Her transformative achievements include the development of selected receptors for pyrophosphate and sulfate ions, and new methods enabling the synthesis of macrocyclic peptides. Kate.
Congratulations, Kate. I welcome you as a Fellow of the Australian Academy of Science.
Every cell in your body is replaced every 7 years. But what happens when that process doesn't work? Apoptosis, or the orchestrated deaths of cells, plays a pivotal role in many diseases. Too much apoptosis, for example, can contribute to degenerative diseases, while too little can lead to cancer because of damaged cells that won't die when they're supposed to. So scientists spend a great deal of time studying the process as the first step in developing treatments. And now they have a powerful tool, thanks to the work of supramolecular chemist Professor Kate Joliffe.
One of the things that we've done recently that's really exciting is our design of a molecule that can detect when cells are undergoing cell death.
The system relies on the fact that the inside and outside layers of cell membranes display different molecules.
The ones that are on the inside have a negative charge, and when your cells are dying, that negative charge flips to the outer layer of the membrane, and we can then detect those with a molecule that lights up effectively like a light bulb turning on when it sees those molecules and shows that the cells are undergoing death.
In other words, scientists can watch apoptosis in real time using fluorescence microscopy.
One of the beauties of chemistry and synthetic chemistry is the ability to create a molecular structure that nobody's ever made before, which is kind of neat.
Her research has many applications, and not just in medicine.
The species that we look at, anions, are present everywhere. They're in industry, they're in the environment, and they're in biology. So being able to detect those has applications across all of those, from detecting pollution through to diagnosing disease.
Professor Jolliffe's obsession with chemistry began not in the lab, but the kitchen.
I did work experience in the Women's Weekly Test Kitchen, and then the following year I did work experience in an analytical chemistry lab. And I realised that I was more intellectually stimulated in the lab than in the kitchen, but I still love cooking. That's my plan B.
Not that she'll need it anytime soon. Professor Jolliffe is internationally recognised for her contribution to science.
I'd absolutely recommend a career in science. It's always interesting. It's often exciting. I'm a supramolecular organic chemist, but I could easily have been a different type of scientist and worked on a whole range of different problems. There's so many things to do.
Professor Pinkoy Lam. Pinkoy Lam has an international reputation in secure quantum communications and quantum state generation. He was the first to demonstrate successful end-to-end quantum key distribution in Australia and established a globally recognised web server for quantum random number generation. Pinkoy.
Congratulations, Pinkoy. Please take the pens inside. I welcome you as a Fellow of the Australian Academy of Science.
We live in a digital world where nearly all of our personal information is stored online. But data breaches happen almost daily, exposing sensitive information like passwords and credit card numbers that can lead to identity theft. Now scientists have developed quantum encryption to try and stop it happening.
Quantum encryption is the ultimate form of encryption. It is essentially an unbreakable code.
Professor Ping Koi Lam is a quantum physicist, and his research has enabled the development of new and secure quantum technologies. And he was the first to successfully design quantum key distribution in Australia.
My research at the ANU has shown a beam of laser light can be used to quantum encrypt information. Conventional encryption relies on mathematical complexity. So if you have a very powerful computer, you'll be able to perhaps break the encryption.
Professor Lam's research into quantum random number generation is used to develop secure networks. He was also involved in setting up Quintessence Labs to commercialise the technology.
Random number generation is a very important component of information technology. Random numbers are used in computer modelling and also in generating encryption keys.
Born in Malaysia, Professor Lam moved to Australia in 1993 and says he always wanted to become a scientist.
When I was young, I have already made the decision that I want to be a physicist so that I can witness firsthand the really weird and wonderful predictions and phenomena quantum physics has.
Professor Ryan Lister. Ryan Lister is a genome biologist who's made major advances in our understanding of the epigenome, the molecular code superimposed upon the genome that can regulate the readout of the underlying genetic information. His work is driving advances that will provide benefits to agriculture, human health and medicine.
Congratulations, Ryan. Please. I welcome you as a fellow of the Australian Academy of Science. Thank you very much.
Our epigenome helps explain who we are as individuals. It's basically a set of chemical modifications to cells, which can alter gene expression. And while our DNA code remains fixed, the epigenome is dynamic and can be influenced by things such as lifestyle.
The epigenome plays really critical roles in the identity of a cell, the cell's form and function.
Professor Ryan Lister generated the first comprehensive maps of the human epigenome, and they revealed something stark.
We found that the epigenome in neurons in the human brain changes enormously during childhood as the neurons in the brain matures.
That means it has a big impact on our ability to learn. We also know that changes in the epigenome can influence immune responses. Given its power, Ryan Lister has set his mind to creating molecular tools that can edit it.
This will have important roles in a diverse range of areas, from regenerative medicine to manipulating plants for better agricultural outputs to understanding the epigenetic basis of disease.
Professor Lister established his world-renowned research group at the University of Western Australia in 2012. Their work is considered vital in understanding what makes us tick.
I find science and discovery inspiring because it literally creates the future. We see all around us the technologies and the advances that are made through research, through science, and you realise just how it creates the world of the future.
Professor Justin Marshall. Justin Marshall's research has made fundamental contributions to sensory neuroscience and ecology, including the discovery of the world's most complex colour vision system, the first demonstration of sensitivity to circularly polarised light in any animal, and discoveries defining modern visual ecology in both vertebrates and invertebrates.
Congratulations, Justin. Please sign. I welcome you as a fellow of the Australian Academy of Science.
The mantis shrimp has the most sophisticated eyesight of any animal on Earth.
We have 3 colour receptors, red, green and blue. Mantis shrimps have 12 channels of colour.
They can also see polarised light and 4 different channels of ultraviolet light.
The mantis shrimp's vision has enabled us to redesign satellites, to store more data on computers, and is now helping us to detect cancer quicker than we possibly could have done beforehand.
Professor Justin Marshall is a marine neuroscientist who studies how animals see colour. Lured to Australia by the beauty of the Great Barrier Reef 30 years ago, he enjoys understanding how animals see and experience their world.
We run what are called behavioural experiments, where we train the fish to do something, or we train the mantis shrimp to sometimes literally jump through coloured hoops. And if they jump through the red hoop, they get food. If they jump through the blue hoop, they don't get any food. And they very rapidly learn that the red hoop is the right one to jump through.
Professor Marshall's discovery of the world's most complex colour system has led to bio-inspired engineering. He was inspired by his parents, who are marine biologists, and who he joined on expeditions around the world.
My father was Her Majesty's Curator of Fish at the British Museum of Natural History, so he was the fish guy. If Her Majesty wanted to know what her fish on her plate was, she could phone him up and ask him.
Professor Marshall is also a passionate conservationist and runs Coral Watch, the world's most widely used citizen science program for coral health.
And getting out and looking is a really important way of understanding the world around you. And that's what citizen science does. It encourages people to get out, look at the forests, look at the birds, look at the reef, and understand nature.
Professor Andrew Harvey Miller. Harvey Miller's discoveries underpin our understanding of respiratory damage during plant cell ageing and disease. He discovered biochemical mechanisms through which plant respiration is adapted to cellular processes and harsh climates, and identified how damage by lipid, oxygen and nitrogen radicals lower the efficiency of respiration.
Congratulations, Harvey. I welcome you as a fellow of the Australian Academy of Science.
It was a surprising discovery. When it rains, a plant's reaction is close to panic. As water lands on the plant, thousands of genes spring into action, inducing a plant protein to kickstart a range of protective effects. The Chain reaction was observed by an international team of scientists, including plant biochemist Professor Harvey Miller. He says rain is the leading cause of disease spreading between plants because ricocheting droplets contain bacteria, viruses and fungal spores. So he says they have every reason to panic. It's just one of many unique insights offered by Professor Miller, who has a genuine passion for understanding plants.
And that's really because of an interest in gardening and an interest in science and trying to find some way of actually merging those two things.
His main research focuses on mitochondria, the powerhouse of a plant cell, and the role of metabolism in the energy efficiency of plants. His team recently discovered how plants change their rate of respiration at night.
And this is important because plants only have a certain amount of food effectively at night to eat.
Successfully modifying that process could have a big impact on our future food needs.
And so we're part of that information chain to ultimately produce ideas that breeders can implement, which farmers can grow, which people eat.
Professor Miller says that's the beauty of science, uncovering evidence-based solutions to complex problems.
There are things that we can learn which are above simply your and my opinion. And these things are going to drive not only good outcomes for us, but good outcomes for everybody if we base it on real facts.
Professor Lydia Moravska. Lydia Moravska's diverse research involves groundbreaking applied studies in the areas of radiation physics, environmental physics and atmospheric physics. She's recognised as a foremost authority on airborne particulate matter in the context of atmospheric pollution and its sources, as well as its impact upon human health and the environment. Lydia.
Congratulations, Lydia. I welcome you as a fellow of the Australian Academy of Science.
Air pollution kills around 7 million people every year worldwide.
It's incredible. It's something which we don't realize at all because we are used to pollution, but that's the reality of the risk.
In January 2020, Melbourne and Canberra's air quality was rated among the worst in the world as bushfires burned along the east coast of Australia. It was a small taste of what life is like in many densely populated cities.
Pollution in Australia is much lower than anywhere else in the world, not necessarily because we do things better than other developed countries, but because of the low population density.
Professor Lydia Moravska is a physicist who has been studying air quality for almost 4 decades. She is also an advisor to the World Health Organization that works with countries to monitor and improve air quality. Her team also designs and builds low-cost solar-powered sensors to monitor air pollution.
I work in a very multidisciplinary field of air quality and its impact on health and the environment. Our specific focus is on airborne particulate matter, particles in the air. Well, you don't see them, you don't think much about them, but this is a very important and very diverse field.
More than 80% of people living in urban areas are exposed to dangerously high air pollution levels.
The range of impacts is enormous. There's basically hardly an organ in our body which is not affected due to pollution.
Born in Poland, Professor Moravska says she always dreamed of being a scientist.
I developed interest for physics, and that was nuclear physics. And I knew from, grade 4, grade 5, that I'm going to be a physicist.
Now she's a leading expert on atmospheric pollution and has just been elected a Fellow of the Australian Academy of Science.
Professor Robin Owens. Robin Owens has an exceptional record of innovation and computational vision science, including groundbreaking fundamental theory in feature detection and object recognition, and applying these theories across diverse disciplines, from biomedical science through to face recognition. She also has outstanding achievements in research training and research policy development. Robin.
Congratulations, Robin. I welcome you as a fellow of the Australian Academy of Science.
From airport security to our smartphones, facial recognition software is now commonplace, but getting computers to recognise images was far from simple.
For such a long time, everything had seemed so confused and jumbled, and then all of a sudden, the whole world seems very simple because you've seen how it connects together.
Professor Robin Owens played a key role in those early breakthroughs.
My training was in pure mathematics, but my first job after my doctorate was working on a robotics project, and that's when the world first began attaching cameras to robots to see the world around them.
She says the biggest challenge was getting computers to process features such as edges.
This was really important for understanding what was making up the scene around them.
Professor Owens says a lot of that work was theoretical, but applications have proved endless. She warns, though, there should be limits.
It's absolutely essential that science works hand in hand with the humanities and has a very strong ethical background for all the things that it discovers.
Professor Owens recently retired as Deputy Vice-Chancellor of Research at the University of Western Australia, but sees her election as a Fellow of the Australian Academy of Science as a way of continuing to make a contribution.
Science, I think, has been at the forefront of most of the major recent revolutions in human development. It matters because it can improve the welfare of humans, it can change the world around us, it can make the world a much better place.
Professor Ian Paulson. Ian Paulson is a world leader in microbiology and a pioneer in microbial genomics. He discovered several novel classes of multi-drug efflux pumps that can make bacteria resistant to multiple drugs, and showed that these pumps have natural roles in the cell and have been opportunistically co-opted by hospital pathogens as a resistance mechanism against antibiotics.
Congratulations, Ian. I welcome you as a Fellow of the Australian Academy of Science.
Picture this. The world's cars fueled not by crude oil, but by the waste products of sugar processing. It's just one of many goals for Professor Ian Paulson, who works at the cutting edge of synthetic biology.
What we hope to do with synthetic biology is build designer organisms that can turn waste products into plastics, into chemicals, into fuels. So synthetic biology is a new science that sort of combines an engineering mindset with molecular biology techniques.
Professor Paulson leads the ARC Centre of Excellence in Synthetic Biology. The team has a big mission to create a new bio-based economy, delivering world-changing solutions.
Commercially, this is a multi-trillion-dollar global market in the future, and Australia has great potential in this area. We're a nation rich in biomass. with a long history of excellence in agriculture.
He believes the biological systems the team is creating have the potential to rejuvenate regional Australia while turning agricultural waste into everything from bioplastics to pharmaceuticals. It's almost the stuff of science fiction. It's perhaps not surprising then that as a teenager, Ian Paulson was heavily influenced by John Wyndham, author of The Day of the Triffids.
But I was inspired by a particular book he wrote called Trouble with Lichen, where the main character is a microbiologist and comes up with a discovery with world-shaking results, and that inspired me to want to become a microbiologist.
Professor Paulson is also a gamer. He says strategy gaming can help his work.
It develops a sort of problem-solving mentality, and so you can apply that mentality to science and try and work out strategies to achieve your goals.
The need for strategy in solving problems is something he impresses on his students. Although he isn't required to teach in his current role, he enjoys it and considers it vital.
I see an important part of my legacy is teaching and inspiring the next generation of scientists who, after I'm done and gone, will then go on to be, make great discoveries and do important things for the world.
A logical approach for a scientist with a vision for the future.
Dr. Simon Poole. Simon Poole is an outstanding researcher and entrepreneur in photonics. He was a member of the team which developed the erbium-doped fibre amplifier, now a ubiquitous part of the optical fibre networks that underpin the global internet. He has also led the establishment of an export-competitive photonics industry in Australia. Simon.
Congratulations, Simon. I welcome you as a Fellow of the Australian Academy of Science.
Optical fibre networks underpin the way we communicate and access information.
For example, during the recent lockdowns, if you can imagine what it would have been like without video on demand, without Zoom meetings, all of those things are enabled by optical fibre networks.
The fibres transmit data from one place to another by sending pulses of infrared light. But in order to travel long distances, they need something else.
As light propagates through an optical fibre, it loses some of its power and eventually becomes too weak to be able to detect. However, if you can put in there an optical amplifier, which is equivalent to like an electronic amplifier but works for light, then you can keep boosting that signal up and send it much further distances.
Dr. Simon Poole was part of the team at the UK's University of Southampton that created the erbium-doped fibre amplifier in the mid-1980s. It was a game changer, reducing the cost of long-distance fibre systems.
There are now millions of these optical amplifiers around the globe in every network, in every optical fibre network that exists out there.
After moving to Australia, Dr. Poole founded the Optical Fibre Technology Centre at the University of Sydney, and later the Australian Photonics Cooperative Research Centre.
What really inspires me about science is not just science for science's sake, but taking that science and turning it into something useful.
He describes himself as more of an entrepreneur than a scientist these days, backing startup companies as they commercialise ideas born in labs.
And it's that process of taking an idea and then proving it out into the marketplace and selling and creating companies based on that that really excites me about science.
It was the same thinking that drove his work in optical networks, the pursuit of advancing our common knowledge for the sake of humanity.
Without that, we would still be working at a subsistence farming level. We wouldn't have the high degree of technology, the high degree of travel, the high degree of communication and the quality of life that we do these days.
Professor Andrew Roberts. Andrew Roberts has conducted groundbreaking research that has delivered ventoclax, a novel drug for blood cancer patients. Venetoclax is approved in Australia and internationally for chronic lymphocytic leukemia and for acute myeloid leukemia in the United States.
Congratulations, Andrew. I welcome you as a fellow of the Australian Academy of Science.
Blood cancer is one of the deadliest cancers in Australia, with more than 15,000 people diagnosed each year. And clinical haematologist Professor Andrew Roberts' research into how cancer cells stay alive has helped in the development of a new drug called Venetoclax, which is being used to treat chronic lymphocytic leukemia.
The big discovery that my colleagues and I made was that you could kill leukemia cells both in the test tube and in people. And this drug was discovered and developed by international pharmaceutical companies based on a discovery made here in Melbourne about 30 years ago.
That discovery found that a protein called BCL2 helps cancer cells survive indefinitely. But after Venetoclax treatment, which targets BCL2, the cancer cell dies.
The way this drug works is that it causes the leukemia cells to kill themselves. And so the leukemia will melt away in people whose cancer is susceptible to it. This drug isn't going to be a cure, but it certainly gives many people another chance.
More than 30 years in the making, Professor Roberts says the groundbreaking discovery was a massive team effort.
It's an amazing feeling when it becomes clear that a patient has benefited from a drug that you've been involved in developing. And for me, that's been incredibly rewarding. In fact, just inspires me to keep going and try to do better.
Dr. Jenny Stauber. Jennifer Stauber is an international leader in ecotoxicology, particularly metal contaminants in aquatic environments. She's invented a range of new risk assessment protocols that are applied worldwide in research programs, industry and government, including the National Water and Sediment Quality Guidelines for Environmental Regulation in Australia.
Congratulations, Jenny. I welcome you as a fellow of the Australian Academy of Science.
The Great Barrier Reef's battle with heat stress is now well known. Recent mass bleaching events have offered stark evidence of the threat it faces. But rising temperatures aren't the only challenge.
Manganese is really common in the environment. It's a common metal. It's found in soil and water and sediments. And it's usually thought to be not very toxic. But what we've been finding is that manganese can actually cause not the corals to bleach, but rather the whole tissue of the coral, the polyps, slough off the surface of the coral, leaving just a bare, exposed coral skeleton.
Manganese is often found in mining effluent. CSIRO's Dr. Jenny Stauber
has been investigating coastal lagoon environments to determine the amount of manganese that causes damage.
Once we've done those experiments, we then want to set a guideline, an environmental guideline for manganese, so we know at what concentration of manganese there'll be a risk to those adult corals.
It's the kind of experiment Dr. Stauber has conducted regularly across her almost 40 years as an eco-toxicologist.
We need to have these guidelines that are just the right balance between sustainable industry development and protecting our environment.
She says the volume of pollutants going into our oceans and waterways has decreased over her career, but there are now emerging contaminants that weren't considered previously, such as personal care products.
We can also use new tools such as environmental DNA or omics techniques, and that allows us to take DNA out of sediments and then see whether the biodiversity or those communities have changed in the water body along a chemical contamination gradient. So we've got all of these new tools now that we didn't have before, and we can use them all together in a sort of different lines of evidence in a weighted evidence approach to assess risk of contaminants.
Dr. Stauber knows her work is making a difference and says that's the value of science.
It's really a rewarding career to have, and I think you're actually doing some good. You know, you're actually improving the situation for the generations to come.
Congratulations to all our new fellows. I now invite Professor Janapati Jagadish to the microphone to provide the President's address.
Thank you, Jim and Helene, and congratulations and to welcome to our 2019 and 2020 new fellows. As I stand here today, officially welcoming our 2019 and 2020 fellows to the fellowship, I cast my mind back to 2005. 2005 was the year that I stood where you all are now and made my own solemn promise to promote, declare, and disseminate scientific knowledge and to serve the Academy according to its charter and bylaws. 17 years later, I look back on that day and reflect on the importance of upholding that promise now and more than ever. Historically, the Academy has been a symbol of scientific excellence, delivering on recent remit to advance Australian science and showcase excellence at home and abroad. The Academy has always been a trusted source of evidence-based counsel. It has been science that has propelled our community forward, whether through medicine, technology, defense capability, environmental studies, and so much more. There is not one part of our history or our future that is not touched by science. This is as true today as it was on the foundation of the Academy in 1954. We need only to look over our shoulders at the past 3 years and the advent of COVID-19 to see the importance of science in everyday life. It was science that illuminated a pathway through the pandemic, and it will be science that will help us to navigate into the future. In my youth, studying by the light of a kerosene lamp in India in a small village, I had no idea that my love of learning would one day see me standing here in front of you. But I am thankful that it did. It is wonderful to be in the company of so many with the same passion for science and love of learning, and it is not only our responsibility, but it's also our privilege as fellows of the Australian Academy of Science to extend that joy for the benefit of all and to celebrate, promote, and honor science as a keystone of each and every community. Today is a reminder to all fellows, old and new, of our commitment. This is a promise that we make as fellows, and I encourage you to engage with the Academy to pursue this cause. There are many opportunities to engage, including through the Academy's National Committees for Science, sectional and award committees, and through regional and state and territory-based activities. The latter, in particular, is an area that we are looking to grow, and we welcome your thoughts, insights, and ideas on ways the Academy can support you to champion science in your region. Many of you have already made significant contributions in the few years since your election, and for that I thank you, and I look forward to working with you for many years to come. We will now watch a short video on ways you can be involved in the Academy.
Congratulations on your election as a Fellow of the Australian Academy of Science. You join approximately 590 Fellows who represent excellence in science. A good place to become familiar with the activities of the Academy is through its annual report, released at the AGM in May each year. You can download a copy by scanning the QR code on your screen. The governance structure of the Academy includes 17 Fellows on Council, and among them 7 Fellows on the Executive Committee. ExCom, as it's known, includes the President, the Vice Presidents, who are the Secretary for Physical Sciences and the Secretary for Biological Sciences, Foreign Secretary, Secretary for Science Policy, Secretary for Education and Public Awareness of Science, the Treasurer, and the Spokesperson for Integrity. The Fellowship team collects and maintains all the information about Academy Fellows, including the database, personal records, obituary notices, biographical memoirs, website profiles, and other material. It's very important to keep your information up to date. Let the team know if your contact details change, or if you move into a new position, and also about any significant award or prize you receive, as they are publicly acknowledged by the Academy. To update the team, email fellowship@science.org.au. The Fellowship portal on the Academy's website is where most confidential information is located, including the AGM papers, Council papers, updates from the President, the place to pay your annual subscription, and the Fellowship election material. There are many opportunities for you to engage with Academy activities. These include nominating and assessing candidates for Fellowship and the Academy's awards, serving on Council or committees of Council, joining the Reconciliation Action Plan Working Group, contributing to policy and international work, engaging with Fellows in your region or state-based activities, consulting for the Academy's education programs, national committees, which are made up of Fellows and other experts within a field and help to steer engagement with their research communities and connect to the international science unions. Every day, the Academy publishes scientific information on its social media channels with over 2.4 million followers to engage, inform and influence. The information can be in the form of short articles, videos and images with detailed descriptions. Fellows are involved in the review of content and in providing scientific material that may be used. If you have questions about any of these opportunities, please get in touch by emailing fellowship@science.org.au. We're looking forward to working with you to make the most of your election to the Australian Academy of Science.
This video can be found on the Fellows portal, which you can log into on the Academy's website. The Academy is its Fellows, and I know I speak on behalf of my colleagues on the Academy's Executive Committee and Council, and also Anna Maria, when I say that our doors are always open. And I will end by offering once again my heartfelt congratulations and welcome our 2019 and 2020 Fellows, and thank you to everyone here today for joining us to celebrate. We'll be hosting a cocktail reception from 6 p.m. this evening in the Marquee near the recently restored Ian Potter House. I invite you all join us for celebratory drinks. It promises to be a lovely evening, though it is a little bit chilly in Canberra, though we didn't anticipate that. So I now invite Anna Maria to introduce key staff members to close this morning's ceremony. Thank you and good morning.
Thank you, Jagadish, and to our 2019 and 2020 new fellows. Although we're celebrating your admission today, you've been part of the Academy now for the last couple of years, and we've had an opportunity to work with many of you as we've traversed the pandemic years, and we thank you very much for your contribution to date. I'd like to extend my congratulations to you all on your election to the Australian Academy of Science, and I'd like to take this opportunity to introduce you to our senior management team. So come forward.
Chris Anderson, I'm Director of Science Policy.
Andrew Hood, I'm Head of IT.
Good morning, I'm Claudette Baitup and I'm the Director of Education here at the Academy.
Thank you. I'm Nancy Pritchard and I'm the Director of International Awards and National Committees.
Thanks, Nancy.
Good morning, I'm Melissa Abberton. I'm the Academy's Chief Operating Officer.
Hi everybody, my name is Petra Lundgren and I'm the Director for Future Earth Australia, which is hosted by the Australian Academy.
Good morning, I'm Paul Richards, Director of Communications and Outreach.
And I'm Zach Girardello, Director of Diversity and Inclusion.
Thank you ever so much. We do encourage you to stay in touch or indeed visit staff at Ian Potter House at your convenience. There is a Fellows Lounge available to you there. So if you're in Canberra, even if it's not on Academy business, do pop in. You can leave your suitcase there. There are meeting rooms for you to use, a coffee machine, and I know how much staff love seeing fellows. In fact, in our annual staff survey, they often report that it's one of the highlights of their job, and indeed it's one of the highlights of mine. So please do pop in. This really is your home. The Academy is its fellows, so both the Shine Dome and Ian Potter House are available to you. As we draw the admission ceremony to a close, I ask that all 2020 fellows meet in the foyer for a group photo. And I'd also like to remind you to make your way to the Becker Room to have your official Academy portrait taken whenever is convenient to you over the next couple of days. But after that, please enjoy lunch, which is being served in the Jaeger Room just outside of this theatre, and in the Dorothy Hill Room and the marquees outside, hoping that the sun has warmed them up. For those with dietary requirements, I invite you to the Dorothy Hill Room where options will be available for you there. Please do make the most of this beautiful space, both indoors and out, and have a lovely afternoon. We'll see you again this evening. Thank you.
One person needs to introduce, and Karen, please introduce yourself.
Oh, Karen, sorry. Hello, I'm Karen Holt. I'm the Fellowship Director and also the Director of the Archives. Thank you.
Thank you.
The future is the great unknown. One day, we'll turn our plastic problems into worm food.
We're doing that.
The best time to own the unknown is now. The University of Queensland.
Curiosity, collaboration, and courage to think outside the box are at the core of science and technology in defence. From developing high-tech capabilities to creating new technologies, defence researchers are at the forefront of our scientific advancement. We aim to inspire the next generation of scientists, researchers, and engineers. And our collaborative partnerships help solve some of our nation's biggest problems and protect our way of life.
Science matters to all of us.
We're living in science. We're a world that's driven by science.
A world without science would be a desolate sort of place.
No technology, no electricity, no travel, no planes, no medicine.
A good scientist is someone who can ask a really good question. Once you've answered it, it will have an impact on all sorts of other fields.
With science, you're trying to uncover something no one else has ever managed to discover.
I think the moment of discovery is a really interesting moment. The point where you realise that you're studying something that could be profoundly interesting and you can almost taste the discovery.
It's the biggest buzz you can imagine, the aha moment, that, oh my God, we've got it.
We live in a world of extraordinary challenges. The solutions to those challenges are more science and technology, not less.
If the public have a deeper understanding of science, that allows them to make more informed choices about the way they live their lives, the way they interact with the planet, and being healthier, which ultimately impacts their families and their communities.
The future doesn't happen to us. We get to decide it. Those decisions will be about how we best use technology and science to solve the very many problems that are facing us.
We have come a really long way in scientific discovery and innovation over the last 100 years, even in the last decade. But there is still so much that we don't know.
The beauty of the universe.
Understanding the basic building blocks of life.
The beauty of how things work.
With science, you can solve problems. With science, you can make discoveries that none of us could ever have imagined.
Hello, I'm Paul Richards, the Director of Communications and Outreach. Welcome back to Science at the Shine Dome, here in front of the beautifully sunny and shiny Shine Dome here in Canberra. We're also thrilled to officially welcome fellows elected in 2020. Our audience here at the Shine Dome is breaking for lunch, so feel free to grab a bite yourself while we hear from a special guest. Professor Lynn Beazley is the former Chief Scientist of Western Australia. She's now the Secretary for Education and Public Awareness of Science at the Academy. Take a look at her story.
Professor Lynn Beazley's love for science began as a teenager when she visited the home of Charles Darwin.
I actually looked through his own microscope at his specimens and I was hooked. I wanted to be a scientist.
She studied zoology, but then by chance attended a lecture about repairing the brain after injury.
It was a big call. People thought we couldn't do it then. It's still a hard call, but we're working towards it. And that became my life's work.
That work has focused on the regeneration of brain and spinal cord nerve cells. There's been progress, but there's one thing Professor
If we could get nerves to grow 1 or 2 centimetres, that could make the difference of being on a respirator and having very little function, to being able to feed yourself, write your name, even drive a car. That would be absolutely awesome.
Professor Beasley was Western Australia's chief scientist from 2006 to 2013 and continues to be one of science's most passionate advocates.
One of my heroes is Sir David Attenborough. He's putting it on the line now. We have to get people on board. So scientists have to speak in simple, straightforward terms.
Just like Sir David, Professor Beasley has a fascination with biodiversity, especially in her home state.
We have 1,500 new species of flowering plants in WA we've yet to actually name.
But a species of sea sponge discovered off Rottnest Island in 2005 does have a name. Hers.
Manahini Island Beasley-I. It's one of the greatest honours in my whole life.
She hopes that being elected as a fellow will allow her an even greater platform to champion science.
I believe Australia has to be science central for the world, for a better planet, environmentally, economically, socially and culturally. The Academy very much is a leader in that. To play a part within that, for me, is really special.
Well, Professor Lynn Beasley joins me now here at the Shine Dome. Hello, Lynn. It's so great to see you.
Good morning, and a lovely sunny day in Canberra.
It is gorgeous. Yeah, all the wind and the storms of yesterday have blown away and the sun's come out. It's gorgeous. Tell me, you've waited 3 years for the moment that you just enjoyed. What was it like finally to sign the charter book with all that history?
It was so exciting. I missed it in 2019. I was actually on a delegation to Israel, another place where science and innovation are so important in the world. So for me, then COVID cut across for 2 years. So it's just been one of the most exciting moments of my life. I didn't realise just how important and meaningful it would be to stand here this morning. And as I stood beside the many recipients who came through, I know they felt exactly the same way. It's very special, a great honour and a privilege, but a challenge too, because we've got a lot of work to do in science to make sure we have a better future. So I think we're all embracing that.
Yeah, I hear that a lot from fellows that I speak to, both about the honour but also the responsibility that comes with the fellowship. How does that play out for you? How do you respond to that sort of challenge of the responsibility you have?
Well, for me in particular, because I'm Secretary E, that means education and public awareness, and they're both issues so close to my heart. So education, my gosh, primary connections, that influenced a whole generation and continues to do so. We have a wonderful education program online, reaching out across the country. My heart is so much in the rural, regional, remote areas. So important that they are included and giving the opportunity to our next generation. So for me, that's a thrill and an honour. Again, as I say, a responsibility. In terms of communication, when I was the Chief Scientist of Western Australia, my motto was do science, translate science, communicate science. And if you don't do the communication bit, you really haven't completed any exercise in science, I believe, because you have to share it with your fellow professionals so they can build on your discoveries. Maybe they might find some holes occasionally that they can then fill and build on, but they might lead to a much bigger discovery. But as important as that, and perhaps more important, is engaging the public, because really we have the future in the hands of this generation and generations to come, and unless they can make wise decisions about science, ones that they hold not only in their head but in their hearts, then we are not doing the job that we need to do.
Yeah, well, one part of the community, the general public, might influence another. And so it's really important not only for their own scientific literacy and understanding of issues within science, but also they can have an impact on other people who need to hear those messages.
Exactly, including in politicians. And I think this is what's so important, that the Academy's role is also working with those decision makers throughout the country, both here in Canberra and at a state level. And that influence that the Academy has should never be underestimated, but it must must be backed up with us reaching out to the public, because you need that appreciation of science. Everybody votes once they're over 18. If you're in New Zealand, it might be 16 soon, we'll see. But we have to make sure that people are well informed to make decisions that are going to influence their lives, but not only theirs, but their kids and generations to come. We're at such a pivotal point in the future of our planet. And science means that we have to communicate from the Prime Minister, who was at the wonderful Prime Minister's Science Awards yesterday, and many fellows of the Academy received awards there. Absolutely, they deserve them, it was wonderful, but right through to talking to the entire community, whatever that age group.
Do you think one of the challenges we need to overcome is around how science really is for everyone it impacts us in our daily lives, but also can be appreciated and understood on a range of different levels? I mean, when I came to work at the Academy of Science, I like to think of checking the weather as interacting with science. It's as simple as that. You know, that's not a very high bar to clear in order to gain an appreciation of, well, we need this data and someone's worked out how to measure these things and it impacts my life. I mean, it's simple as that, isn't it?
It is. It's a great example. The most commonly used website in Australia is Bureau of Meteorology. You need, as you say, physicists and mathematicians to do that. Can I tell you about an outreach story that I did in Broome in Western Australia? So we were reaching out, particularly to get girls in Year 9 to see STEM as careers. We talked to boys and girls because it's important to be inclusive, and we had a team with us, and one of them was one of the 4 meteorologists for the Royal Navy. And I'd already asked how many people would like to be mathematicians. Hardly any hands went up. When I said how many would like to be, say, deciding whether a helicopter would fly into a dangerous situation, whether a fleet of our craft would go into a particular ocean situation, nearly every hand went up. And I said, well, that needs maths and physics. The person who was sharing that story was in full whites because we were in a tropical situation, and it was a lady who was 8 months pregnant. That message got through. I would love to go back to that class and see how many more are doing science. But every day almost, because it's been one of the great things driving my life to reach out to young people, to live and learn and love science, and that is people coming up to me and saying, I had one this morning, my daughter's doing science because she heard you. That is gold for me.
And it actually goes back to the point you made before about the importance of communicating science. We need the role models speaking up and saying, no, you can do it too.
Yes, and we need role models in the Academy. How wonderful that we are so diverse in the fellows who are coming on board. Of course, this time, for the first time ever, we have 50% of all the new fellows are women. That's marvellous. But we reach across. So many nationalities are represented here, so many cultural backgrounds. Diversity is so close to our heart, and we are living it and showing it every day. Every one of the fellows that I saw joining this morning will be role models already, but that will be amplified by being a fellow. That's the extra opportunity it gives us.
It's also representative of society. We live in a world that is diverse, rich, multicultural, and you know we need to represent that in science. So that's really the challenge
Absolutely.
That we have before us, to make sure that we're representative of
From the food,
the real world.
Yes, the food we eat, the type of car we drive. The latest, I mean, I see people queuing up to buy the latest phone. Mine's a bit old-fashioned, I have to tell you, but you can see how people really appreciate, and there's opportunities to improve their lives and make it better. They don't always associate that with a new science discovery. I've learnt this morning, for example, that we can communicate across the world better because of discoveries that have been made right here in Australia to send light down a fibre optic so it doesn't just degrade and not get to the other end. The whole world's using that. How awesome and exciting is that?
It's pretty amazing, you're right. Tell me, Lynn, take me back to your own entry into science. Was that a natural one, or one that you had to sort of really work hard and overcome?
I think it was there from very early on. You know, we have just had a wonderful fellow join us, Professor Justin Marshall. He works on colour vision in animals and in humans, and that's affected the way our satellites now work. As a kid, I sat and watched a whole bed of flowers in different colours to see which ones the bees went to. So I think I was there to start with, but the real thing for me was going to Darwin's house on a school excursion. As you can tell, I'm not an Aussie by origin, I am proudly that now, but back in Britain, and I looked through his microscope and I looked at carnivorous plants, which I'm pretty sure came from Western Australia now, the last place he visited, which is Carnivorous Plant Central. Didn't know that then. I walked away from that experience, I got on that bus, I can almost see my little self there now, and I was going to be a biologist. And it's been my whole life, I have just loved that. I'm so curious and I'm so appreciative of all the discoveries that our fellows and others are making. It's extraordinary, and if we can protect our biodiversity, which is huge in Australia and under threat, the sort of discoveries that our fellows are making about climate change, about plant adaptation, they're all in there, growing better crops so we can conserve more areas for natural environment. This is all part of our future.
Now, Lynn, tell me, why is an event like Science at the Shine Dome so important in bringing the fellowship together?
Well, first of all, we've got to celebrate. When you're a scientist, you're head down a lot of the time, and you don't come head up and say, hey, we've reached an important point. So it's important to celebrate that. It's also important for the teams. It's very much a team sport doing science, and they will gain so much in terms of confidence and actually ability to get jobs and to get grants and to be part of, or to reach out and become part of industry. So I think that celebration and sharing that joy across not only the fellows but other members of the scientific community is really important. It's a great networking event. A lot of the great science discoveries come when two people who would think they would never meet say, I have something from radio astronomy that can help you solve your problem in biology. So having all those fellows together in one place is just an extraordinary experience and really important. If you're in somewhere like Oxford or Cambridge, you might go for half a pint of beer at lunchtime and you bump into someone. Not as easy in Australia, where we're more widely distributed. But to pull us into one place, and I bet you, we should be monitoring that, Paul. We should be looking to see how many new discoveries take place as a result of conversations that take place at these events, because I bet you there are going to be some.
It's so true, and I have to say, working back in the office here at Ian Potter House, right next to the Shine Dome, having
newly restored, everyone, and wonderful, thanks to the hailstorm.
Exactly. And I think just working together in the same space and having those incidental conversations, you suddenly realise the value of actually being in the room together and
it's
sharing
absolutely,
ideas.
it's absolutely invaluable, because one gets very channelled into your own discipline. I saw that as the Chief Scientist of Western Australia, that bringing people together was one of the jobs that I thought was most important. And it really is talking across disciplines. And now we can hardly distinguish physical from biological sciences. There used to be two clear entities. Now synthetic biology, you're creating a new molecule, we heard that this morning, you're applying it to better plant production, for killing cancer cells. My gosh, you have to put everything together. That's where the Academy has such strength.
Now, just before I let you go, you have a special role that you're playing tomorrow night.
Yes!
One of the hosts with the most. Tell us a bit about that.
Well, this is the Academy's dinner. It's going to be in Parliament House. How exciting is that? In the big hall with that wonderful tapestry behind. Myself, I'm only co-chair with Francis Seprovic, and we are so looking forward to the whole event, because not only is it a chance to celebrate our scientists, but it's to say thank you to their families. We hope so many will be there with their partners, their families and their friends, because if you're married to a scientist, and I'm sure my husband Richard would agree with this and others would, it's sometimes a tough trot. You know, you might say you're doing 9 to 5, but that 5 might be 5 the next morning, not 5 in the evening. And you travel a lot more, and sometimes you're thinking about the next paper when you should be thinking about other things. So to say thank you to them, And I think for the fellowship to say thank you to all of you in the Secretariat who keep the ship very much on the road, and for the fellows to meet you, because often you're just there. I've been fortunate enough to meet you all and know what an awesome job you do, but if you're just the end of an email, sometimes it feels a bit impersonal, and that's a chance to really interact. So I see it working on several levels, and I just think we have to make sure we keep these events going. They're very precious. As you know, I'm very keen, and it was wonderful that the President said this morning that we're looking at developing regional hubs even more, so the fellows across the country can work within their environment, and I look forward to that. But there will always be a case for bringing everyone together.
And I think after what we've lost over the last few years, it's really brought to the front of our minds how important
we
having those
appreciate it even more, don't we?
Absolutely right. Lynn Beasley, it's an absolute delight speaking to you as always. Thank you so much, and good luck with the dinner tomorrow night, and enjoy the rest of Science at the Shine Dome.
Thank you very much. It's a privilege and honour, and it's a joy.
Thank you very much. Well, based here in Canberra at the Shine Dome, if you go for a bushwalk, you might come across echidnas from time to time, of all things. Coming from Sydney myself, I never imagined that I might see an echidna in the wild, but how about a train of them? Take a look.
Many echidnas have a quirky courtship ritual known as the echidna love train. It's where multiple male echidnas follow a female around in the hope of becoming her mate.
She generally has only one young every 3 years, whereas the males can be reproductively active every year. That means that there's going to be a lot more males looking for a reproductively active female during the breeding season. And that's probably what forms the echidna trains.
This romantic pursuit takes commitment and can last up to 4 weeks for some echidnas during breeding season in winter. Some males travel many kilometres outside their home ranges, possibly drawn to the chemical odorants that female echidnas release.
But until the female is receptive, no mating happens. The female has one single mating with one single male, and the rest blues out.
These behaviours only occur in some subspecies of echidnas. Others, like the Tasmanian echidnas, aren't seen in echidna trains at all, and those females mate with many males. The female echidna lays an egg in her pouch, which hatches after about 10 days. Blind and hairless, the young puggle is the size of a jelly bean. Meanwhile, the male echidna returns home alone and waits until the next breeding season.
The Australian Academy of Science, because questions need answers.
Well, welcome back to the Shine Dome here in Canberra. Anna Maria Arabia is the Chief Executive of the Australian Academy of Science, and she joins us now. Anna Maria, welcome to you. It's so fantastic to be here. The sun is shining.
It is absolutely amazing to be back at the Shine Dome, for Science at the Shine Dome, after a 2-year absence. I'm just so thrilled to see our fellows in the Ian Walk Theatre being acknowledged for their scientific achievements, and to have everyone together again and networking and collaborating. It is really a joyous moment.
And with Lynn, who we just spoke to, she's waited 3 years for this moment. She was just talking about not only the significance of what an honour it is, but the responsibility that comes with being a fellow. Many fellows say that, don't they?
Yeah, that's right. So when somebody's elected a fellow of the Australian Academy of Science, their scientific record and achievements are absolutely acknowledged. But they give so much back as fellows of the Academy, not just to the Academy, but to society. They really bring their science to the service of the nation. And it's one of the joys of my jobs to work with all of the fellows and gather that wonderful expertise and evidence that they have and that they have developed, and shape that in a way that's able to inform decisions.
Now, can you tell me a bit about how... Okay, we're just going to quickly stop and go to a quick story, and we'll be back with Anna Maria in just a moment.
The leading cause of heart disease and stroke, affecting more than 1.2 billion people worldwide. New research reveals that about twice as many people globally now have the condition than 30 years ago. And that's largely due to our aging populations. Also known as hypertension, high blood pressure is easy to detect and treat with low-cost medication, but as many as half of those living with it don't realize they have it. And even fewer are receiving treatment to keep their blood pressure within normal ranges.
And this essentially is because hypertension is a silent disease. The overwhelming majority of people who have hypertension have no symptoms of it, know nothing about it until either they have their blood pressure checked or, unfortunately, until they present with a complication such as heart disease or a stroke.
While old age and genetics can increase your risk of hypertension, simple lifestyle changes can lower it. That includes cutting down on salt, eating healthily, exercising regularly, and reducing stress and smoking. High blood pressure occurs when your blood pumps with more force than normal through your arteries. This added stress can cause your artery walls to thicken, making it easier for fat and cholesterol to build up. Hardened arteries limit the flow of blood to organs like your heart and brain, potentially leading to heart attacks or strokes. The study found that many lower-income regions such as sub-Saharan Africa are still struggling with hypertension control, while middle-income countries like Costa Rica, Chile and Turkey have made huge progress in the last 30 years.
Much of this is about organisation of care and about societal-wide interventions to improve lifestyle that will reduce the risk of developing hypertension for some people, and for those people who already have high blood pressure will help them in controlling the levels of blood pressure.
And these may be valuable lessons to carry forward as health experts work to alleviate the global burden of hypertension.
The Australian Academy of Science, because questions need answers.
Welcome back to the Shine Dome here in Canberra. My name is Paul Richards. I'm the Director of Communications and Outreach, and I'm joined by the Chief Executive of the Academy, Anna Maria Arabia. We had a small technical issue before with one of our microphones. That's all been fixed now, so we should be great right to continue our conversation. And Maria, we were talking about the honour that it is for fellows to be elected to the Academy and the responsibility.
And just how much they give back to the Academy and to the nation as a whole. So they often bring science to the service of the nation. At the Academy, one of the privileges of my job, as I mentioned earlier, is to be able to gather that expertise and use it to help inform decisions wherever decisions are made. But our fellows really contribute their expertise and their time and energy in so many ways. They're involved in committees to help elect the next year's fellows. They're involved in award committees. They're involved in helping shape scientific disciplines so that they are ready and able to meet the needs of scientists and to be able to solve so many of the global challenges we're facing. So they really do inspire me because they give so much of their time and energy in a voluntary capacity to the Academy once becoming Fellows of the Academy. And then the role really, I guess, of the Academy is to harness that knowledge, that expertise, and make it available to lots of different forums. Parliament House, just over the road really from where we are here across the river. How do we do that? What sort of ways does the Academy work to make the evidence-informed decision-making possible? Yeah, you're spot on, Paul. We do harness that expertise. I think there are three things that I'd really like to emphasise. Harnessing that expertise means using the convening power of the Academy, so to be able to find that expertise wherever it resides, and it usually does reside within our fellowship, but even amongst scientists who are not in Australia, those who might be overseas. So our independence is really important. Our convening power is very important. Our independence is also very important. As fellows of the Academy, they're not here representing their institution or anyone in particular. They are experts in science. And so they bring their knowledge and expertise in a way that is independent and able to inform decisions. And of course, we are able to then gather that and synthesise that information. And as you said, it really is used for informing decisions. In Parliament House, for example, we know decisions are made every day by ministers, by shadow ministers and by others. And often we're called to assist in that decision-making process by having science heard in that forum. So the Academy gathers that expertise, it synthesises it and makes it accessible for an audience that is not a scientific audience. So most parliamentarians and most ministers don't have a science background. We have an increasing number of them, which is good news, but most of them are not scientists. So we do translate that knowledge in a way that is really accessible for parliamentarians, and they can access it to inform their decisions. We absolutely know that lots of things inform their decisions. Economics inform their decisions, polling inform their decisions, public sentiment, a range of things. But it is really important that science also informs their decisions. So that is a key role of the Academy and how we and how our fellows contribute their knowledge.
And really working with the Academy, you know, helps deliver such amazing knowledge to the places of power that need to hear it in a way that not many organisations have the privilege of doing. I mean, it's, if there are researchers or fellows watching our live stream now, if you're called upon to support a report of the Academy, it is a huge opportunity to have that evidence heard where it might not otherwise be.
It really is. It's a form of translation, really. So often researchers, we speak about them working with industry to translate their science into a technological product or a service. But actually another form of translation of that evidence base is so that it is accessible to decision makers. So it's really what we call the science policy interface, and using that expertise to inform decisions. And fellows who do participate in those processes often report back saying it's some of the most meaningful work that they do, because they can see a direct application of their knowledge in whether that be a piece of legislation or most recently in paving a way to guide us through the pandemic. So it is a really important role that they play and contribution they make that is hard work, but I think very gratifying work.
You've also made a priority to have evidence-informed decision-making in our courts. Why did the Academy get involved in the Kathleen Folbig case, for instance?
Yeah, great question. So if you think more broadly around the principle that we feel science should be heard wherever decisions are made, whether that be in the Parliament, whether that be in boardrooms, in classrooms, in the public square, but also in the justice system. And the Kathleen Folbig case exemplifies a case that is before an inquiry at the moment, an inquiry being overseen by Commissioner Tom Bathurst about a woman who has been convicted for killing her 4 children. There is significant scientific evidence that brings reasonable doubt to her convictions. And so it is quite important, it is very important that science be heard in the justice system so that new and evolving evidence, scientific evidence in this case, that does have a significant impact in this particular case, but more broadly on the justice system, is heard. So the Academy has become involved in that case as an independent scientific advisor to the inquiry that is looking into her conviction. The inquiry started a week ago and will continue in February. So our role has been to make sure that the right experts are able to speak with Commissioner Bathurst, to make sure that the right questions are asked of experts so as they can share their knowledge in a way that is accessible to the courts and to the justice system to help inform their decisions. It's critically important that that's done well. Unfortunately, the mechanisms for new scientific evidence to inform decisions after all appeals are exhausted actually don't exist in Australia in a way that allows science to be heard appropriately.
So there's a real opportunity for reform then in terms of how science could be heard not only during legal cases or trial, but potentially revisited it, because science is always evolving, as in this case, where new findings were made, you know, years after the conviction.
There's enormous opportunity for reform. In particular, there are 2 areas of reform that we are pursuing that are exemplified through this case, and indeed the Academy's involvement in this case is a demonstration case, but our involvement will continue beyond the Folbig case in efforts to ensure science is heard in the justice system. But the 2 reform opportunities, one exists
experts right up front. So whenever a case is being heard in a court of law or at an inquiry such as this, it's important that the right experts are there. So we're well beyond the days of having only physicists, biologists, chemists and mathematicians. There are so many subdisciplines. It is so difficult to know and understand which would be the most appropriate subdiscipline to inform a particular case, given how much information and knowledge we have in the scientific sector. So there is a role for the justice system to receive advice on who the best scientific experts are to inform any particular case. And that could be done right up front at the beginning of a court case or the beginning of a hearing. The second law reform opportunity which we see is the introduction of a criminal case review commission. That would be a commission that enables us to have a look at when new scientific evidence is available at the post-appeal stage. So imagine someone like Kathleen Folbig who has exhausted all of her appeal opportunities, and then there is new scientific information. There is no mechanism at the moment for that science to come forward and to be heard. Many other countries around the world, like-minded countries, do have a criminal case review commission. Australia doesn't. So the justice system would be served really well if such a commission were established. So in cases like the Kathleen Folbig case, post the appeals process, science can be heard at that end of the spectrum as well.
Well, Anna Maria, I know you've got a super busy schedule, but there is one more question I wanted to ask you about, and that is related to your work in diversity and inclusion. You've really helped lead the strategy along with our fellows in how we can both represent diversity and inclusion more fully through the Academy, but also seek to have impact across the sector. Why is it an issue so close to your heart, and are we getting there?
Yeah, I'm really proud of the strides the Australian Academy of Science has taken in the space of diversity, equity and inclusion. I started here at the Academy in 2016 and there were already some measures in place to improve opportunities and participation, particularly for women in STEM as one form of diversity. We've built on that over the years and indeed it's the Academy of Science that authored the Decadal Plan for Women in STEM. It's a 10-year plan that provides guidance to whoever and wherever you might be in the sector, whether you're in industry, in education, in the science sector, or a teacher, even a parent, what you can do to advance gender equity in STEM. So it's a 10-year plan to achieve gender equity by 2030. So a seminal report that we use very much as a guide to this day, and we have made advances. But we are also most concerned about other represented groups, so other forms of diversity, and think about Aboriginal and Torres Strait Islander scientists who do not have the opportunities that non-Indigenous scientists have. Think about people with disabilities, the LGBTIQ community, think about intersectionality broadly, so culturally diverse individuals and groups. However one might identify, across this broad spectrum of diversity, and our society is so diverse, what can we do as an Academy of Science with the privileged leadership position we have to improve diversity, improve participation, so that we have the most diverse, informed scientific workforce to put all of their strength and knowledge to the wheel to solve the global challenges that are before us, and they are massive. We know we will solve those challenges more effectively if we have diversity in decision making and all the available talent working on it. So we've done a lot at the Academy. There's a lot more to do. There's a moral reason to pursue this, and it's something I feel strongly about, but there are economic reasons. There's better research outcomes. So there's 1,000 reasons to be active in this space and to encourage diversity across the STEM workforce, but starting even earlier than the workforce amongst girls who and younger people who may not have all of the privileges and advantages or may face barriers that we can have a good go at removing to enable them to be attracted to STEM, to be inspired by it, and then continue through the workforce and apply those STEM skills wherever they land. So it could be in research, it could be in industry, but honestly, science is everywhere, so we need as many of those scientists and people with STEM skills across professions, across the country and across the world.
Well, Anna Maria, congratulations on your leadership and your work in this space, and on the fact that here we are at the Shine Dome enjoying this meeting here, the conference for the next 3 days. Thanks so much for taking some time out to chat to me.
Thank you. Could I congratulate you too? The live stream at 2022 Science at the Shine Dome is a real source of pride for me. It is a tremendous opportunity for our online audience to take a peek into this wonderful building, the Shine Dome, and see what goes on inside, to hear from extraordinarily talented people. I mean, all of the fellows, don't worry about me, extraordinarily talented people as they share their knowledge, and to have that insight. So we hope our online audience is enjoying it, and we hope you can visit Science at the Shine Dome and visit us here in Canberra. And thank you, Paul, for your absolute expertise and your team in bringing this to life. I'm really proud of this new innovation at Science at the Shine Dome 2022.
I'm having a great time too, so thank you, don't worry about that. Well, welcome to Science at the Shine Dome, and we're going to hear from some of our partners who have made our live stream possible. Let's take a look now.
Curiosity, collaboration, and courage to think outside the box are at the core of science and technology in defence. From developing high-tech capabilities to creating new technologies, defence researchers are at the forefront of our scientific advancement. We aim to inspire the next generation of scientists, researchers, and engineers. And our collaborative partnerships help solve some of our nation's biggest problems and protect our way of life.
The future is the great unknown. One day, we'll turn our plastic problems into worm food.
We're doing that.
The best time to own the unknown is now. The University of Queensland.
Well, the live stream that you're watching right now wouldn't be possible without our partnership with the Department of Education. And it really is a perfect fit because they have a range of programs that are really looking to turbocharge the research sector. The first Assistant Secretary of the Research Division for the Department of Education, Dom English, joins me now. Good morning to you, Dom, and thank you for taking some time out to have a chat.
Yeah.
Australia's Economic Accelerator is a pretty massive program, $1.6 billion. How does it work?
So early days, we're still setting up how the scheme will operate, but this is really, I think, an exciting and new experiment in how we might use public funding to accelerate research in Australia. Typically, we go for longer grant-based application processes and give sort of 5 to 7 years, and that's great, but that doesn't allow sometimes for that innovation cycle, which requires short turnaround, quick feedback, and quick change of direction to evolve over time and to place more bets and see what succeeds. So what we're looking for is we have 2 stages in the accelerator scheme. We're an earlier stage where we pick up about 100 projects a year and give them between $100,000 and $500,000 worth of initial investment to do things like business analysis, prototype the ideas, look at the engineering and marketing and distribution problems and application problems that need to be solved to take technology out to application with either end users or industry or commercialisation pathways into other markets, and then once we've seen how those perform, we have a smaller number, about 36 grants a year of up to $5 million to really then get in behind those things where deep tech, I think, is the term that everyone uses now, where really you've got to actually make those big investments to convert the idea into something you can tangibly take to industry or commercial partners and say this will work. And so, you know, conceptually, if you think about bench disciplines, we talk about, you know, from the laptop to the bench top in the first stage, and from the bench top to the workshop in the second stage with proof of concept demonstrated. But because of the design we've got, and it sounds like a lot of money, it's 10 years, so we'll see whether it feels like a lot of money as you go. Because of that design, we actually do get to see more projects come in at the beginning and be a bit more risk-seeking, I guess, early. And then when we're making the bigger investments, we can double down and follow the lines of success, or at least the lines of most promise, because we know we can't guarantee success in a business like research accelerators. Yeah.
It sounds as though it's a perfect kind of program to really help research take that next step,
Yes.
and in where perhaps it couldn't go any further without this kind of funding support. It really provides support wherever it's needed, whether that is the marketing, whether that is the relationships with industry.
Yep.
It was a real gap that is great to be filled, isn't it?
Yeah, I mean, a public program can't be a substitute for fixing those commercialisation pathways in Australia, but what we can do is help strengthen the ecosystem and build the connections that people need to use to take those research projects forward. We know, for example, that there is a massive amount of great research in Australia that we can leverage. We're top 5 on just about every measure that you care to look at, in my view. But we're not quite top 5 on the translation side, and there's a little bit of, that's the nature of the industry we have in Australia, and we've got to keep Team Australia working together to build the pathways that allow those new industries to emerge. But we've also got to strengthen the partnerships between people who, may be focused on making their business work and people who are making their research work. And sometimes getting those connections just needs a bit more encouragement, a few more pathways to make that happen. And this scheme hopefully gives a really big beacon to bring those connections together and really encourage people to build those pathways.
So tell me a bit about how, if there are researchers or fellows watching now and they think perhaps their area of research might be suitable for this kind of program, what should they do at this point?
So at this point we're in the let's develop it phase, and let's talk to a whole lot of experts about what the priorities should be and how the momentum should be gained. So first point would be keep an eye on our website. There'll be opportunities to engage in the discussion about the prioritisation, because it will be a scheme that prioritises. We can't back everything, so we're going to pick a few areas and go for it. But there's other opportunities to already start engaging with the broader research commercialisation agenda, such as around the fellowship schemes that the RRC is developing, and the Trailblazer schemes, which are already now rolling out across 6 universities, 6 lead universities and their partners. A little later, early next year, I should say, we're very keen to start opening the first round of trials for the scheme and to invite people to start bringing projects forward. We haven't determined yet which priority areas that will be in. It will likely be one of the national reconstruction priority areas, and so if you think of the sort of things that where there's opportunities to take industry forward for Australia, that will be where we pick it up. So again, opportunities early next year. Keep an eye out on our website. Keep an eye out. Reach out. We've already started to recruit a whole lot of PhDs on internships and postdocs on internships to help design the scheme, because we're really committed to saying to people in the research community, if it helps you build a diverse research career by actually understanding commercialisation pathways and partners and the ecosystem, then come and work with us on implementing the scheme, and then when you go back out you'll be better placed for taking advantage of both the scheme and other opportunities in the ecosystem.
Yeah, I wanted to ask you just a little bit more about that National Industry PhD program. So where does that fit in the piece?
So when we designed the Research Commercialisation Action Plan, we were very clear. We couldn't just roll new grants into the system if we didn't also then build the workforce and the career pathways that academics could take advantage and build these skills and succeed with. And so we're starting at the beginning. We've got 3 streams of an industry PhD scheme. One part leveraging off the CSIRO's very successful industry PhD scheme, expanding its capacity and getting more people into that. We've got a scheme that we've got 2 schemes that are being run from the department. One that focuses on taking people who have an interest in working on industry-related PhDs and connecting them to the industry partners and projects that need PhDs to work on them, and giving them resources to support that effort. That scheme is likely to open in a few months' time. And a similar scheme for people who are actually working in industry who want to come and do a PhD, and we put a bit of support in to help employers deal with the cost of supporting somebody to do that as well. So that's the beginning. As I say, the ARC is now rolling out its fellowships on industry fellowships, the mid-career, the laureate fellowships, and we hope that therefore people can see a path, right? They can actually see a whole career where maybe they spend a bit of time in research, a bit of time in industry, can pick up fellowships through the RC that reflect that time in industry and that time in research commercialisation as a high priority for their fellowship pathways. So we're really excited by just how that package has come together with the full mix of opportunities for people to take forward research commercialisation career in Australia that maybe at the moment is a little more unique than regularised, and we just want to make it really regular. You know,
yeah, it's terrific, and I can see how this range of programs could really turbocharge that and make that translation of science more accessible and successful as well. So yeah, a terrific set of programs.
No, I think we're very pleased that the government has committed to roll these schemes out in the last budget, and now it's head down for us, and we really want to go. But we're at that stage where we're designing some of the detail of how the scheme works, and so we'd love to talk to your members and people watching if they have experience with this sort of research translation that they can bring, that if they've got opinions about how to take it forward, when they're ready to be part of the scheme. We really do want to see a very competitive and engaged scheme. We think this is a great opportunity. You really can't argue with the fact that there's plenty of research potential in Australia, and there's plenty of opportunities for us to really build a stronger economy based on a more diverse, more intellectually driven, more technologically driven economy over time. We think that's a real priority as a nation. Yeah.
Well, Dom English, thanks so much for telling us all about it this morning, and you're talking to the right audience. I'm sure there'll be many people tuning in who'll be, if they weren't already aware, checking out the website, and thank you so much once again for supporting Science at the Shine Dome.
No worries. I hope you have a great couple of days here. It's great. Thank you very much.
Thank you. No, the sun is shining here at the Shine Dome, and there's a great crowd of fellows and EMCRs all gathering together, finishing off their lunch. We are going to be going to our next ceremony of admissions for Fellows of 2021 coming up very shortly. But first, we're going to take you to an interview that I recorded with one of our fellows last week, Professor Phil McFadden. Phil McFadden is the former Chief Scientist of Geoscience Australia, but has also in recent years become quite an incredible wildlife photographer. Take a look. Phil, you've just returned from a trip to Kenya, your first overseas trip since the start of the COVID-19 pandemic. What was it like travelling again?
Well, it was absolutely awesome. Obviously, all those concerns that we've been seeing about how terrible air travel was and everything like that, everything went perfectly. That's largely down to my wife's fantastic organisational skills, but everything worked perfectly. So we were in Kenya. We went from the Masai Mara, which is right on the southern border, right against the Tanzanian border, all the way up to Samburu, which is way up in the north. And then we flew down to South Africa and went way across to the west of South Africa, right up onto the Namibian border in Galakari, which is in the Kalahari. And I was there with a long-time friend of mine, a guy I grew up with. So it was just wonderful to be back there in Africa.
Now, you've brought your 2023 calendar with you. Can you take us through it?
Obviously, we weren't travelling, and so we were focusing a little bit more on the local area for a while. And we had this beautiful little bird, the most fantastic little bird, a red-backed kingfisher. Very rare here in Canberra. They're normally very rare for us to see them. But there was this one that appeared in Campbell Park. And so we spent many a day going out there to Campbell Park, right by the defence establishment, to hunt out this little fella. So, and we kept on finding him. And as you can see, he's just the most he's only about this size. The most extremely beautiful little bird. He really was fabulous.
Now let's turn over from the front cover and take a look at January.
Okay, well in January, that there is my favourite bird. It's an African fish eagle. I love eagles. I mean, at the moment I'm photographing a wedge-tailed eagle here in Canberra, a chick growing up. So I love all the eagles. I love the raptors. The reason the fish eagle is my favorite is because when I hear the cry of the African fish eagle, I know I'm back in Africa, and that just suits my soul. So this is my favorite bird. And this was in the Masai Mara, right in the southern part of Kenya. And every now and again, you get the mix of a bird in the right attitude, right position with good light, which is what I managed to capture here. And it's always great when you manage that. It doesn't happen all the time. So you're only going to get that kind of light in the golden hour, early morning or late afternoon. But there's a lot of early mornings and a lot of late afternoons. And the trouble is you only get that perfect light for sort of 5 or 10 minutes. So that's a very narrow window for finding the perfect shot.
How about we move on to the month of February?
February, my wife took this shot. We were in Kalahari. This was a pale chanting goshawk. Beautiful. I mean, I just love the yellow against the blue sky, and these pale chanting goshawks are all over the show. We don't have any photos in the calendar of it, but quite often I've got photos of pale chanting goshawks carrying a snake that they've picked up because they're extremely good snake hunters. And they're a beautiful bird. Across there in Kalahari, they're quite common, but you get to see them. But it was just beautiful, that clear blue sky with the yellow and the orange beak on this bird. And they do have orange legs. It's hard to see here, but they do have orange legs, so they stand out against the blue sky just beautifully. It makes for a lovely image.
What did you end up choosing for March?
Now, see, my birthday's in March, and my wife always I give my wife a bunch of photos, and she picks which ones go where, and she adds in hers. So she always picks one that I like for March. This was our first afternoon in the Masai Mara, and it was quite fascinating because in the group we had 6 Americans who had never been out of America before. And their reaction to what was happening in Africa, and that's why they were there, was just so beautiful to see. They figured out what the world can look like, given the right circumstances. And it was our first afternoon, and there was this pride of lions, 3 females with a lot of cubs. And the cubs were just so funny. I got fabulous photos of the cubs playing. But when these 3 females sat down on this little promontory, I just thought that the composition, the structure, the light was absolutely beautiful. And so, you know, I just love the setup of those 3 females, so intent, looking out. They were actually looking at a bunch of springbuck. And of course they went after that, and I've got a couple of photos of their extreme disappointment when they achieved nothing. We were driving along, and we saw some lion spoor. So we followed the lion spoor, and then came to this thicket, and we knew there were the lions in there. So, of course, you don't want to go in and disturb them. But we could see which way they'd been going, so we traveled on down in the same direction, hoping that they would come out. And so we waited about 20 minutes, and they came on out, and then we stayed with them for about an hour before it got too dark to photograph.
Can we take a look at April?
Okay, April. This is a photograph my wife took. As I said, we've been doing some focusing on Australia, so we went for a trip up to look at the Menindee Lakes, Lake Mungo, Lake Tyrrell. And the Menindee Lakes, we've also been up to Lake Cowell. There aren't any Lake Cowell photos in here because that was last year. And with all this water, suddenly we're getting a lot of water birds in, and you're getting beautiful landscapes. So it really is quite beautiful with all the water that's up. Of course, at the moment you can't get there because you've got 200 kilometres of flooded road to drive through. But when we were there last year, it was almost perfect about the level of water in the lakes, the birds that were there, and it really was lovely. And this is a photograph my wife took early in the morning, just at sunrise, you know. Yeah, and like, you know, people should be visiting these areas because they're Australian and they're beautiful.
Yeah, spectacular. Now, my birthday month is May, so what did you choose for May?
Ah, you got one of my photos on your birthday. This is also the Menindee Lakes. Every night we went to Menindee Lakes mainly for landscape photography, but a couple of the afternoons I thought, before, you know, I just thought, no, I got to go and photograph some of these hawks that are around, because there are a lot of hawks around. And I pointed out that a photo is out of temporal and out of spatial context. This might look to you like a beautiful photo. The light was perfect, the hawk is sitting there, the sky was lovely, but we're right by the river, and the hawks had been killing a lot of fish, and there were a lot of dead fish lying around, and what you can't do here is smell it. when I was photographing this, I was smelling it, and it was pretty hard at the time, I tell you. But, you know, when you get the opportunity for beautiful light and a bird in the right spot, you just go with whatever's happening. I also find hawks to be beautiful animals for just that sort of reason. The contrast that you see in them. They're not just, I mean, we have a magnificent bird. We have magnificent birds like the magpies and all that sort of stuff. But pure black, people don't get excited about it because they just say, oh, there's not all that contrast in colours. Whereas these birds are just, they look beautiful.
Yeah. Could we take a look at June?
June, now this was a really fantastic experience, and I've got fantastic video of it, which really shows you what's going on. These are the red-billed quelea, a bird about this size, and they're in these massive flocks, and they swoop into the water, they drop down in this massive clump, drop in, get their wings wet, lift up some water in their beak and fly off immediately because there's so much at risk when in the water. So you'll see a completely clear sky, and I've got these videos which will show it, where they just, the whole flock will rush in, drop into the water, grab a bit of water, fly out again. And it's this dynamic thing with them coming in, going out, coming in, going out. And there were a couple of corvins in there just standing there waiting, and all they had to do was grab, and there's breakfast. And they're an amazing bird, and it's just fantastic to watch them. And again, this is a still, so you don't get that sense of dynamism that you'd get out of the videos. But one thing that is quite fascinating, and once again, as I say, it's out of context, this large number of birds getting their wings wet and bringing up the water. We're sitting in the Kalahari. It's absolutely dry desert areas, and the whole humidity and smell changed because these birds are lifting up the water, and as they fly around and flapping their wings which got wet, they're putting. So it was really quite amazing the way their very presence and their activity changed the environment around them.
Halfway through the year now, we've got another 6 months to go. What have we got coming up for July?
This was at the walls of China in Lake Mungo. So we went from Menindee Lakes down to Lake Mungo. As you know, there have been artifacts there found from 60,000 years ago. It's one of the longest occupations of humans that we, and the landscape is just fascinating. So the photography I managed to get there which is quite restricted, and quite rightly so, because of course people are going to do stupid things in that important area. So you're quite restricted in how you can go there. You've got to have a guide, etc. But we managed to be there for 2 evenings and got some of the most amazing photography, because the landscape there, the structures around the walls of China is just amazing. A geologist walking through the landscape sees a very different landscape from most people. I experienced this to a very deep extent one time when I was walking in the Atarkine, and we had a person with us who had been a senior geologist in what became Geoscience Australia, and he was a natural teacher, and most of the people just came to walk around the Atarkine. We had a group of 10 people, and everywhere he went he was explaining the geology and the impact it had on these people to actually understand the terrain they were on. Now I'm very lucky that I walk around and I understand the terrain. But it was amazing for these people to have somebody who was such a good geologist and such a good teacher just explaining to them everywhere they went. And people were saying every day, I had no idea that this is what my Earth was like and what it was doing.
Let's take a look at August.
August, another photograph, this time from my wife. This is the Rothschild giraffe. We were a long way away. Between us was a bunch of lions I was photographing, bunch of cubs trying to play with Dad. It was raining like nobody's business. Dad was unhappy. Kids were saying, I want to play. And my wife, of course, was saying, but look over there. It's beautiful stuff over there. And she was photographing these Rothschild giraffe. Now, the Rothschild giraffe are very rare. There's fewer than 2,000 of them left on the planet. But I don't know if people are aware of the ossicones that giraffe have, these two bony protrusions up there. Most of the giraffe that most people know, the Maasai giraffe, they have 2 ossicones. These guys have up to 5, and they look really quite strange. And they have a much more diffuse pattern than the normal Maasai. And with giraffe, they get darker as they get older. So you can tell that this is quite definitely the oldest one. But it was just in the mist, and what my wife was trying to do with this photo was just show the mist and show the giraffe behind it and this beautiful terrain with these now highly endangered animals. And a lot of animals do that. If you look at lions and all that sort of thing, they all have spots. And as they get older, the spots go away. They change. And it's the same thing with a giraffe. As they get older, they darken. So you can just look at a giraffe and say, that guy's old. This is a young one. This is... You
can see who the grown-ups are.
Yeah, that's right.
Off to spring now. What is the photo that you chose for September?
This is back to Menindee Lakes. And there are a lot of cormorants around fishing. And this was a photograph by my wife, and she just... And it's just, you know, one of the things that's so important to us is to be able to sit with nature and just be quiet. Just chill out and enjoy the world as I think it should be. And it's the same thing as sitting in Menindee Lakes. We'd just been sitting there for ages watching these cormorants, and so my wife just thought it was very nice having this cormorant the yellow light sitting on the water. There are things I've learnt by photographing, because I often hit the button on motor drive and my camera goes at 20 frames a second. I can't see that quickly. And so there's often I've watched something happen. I didn't know it happened, but when I look at what I photographed, I suddenly find out what is actually happening in nature. And it is fascinating. It's amazing to learn what is going on out there by sitting and watching.
Can we see October?
This is Lake Tyrrell. We had been photographing up in Menindee Lakes, Lake Mungo, and we went down to Tyrrell. And the temperature had been 45 and 48 on one afternoon in the Menindee Lakes. And it was pretty warm in Mungo. And then we drove down to Lake Tyrrell. We got up at 4 o'clock in the morning, went out to the lake, had a photograph, and I was really cold. And you can see it looks cold. This is one of my wife's photos. But it's so serene, and we sat there and we got really, really cold. We couldn't understand it. We got back to the car and the car said -2 on the thermometer. But it was just such a shock having day before been in plus 45. But it's just I mean, Lake Tyrrell is a beautiful place that people should visit and see. We didn't put it in here, but it's got this perfectly calm, so the beautiful reflections, you get the reflections of the moon. It's just such a calming place if you want a little bit of calm in your life. Go and sit outside Lake Tyrrell, 5 o'clock in the morning.
Sounds good. What did you choose for November?
November. Yes, November. To me is very special. This is a wedge-tail eagle chick. It's here in the Canberra region. I'm not going to tell people where it is. And my wife and I have been going out there and photographing it. We're photographing 60 meters away because you don't want to get any closer. You don't want to disturb the nest. You don't want to upset it. And this is the chick on his first couple of days when he's actually discovered these things on his side called wings. And he's been flapping around a bit and he's jumping, trying to figure out what's going on. And so this for him is an early experience of trying to figure out what he's going to do in life. And I'm just in awe sitting there watching this young fantastic raptor growing up. And we've watched him over over a couple of weeks now, and how he's matured has just been amazing. From just lying in the nest looking like a pancake with a head, to being this quite a large animal. And in fact, I've got other photos of him where he tried flying. And bearing in mind that I'm 60 meters away using an 800mm lens, his wings fill the whole frame. And that's just an immature eagle. So the parents are even bigger than that. I mean, they're just the most amazing animal. And watching him grow, watching him evolve, it's just the most amazing experience.
And I know you've got some other photos as well of dinner time, maybe it was lunchtime, different snacks are brought by mum or by dad. Tell us a bit about those.
Oh, yes. They bring in other birds, obviously, and they brought in a rabbit this morning, actually. And I had these photos, the last rabbit they brought in, and it was quite amazing. I couldn't get over it. He ate the thing, bones and all. He's just swallowing rabbit leg bones. And as most people know, birds put their food into a crop. And he started off with a very, very flat chest. And 20 minutes later, his crop was just out here somewhere. And he could hardly move. And then he waits 4 days before mum and dad bring in something else.
And at one stage you saw, I think it was the dad that was holding a mouse, but mum wanted it instead?
Oh, no, those were kestrels.
Oh, that was a separate photo.
Those are kestrels. Those are separate. That was a year ago. Those are kestrels. And again, I learned so much about animal behavior in that event.
Tell us a bit about that event.
Okay, well, these kestrels out at Campbell Park, they had this beautiful hole with 2 entrances in the tree, and they had 5 chicks. And Mum and Dad were bringing in mice and legless lizards and snakes all the time to feed them. And then eventually the chicks actually came out onto the branch. And I hadn't realized, it was only when I photographed it, that Mum's behavior changed at that stage. Because Dad would come in with a mouse, and Mum would come in and steal it, fly off and eat it. And I've got this set of photos where Dad pitches up with the mouse in his talon, puts it into his mouth, ready to hop down and give it to the chick. The chick is standing there saying, I'm about to get lunch, this is awesome. And Mum just shoots up, reaches out, grabs the mouse. The chick panics and runs back into the nest. Mum flies off, and it's the first time I learned that birds can actually have expression. You can see the dad sitting there thinking, what the heck was that about? It's just, but I couldn't see that because I've got these 20 frames in the 1 second. I didn't see that, but I photographed it.
Yeah.
And it's
you can see the sequence slowed down.
Yeah, slowed down. You can look at it. You can see the sequence of what happens. But I didn't see it, even though I was looking at it, because my eye doesn't see things that quickly.
And lucky last, the finale, what photo did you choose for December?
Yes, no, this unfortunately I'm not happy with the print. I printed it too bright, but it was awesome. Here we are in the Masai Mara, and these storm clouds were building up, and you just had this shaft of light coming down. It's much better on my iPad. As this mother elephant crossed through the water. And if you look really, really carefully, you can just see the back of her baby there. But this mother elephant just crossing through the water, the shaft of light coming down of these storm clouds, I just thought it was gorgeous. Absolutely gorgeous. And I happen to have a thing about elephants. They're these beautiful, big, gentle creatures that often in the wild I've had them standing next to me. I've been handling them. I was standing in the shower once in Zambia, an open shower. And it was drought time and the elephants were stressed. And I got a bump and there was a tusk each side of me and the trunk down in the water, sucking away. Most people are scared of elephants. I stood there for a while, stroking this guy on the nose while he was drinking, and he just, such a gentle animal, provided you don't do something stupid.
So Phil, you have had an amazing career from being the Chief Scientist of Geoscience Australia right through to now a whole new career in photography. If there were 3 tips that you had to give someone who wanted to start taking wildlife photography or landscapes, what would they be?
As a lot of people say, your first 1,000 photos are your worst. They gradually get better. You've got to get experience. But it is worthwhile going to, my wife and I used to run teaching courses and that sort of stuff. One of the things you'll often see about professional photographers is it's got nothing to do with the camera, it's the guy behind it. And they've got $50,000 worth of camera gear strapped around them. If you're going to go and do wildlife, there's a basic level of camera kit you've got to get over. For example, I'm photographing that wedgetail 60 meters away. I'm not doing that with a $2 kit lens. I'm doing it with an 800mm lens that I almost had to mortgage my house for. There's a threshold that you've got to get. Then you've got to learn how to use it. You really have to learn, and that's why you should go and get lessons from somebody who knows what they're doing. Then you've got to learn something about post-processing, because the camera always takes if you do it right, the camera always takes a very flat image, which isn't what you remember seeing. You have to learn how to post-process. But if you're doing wildlife, one of the most important things is you have to learn to empathize and understand with the animals. You've got to empathize with them and understand them, because often we will spend 6 hours to get one image. And often that is understanding the animal, tracking it, knowing what kind of behavior we're going to get, and you have to learn a lot of patience. The other thing is you never go wildlife photography with people who aren't wildlife photographers. You never go with bird watchers or anything like that, because you've got to have patience, because they will pitch up 20 seconds there and say, it's time to go, and the photographer will say, we've got another 5 hours here, guys, because I want to get the one shot. So, those are the things that you have to understand and recognize if you want to get decent wildlife photography.
And Phil, you've been a Fellow of the Australian Academy of Science for 26 years now. What does it mean to you to be a Fellow of this Academy?
Well, at the time it was an enormous honour, but I've always felt that being elected a Fellow is an honour, but it also brings a responsibility to serve. somebody who's managed to get that recognition should be willing to use that in order to do good things in a much broader scale. And I've done things like I created the first ever National Strategic Plan for the Sciences, which had an enormous impact in terms of money we got in, conferences we got around, money we've got for young kids and that sort of stuff. And that was only possible as a fellow of the Academy. I've worked with some of the most amazing people to build NCRIS. And a lot of the time I was able to, for example, I was able to use the fact that I was a fellow of the Academy to break down the politics, but state politics over positioning stuff. We were about the worst in the developed world for our positioning. By going along as a fellow and saying, this is about science, and being able to break down the state politics, and then working with Kurt Lambeck, an amazing scientist, he did the work, but I was able to use the fact that I was a fellow to break down the politics and allow us to use this science then to start building a decent setup. We're now the best in the world from positioning. You know, we've got 690 GNSS stations that you can just access. I spent 15 years building a thing called Uncover, which could not have been possible without me as a fellow of the Academy. And the real thing was, I was a nobody, except for the fact that I was a fellow of the Academy, and I could go along with my Academy hat without an agenda. And we built this thing called Uncover because today, of course, people recognize that we really need to move to renewable energy. And I hear it all the time. We've got the technology. Why don't we just go straight there? Well, the issue is we don't have the materials to do. If we make half of the world's cars electric, we need more copper than we've ever had. We need 10 times the cobalt that we've ever accessed. We need all these metals, and we don't have them. And mining for those things, we found all the easy finds. Now we are looking at exploring in covered areas, and that's very, very hard. And so we needed a completely fresh approach. And so I was able to run it out to the Academy. I could not have done that without the neutrality of bringing just the science. So we've changed, and Australia is now leading the world. We're really getting the most fantastic successes of people using these new ways to explore. And that was because we were able to do it from the Academy, neutral, and therefore bring together Geoscience Australia, CSIRO, all of the geological surveys. I think it was 129 companies we had. That could not have happened from anybody in any one of those. But having somebody from the Academy bring in the neutrality, it made it possible. So those are the sort of things that it's meant to me, being a fellow, that you can do these sort of things and actually bring value to the nation. So to me, it's always been about, it's an honour on the day, but thereafter it's a responsibility.
Phil McFadden, thanks very much for your time.
Thanks, Viv. Thanks a lot.
Well, when we look at those incredible pictures that Professor Phil McFadden has taken from around the world, there's some incredible scenery and rich biodiversity. One of the challenges that science is helping the world to face in order to preserve that rich biodiversity is to tackle climate change. Take a look.
I've witnessed the natural world at its most fascinating and vibrant. But I've also witnessed startling changes. Changes that are today threatening our very civilizations.
The current nationally determined contributions submitted by the parties to the Paris Agreement would have to be 3 times as ambitious as they currently are to meet the 2-degree target, and 5 times as ambitious as they currently are to meet the 1.5-degree target.
Our confidence in characterizing our situation rests on the solid foundation of a scientific consensus.
We have been losing the race against climate crisis, but the world is waking up. Pressure is building, momentum is growing, and action by action the tide is turning.
With the political will to collaborate, I have hope for our planet, our science, and our future.
What we do in the next few years will determine the next few thousand years.
Well, I'm joined by Professor Andy Pittman and Professor Beth Fulton. Welcome to both of you. Welcome to Canberra and Science at the Shine Dome.
Thank you.
Thank you.
So if we look at Sir David Attenborough's warning and call for the world to unite, is the world listening, Andy?
Not to the extent necessary. There is a fundamental disconnect between scientific fact and action at a global scale. We have seen 2022 being the all-time record year for emissions of CO2, which is entirely and completely inconsistent with the need to dramatically and deeply cut emissions.
Beth, what about from your perspective? Is there hope for the world to still take action?
I think there is hope. There's certainly a lot on the bottom end changing, so people are experiencing it more. The mums and dads, the users of the environment are responding. We're maybe not seeing that reflected in the emissions as we've heard and some lifestyle changes, but it's starting to bite, and so I think people are really beginning to act. Whether the things can happen fast enough is now the biggest question.
Andy, the whole world was sort of frozen in place in one way or another during COVID-19, and we learnt to live without hopping on a plane every 5 minutes. What sort of lessons can we learn from the pandemic that you would love to see applied in our response to climate change?
I think the biggest lesson is the emission reductions during the COVID pandemic were tiny. They were 6 months worth of emissions integrated over the COVID pandemic. They did not make a dint in the atmospheric concentrations. The scale of endeavour we have to embark upon to actually reduce the CO2 concentrations in the atmosphere is enormous, and the climate scientists started saying that in 1990, and we don't seem to have really got that message across to the degree that has led to action.
So Beth, what are we sort of really looking at then? It's the fastest action possible, but we're going to be seeing and living in a world that is going to be suffering the consequences of inaction.
Yeah, and potentially for thousands of years. So part of it is the end that I work on is the adaptation end. So how do we put things in place to help us cope with that change without necessarily creating a new round of problems that's just going to make it worse. So some of the underappreciated parts of the COVID pandemic is, we all started ordering things online, so that requires transport. We redirected where some of those emissions were as well. So in trying to find solutions, you don't want to create the next problem, which is why it needs a bigger picture look at how you make those changes.
Andy, tell me a little bit more about your area of research and how it is really looking at the issue of climate change.
So I'm particularly interested in extreme events and how changes in climate are amplifying or triggering extreme events. I'm interested in the actual fundamental processes that underpin things like droughts and heat waves, and ultimately where we might be able to use the land to either moderate climate change or adapt to climate change, trying to reduce the scale of some of those changes.
And in just a few minutes' time, you'll be heading inside the Shine Dome. We will have to let you go in a moment because you have to get ready for that moment. It's been a little while for you sort of to get to this point. What is it like actually coming to Canberra and having the opportunity to sign that charter book and join this fellowship?
It's terrific, and there's shock value in actually catching up with people in person. It's terrific that the Academy has been able to do this in person.
Yeah, that's terrific. And Beth, how about from your perspective? You're on a little bit later this afternoon. Have you had a chance to work with or meet many of the fellows from your cohort? I'm sure you'll love catching up with 2020 and 2021s as well.
So we haven't had much of a chance to connect in person as yet, so that'll be a good experience after the last few years of just being online.
Yeah, absolutely. I wanted to also just ask you both around, just to finish with, the capacity that we have for science within Australia and the need for really greater diversity in the areas of research. Beth, if I could just start with you in terms of attracting expertise but also diversity within research. Are we making any inroads there?
Yes and no. So we work with an increasingly diverse range of people in a participatory approach, so pulling people from different backgrounds, different demographics, linking different disciplines like biophysical sciences and the social sciences together. But the biggest challenge in my personal area of modelling is the lack of maths literacy in Australia. We've been going backwards and I just can't find good Australian students to hire. So increasing diversity in the maths side would be great from my perspective.
Would you echo those thoughts, Andy?
Yeah, and there's a solution. We pay our PhD students $19,000 a year to do a PhD, which is below the poverty line. So the very best and brightest kids of their generation, first-class honours degree, let's make them live for 3.5 years under the poverty line and wonder why they're not coming into science. I think it's fairly obvious. It's outrageous how much PhD student scholarships are worth.
Well, thank you both. That's a very strong note to end on. Thank you both for your leadership in the work that you do, and congratulations once again on your fellowship. Enjoy the rest of the conference. Well, from climate change, we're going to take a look now at some of the animals that are needing to adapt and in fact are adapting as a result of climate change.
Evolution has always been a key part of survival for the animal kingdom, but climate change is taking this to the next level. New research has found that some warm-blooded animals are changing their shape to adapt to higher temperatures. Several species of the Australian parrot, such as the Gangan cockatoo and red-rumped parrot, have larger beaks than 150 years ago, while mammals like the masked shrew, found in Alaska and the northern United States, now have longer tails and legs.
Warm-blooded animals have to maintain a constant internal temperature, and part of maintaining this body temperature is being able to let go of extra body heat when you get too warm. And animals can do that using various appendages, because the increased surface area of these appendages allows them to let go of more body heat when they get warm.
This reasoning is based on a theory known as Allen's rule, which states that animals in colder climates like the Arctic have smaller appendages than those in warmer climates like the tropics.
It's been proposed that maybe animals will respond to climate change in a way that follows Allen's rule, so they'll increase the size of their appendages as a response to the increased temperatures.
The researchers say climate change also explains why shapeshifting has occurred across such a diverse range of animals, but this survival tactic isn't without consequences.
What we're worried about is that there's going to be a limit to how much animals can shapeshift before it interferes with the other functions the appendage has in the animal's life and in their ecology.
And as the planet continues to warm, it may be even harder for these animals to keep up.
The Australian
Delighted to have you all with us today, face to face, after a very, very long pause. Welcome back to those who participated in this morning's admission ceremony, where we admitted the 2020 fellows and 2 fellows who couldn't make it in 2019 and could never have known that it would have taken until 2022 for their own admission ceremony. My name is Anna Maria Arabia. I'm the Chief Executive here at the Australian Academy of Science, and it's my absolute pleasure to welcome you. I'd like to begin by acknowledging the traditional owners of the land on which we meet, the Ngunnawal and the Ngambri people. It's upon their ancestral lands that the Australian Academy of Science is built, and as we share our knowledge, teaching, learning and research practices, may we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. Before I hand over to our President, Jagadish, may I ask that you place your phones on silent or any other devices you might have if you haven't done so already. But don't turn them off. We do encourage you to share your experience of this really wonderful celebration of your achievements on social media. If you can, use the hashtag ShineDome2022. I would also like to make a special mention and a special welcome to our online guests who are joining us via our live stream. As you walked in today, you would have seen a marquee outside the Shine Dome. From that marquee, we are live streaming everything that is happening throughout Science at the Shine Dome 2022. And in between the breaks, there's lots of opportunities for interviews and exclusive chats with people across the science sector, fellows, some of our sponsors, executive and council members, so that our online audience can really feel part of this terrific occasion. So welcome to our online guests. We strongly encourage attendees to practice good hand hygiene. There's a lot of handshaking happening over the next couple of days. Indeed, we would, as an abundance of caution, we might be foregoing handshakes today, if that's okay. I'm really keen to protect our executive committee and council members who really are meeting hundreds of people over the next couple of days, particularly as we go through this COVID peak. And of course, hand sanitizer sanitizer is available throughout the venue, and masks should you wish to wear one. And one final note before I introduce our President to the microphone: official portraits of our new fellows will be taken during the breaks today and tomorrow, and I invite all new fellows to please make their way to the Becker Room at some stage to have this special occasion captured. So without further ado, it's my great pleasure to welcome President of the Australian Academy of Science, Professor Jagadish.
Thank you, Anna Maria. I also pay my respects to the traditional owners of the lands we meet, Ngunnawal people and Ngambri people, and I pay my respects to their elders past, present and emerging. Colleagues, it's an honor to welcome you to the Ian Walk Theatre this morning, or this afternoon. In my first year as Academy President, I could have not asked for a better start to my tenure than our return to the Shrine Dome here in Canberra, and to be celebrating excellence here with you over the next 3 days at the Science at the Shrine Dome. Australian scientists are among the best and brightest minds in the world. At our core, we ask questions and seek answers to understand our world better, and we look for ways to secure the future of our own nation and our neighbors and all over the world. Taking up this challenge isn't easy. The questions are hard and answers sometimes harder. So it is important to recognize outstanding achievements and inspire our upcoming generations to continue to question, innovate, and create. The admission of our new fellows is a time-honored tradition established by the founding fellows of the Academy and the founding fellows of the Royal Society of London before them. Upon admission, the Academy, and by signing the Academy's charter book, you subscribe to the following obligation. I hereby solemnly promise to promote, declare, disseminate scientific knowledge, and to serve the Academy according to its charter and bylaws. The charter book was a gift from the Royal Society and has been signed by every fellow of this Academy. Your signature today will sit alongside some of the world's most esteemed scientists, and you are welcome to look through what is a significant piece of Australian history at the conclusion of the ceremony to see how deep the traditions and the knowledge of this Academy, learned Academy run. To officiate the formal admissions, let me introduce our Vice Presidents, Secretary for Physical Sciences, Professor Malcolm Sambridge, and Secretary for Biological Sciences, Professor Helene Marsh. Malcolm and Helene will announce the names of each new fellow and read your citation. I invite each new fellow to come to the stage to sign the charter book and receive your certificate and lapel pin. A photo will be taken on stage before we enjoy a brief video summary of your achievements. Fellows will be called in alphabetical order to come forward and join me at the charter book. The first fellow we'll call upon is from the biological sciences, so I will now hand over to Helene.
Good afternoon. My name's Helene Marsh and I'm Vice President and Secretary Biological Sciences at the Australian Academy of Science. Our first new fellow is Professor Stephen Chown. Stephen Chown is a preeminent authority on the biodiversity and conservation of Antarctic systems and the threats posed by environmental change. He's revolutionised the way in which information on the environmental response of animals is understood at global scales, unveiling not only the nature of adaptation, but also the way in which its limits constitute problems for life in changing circumstances. He's a leader in science and conservation policies for the Antarctic.
Congratulations, Stephen. Please take one of the pens and I welcome you as a fellow of the Australian Academy of Science.
The West Antarctic Peninsula is one of the fastest warming areas on Earth. Protecting its unique ecosystem from climate change is a challenge.
For me, that's a real priority over the next several years. That is providing the scientific evidence to ensure that Antarctica is well looked after, that its ecosystems have a future, and that impacts Antarctica might have on us through, for example, ice sheet melt and so on, are mitigated and we adapt them to the extent possible.
Professor Stephen Chown is a biological scientist and expert on the biodiversity and conservation of Antarctic systems. His research has led to major advances in understanding the diversity of life in Antarctica and ways to mitigate the threat of environmental change.
As part of our research, we predicted that species from elsewhere might be able to establish on the Antarctic Peninsula right now, or certainly just with a bit of warming. And in 2012, we released a piece of research, and that year, an invasive species, the annual bluegrass, was detected for the first time exactly in the sites we predicted that the species would establish.
That research enabled Professor Chown to alert the Antarctic Treaty Parties to enable additional biosecurity. He was also instrumental in setting up an Australian-led international program called Securing Antarctica's Environmental Future, which seeks to provide scientific evidence to ensure that Antarctica's ecosystem has a future.
There's a lot of change that's already locked into the system, and it's essential for us to understand what the implications of that change is for us and how we can adapt to it.
Professor Chown says he's always had a love for nature, even as a child.
I was always fascinated by the natural world, completely obsessed, I would say.
Professor Chown came to Australia in 2012 to head the Department of Biological Sciences at Monash University. Today, he is internationally known as a leader in Antarctic conservation and science policy. His pioneering has seen him elected a Fellow of the Australian Academy of Science.
It's a tremendous honour, a huge privilege, and very exciting because the Academy opens all these windows and doors to new experiences, to new learning, and to people that one has never had the pleasure of interacting with before.
Professor Arthur Christopoulos. Arthur Christopoulos is a pharmacist and molecular pharmacologist who's made seminal discoveries of spatially distinct allosteric drug binding sites on G-protein coupled receptors, the largest class of all medicinal targets. His research at the interface of chemistry and biology, with a particular focus on neuropsychiatry, cardiometabolism, pain and addiction, is transforming the way these medicines are discovered in academia and industry.
Congratulations, Arthur. Please take this pen. I welcome you as a Fellow of the Australian Academy of Science.
While working as a pharmacist, Professor Arthur Christopoulos was struck by how inadequate many of the major classes of medicines were for common diseases. He realised many drugs acted on a specific family of proteins he'd previously studied, sparking a deep interest in finding different ways to approach these proteins.
The research that we're doing is being applied to essentially health burdens that currently have unmet therapeutic needs, in particular neuropsychiatric diseases, neurological diseases, diabetes, obesity, heart failure and chronic pain.
Professor Christopoulos is a molecular pharmacologist who focuses on novel avenues for drug discovery using the largest class of proteins encoded by the human genome. His research has contributed to seminal discoveries of drug-binding sites on G-protein-coupled receptors, or GPCRs.
90% of the medicines on the market that act on these types of proteins do so by acting on the on-off switch. They either activate the protein or they block the protein. But what I discovered is that these proteins also possess different spatial regions on them that act like a dimmer switch. So we discovered essentially a whole new class of medicines that we refer to colloquially as dimmer switch medicines.
Professor Christopoulos says he was inspired to study neuropharmacology because of his desire to help people.
There's been essentially no new drug discovery in neuropsychiatric space in at least 50 years. Now, where else would you accept that as the current standard of care?
His research has helped discover new classes of drugs for people with memory impairments and a way to more selectively target the A1 receptor with non-opioid analgesics, which he hopes will lead to new treatments for people with chronic pain.
The nature of the drugs that we discover, how they act in the body, they are very different to your more traditional medicines which either activate or block proteins in the body. These things are much more selective and therefore they have the potential to not only be more effective but to also be safer.
The son of Greek immigrants, Australian-born Professor Christopoulos is the first in his family to finish university. He's also the first family member to feature in a film with Kiwi actor Sam Neill, not for his research, but for his guitar skills. Internationally renowned for his contribution to science, Professor Christopoulos has been elected a Fellow of the Australian Academy of Science.
What's important about getting elected into the Academy of Science is that your peers in all different spheres of science have recognised that you are actually making a difference not only to Australia but to the world. When my mother asked me, what does this mean? I said, it's kind of like the Hall of Fame, Mum, but we're still going.
Good afternoon. My name is Malcolm Sandbridge and I'm the Vice President and Secretary for the Physical Sciences of the Australian Academy of Science. Our first new Fellow from the Physical Sciences is Dr. Greg Clark. Gregory Clark is a renowned scientist, technologist, businessman with an outstanding career in Australia and internationally across a spectrum of industries from IT and communications to media, space and finance. His scientific contributions have been in the areas of solid-state physics, chip technology, neutrino physics, space technology, media digitisation and cyber analysis. Greg Clark has also continually supported student education and involvement.
Congratulations, Greg. Please come and take this one. Sign this. I welcome you as a Fellow of the Australian Academy of Science.
Growing up in Tasmania, Dr. Greg Clark set his sights on becoming a professional AFL player. During a visit to Melbourne, St Kilda agreed to give him a run.
As soon as I got on the ground, I realised that I was not AFL material. So I tossed that in and moved to science.
And so began a career that would see him lead global tech companies and spearhead the way we communicate. He credits his early mentors while doing a PhD in nuclear physics at ANU in Canberra with encouraging him to think big.
The value of mentors can't be overstated.
Out of university, he received a Harwell Fellowship in the UK, applying nuclear physics techniques to semiconductor technology. He then moved to CSIRO, where his work on mineral physics and semiconductors saw him recognised by the Australian Academy of Science in 1979 with the Pawsey Medal. Soon enough, he was being headhunted by IBM Research in New York.
It was the best research period of my life. And the thing I learned there was teamwork.
The team wasn't small. He was surrounded by 700 research scientists, creating technology that still underpins computing and communications today. Dr. Clark spent 15 years at IBM. That included setting up joint research programs with Australia, such as establishing a supercomputer facility at the Australian Institute of Marine Science in Townsville to monitor water flow between the Great Barrier Reef and mangroves. The project won a United Nations Environment Award. And then in 1993, he got a call from Rupert Murdoch asking him to run technology for News Corp.
I think I've been very lucky in life. That was perfect time to go to News Corp.
It was a time for big changes in big media. Dr. Clark was responsible for transitioning News Corp from analogue to digital across films, print and television. He even lived on the famed Fox Studios lot in Los Angeles. Dr. Clark was becoming increasingly interested in satellites and took a position as Chief Operating Officer and President of the world's largest commercial satellite manufacturer, Loral Space and Communications.
There's almost no aspect of our society that isn't dependent on satellites now.
Dr. Clark says no matter which role he's had, science has always underpinned it. Because science, he says, is key to a nation's future across all disciplines from health to defence, agriculture to manufacturing. As a Fellow of the Australian Academy of Science, he wants to advocate for science to be given a seat at the table whenever key decisions are made.
I think the Academy needs to push to get on that table.
Professor Brendan Crabb. Brendan Crabb is a pioneer of genetic technologies in human malaria, fundamental discoveries in malaria parthenogenesis. His team discovered the malaria translocon, a protein machine that allows the translocation of malaria proteins into its host cell, a highly vulnerable point in the parasite's life cycle. He was the first to provide an order for the myriad of receptor-ligand interactions that mediate red blood cell invasion by malaria parasites.
Congratulations, Brendan. Please. Welcome you as a Fellow of the Australian Academy of Science.
Every year, malaria kills hundreds of thousands of people, many of them children under 5.
We've had a lot of good anti-malarial drugs and they're a very, very important part of malaria control, but the parasites become resistant to them all.
Professor Brendan Crabb is an infectious disease researcher with a special interest in malaria. His work aims to better understand malaria parasite biology and develop new drugs.
Malaria is probably at least the equivalent of the most important infectious disease humans have ever faced. It's probably the first zoonosis. That means a parasite that went from a gorilla into people 50,000 years ago, and ever since then it's caused devastation for our world.
Having grown up in Papua New Guinea, Professor Crabb contracted malaria several times. He says the experience living there for almost a decade helped shape the scientist he's become.
I'm sure it influences me now quite a lot in looking for solutions to this incredibly debilitating, poverty-inducing infectious disease.
Professor Crabb is a pioneer of genetic technologies in malaria and has made several significant discoveries, including describing the first gene knockout in the malaria parasite. Gene knockouts allow genes to be switched off one by one, so scientists can determine the precise role each one plays in infection. The use of this technique in malaria has underpinned the last 2 decades of research into the parasite, including potential vaccines. His team also discovered the malaria translocan, a structure that allows the parasite to move proteins into its host red blood cells.
That one function that this molecular machine has can interfere or is affected a nexus for 500 different protein functions. The discovery of that machine was significant biologically, but also as a potential target for drugs, because if you target that one machine that's a nexus for 500 other proteins, you can interfere with the function of all of those proteins with one simple drug.
Professor Crabb's significant contributions to medical research have seen him elected a Fellow of the Australian Academy of Science.
It is the most prestigious science award in this country, so it's fantastic from that perspective, but it's also fantastic because of the Academy's role in promoting science. I'm really looking forward to being a part of that.
Professor Mark Dawson. Mark Dawson focuses on the biological mechanisms by which epigenetic regulators facilitate the induction, maintenance and progression of cancer. He's made several paradigm-shifting discoveries into epigenetic mechanisms of cancer stem cell maintenance, resistance to anti-cancer therapies and regulation of anti-cancer immune surveillance. His research has directly contributed to the development of several first-in-the-class epigenetic therapies that have been studied in clinical trials in at least 20 countries.
Congratulations, Mark. Could you please sign here? I welcome you as a Fellow of the Australian Academy of Science.
Why is it that 2 patients with identical cancers will respond differently to the same treatment? It's a question that Professor Mark Dawson first encountered while training as a haematologist.
This could not be explained by looking at the cells down a microscope, by imaging the patient, or by any of our other conventional methods. And therefore, it really led me to want to pursue this question in greater detail, which is why I chose to train as a discovery scientist.
Today, Professor Dawson is a leader in the field of cancer epigenetics. Epigenetics is the study of how cell activity can be modified by changing how the DNA sequence is read. Epigenetic changes turn genes on and off. Unlike genetic mutations, they can be reversed, offering a unique opportunity for therapeutic intervention.
What we have learnt over the last few years is that cancers adapt without necessarily changing their genome.
Professor Dawson's team investigates how cancers rewire their ability to express genes in order to evade treatment. They're also developing new drugs which can reverse epigenetic changes by targeting the proteins involved.
Over the last decade, my research has helped identify exactly how these proteins control transcriptional regulation. We've defined the exact domains of these proteins that are amenable to therapeutically targeting. And then we have helped our industry partners develop, characterize, and start to implement small molecule drugs against these proteins.
He says the epigenetic drugs themselves can't cure cancer, but by forcing cancer cells to make more predictable decisions, they can improve other therapies that kill cells, including conventional chemotherapy.
This combination is far better than the sum of their parts. And here we are really starting to see meaningful outcomes that have changed the standard of care for many older patients with blood cancers, including acute myeloid leukemia.
To this day, Professor Dawson still sees cancer patients. He says being a clinician scientist puts him in a unique position of bridging the gap between clinical practice and cutting-edge discovery science.
And it is really, really important for governments around the world to appreciate the fact that our discovery scientists are making the discoveries today which will fuel therapies in the next decade. And it is that needs to be supported right now.
A message he intends to share widely as a Fellow of the Australian Academy of Science.
Professor Yi-Hong Du. Yi-Hong Du is an internationally renowned for his contributions to the theory of nonlinear elliptic and parabolic partial differential equations and their application in chemical reaction theory and population dynamics. He is a leader in the use of nonlinear free boundary problems to model spreading phenomena and has resolved long-standing problems on sharp thresholds, boundary blow-up, bifurcation, and multiplicity.
Congratulations, Yi-Hong. Please sign here. I welcome you as a Fellow of the Australian Academy of Science.
Mathematician Professor Yi-Hong Du first came to Armidale in the early 1990s as a postdoctoral research fellow at the University of New England.
When I started the postdoc, I was thinking after I finished, I would go back to China, because after I finished my PhD, I got a job at the same university, and the university wanted me to go back.
But with various uncertainties in China at the time, Professor Du instead accepted a teaching position at the University of New England. 30 years on, he's still here. Across that time, he's become world-renowned for applying pure mathematics to a range of complex real-world problems. Problems such as biosecurity threats.
We think about invasive species, and we try to understand whether the invasion can continue or they'll stop.
Many mathematical models use partial differential equations, but over fixed domains. That often means they fail to factor in a certain complexity of the natural world.
So it's better to modify the equation to consider them sitting on a moving domain.
By doing that, Professor Du has been able to make more accurate descriptions of how things will spread. His techniques have been used in a variety of fields beyond invasive species, such as the impacts of climate change and even how wounds will heal. Professor Du may live in regional New South Wales, but his collaborations are global, and many of his scientific partners have made a point of visiting Armidale.
We have lots of walks on campus, and during the weekend we go to some national parks. I like the lifestyle.
He describes becoming a Fellow of the Australian Academy of Science as a great honour and regards it as encouragement to keep pushing the boundaries of mathematics.
Professor Robin Gasser. Robin Gasser's fundamental research into the biology of parasites, their interactions with their hosts and the diseases they cause, has led to a range of advanced technologies to explore their genomes and functions. This research underpins the development of innovative methods for the diagnosis, treatment and control of socio-economically important parasitic diseases of animals and humans for subsequent translation and commercialisation.
Congratulations, Robin. Please. I welcome you as a Fellow of the Australian Academy of Science.
Parasitic infections are a major public health problem, affecting more than 1 billion people worldwide. They also cause a variety of diseases in animals. Controlling their spread and developing new treatments is a constant battle.
So a lot of the currently used methods and drugs that are used to combat parasites in animals are now no longer effective, and so we now need to work towards getting new compounds, better treatments into the field so that farmers can use them to better control their parasites.
Professor Robin Gasser is a veterinary scientist. He grew up on a farm, learning about animal diseases and the problem of drug resistance from a young age. For the past 35 years, he's been researching the control of parasites in humans and animals, particularly livestock.
We're really focused very sharply on trying to find the Achilles heel in parasites.
Professor Gasser's research has informed our understanding of the biology of multiple parasites and how they cause disease. Understanding the relationship between a parasite and its host enables the development of new strategies to interrupt that relationship.
We're now focused on trying to use that information to guide us towards developing new drugs and vaccines against parasites. So that's a particularly exciting period in science because there's a massive revolution in digital technologies, machine learning, artificial intelligence, and those advances are allowing us to better analyse molecular data.
Although he initially wanted to be a motor mechanic, a sense of discovery led Professor Gasser into science.
Science is fantastic because there's always something new around the corner. I love the process of science because you're always consistently breaking new ground and moving ahead, so it's tremendously exciting.
A journey that has now seen him elected a Fellow of the Australian Academy of Science.
Professor Glenda Halliday. Glenda Halliday is acclaimed internationally for her research on neurodegeneration. She established the Sydney Brain Bank and applied her expertise to clinico-pathological correlations, revealing the anatomical, biochemical, molecular and genetic characteristics of several neurodegenerative diseases, particularly Parkinson's disease and frontotemporal dementia. Her work has changed international diagnostic criteria, providing differentiating characteristics for neurological diseases, and she's developed disease staging schemes.
Congratulations, Glenda. of Science.
Professor Glenda Halliday studies the human brain.
The reason I got interested in it is because we don't really understand why your brain degenerates.
Brain degeneration seems to be unique to humans. From what we can tell, other members of the animal kingdom don't encounter the same problem.
That got me thinking that there probably are unique aspects to human brains and human neurons that is different from other animals. And in fact, some of the research I've done has shown that.
The human brain is full of neurons, also known as nerve cells. Some have pigments similar to the ones found in eyes. Those pigments haven't been spotted in any other primate species or rodent studied in a lab.
So there's some unique characteristics about the cells in the human brain that actually, if we don't look at the human brain, you would never know.
But looking in that detail in the human brain isn't simple. You can't examine someone's brain cells while the person is alive. So Professor Halliday established the Sydney Brain Bank. Donors undergo detailed health assessments during their life before their brain and spinal cord tissue is studied after their death. The bank currently has 10 brain donor programs, allowing researchers to focus on conditions such as Alzheimer's, Parkinson's, and motor neuron disease.
So we keep knowing more, but I don't know when we'll know enough. We still don't know what causes any of the neurodegenerative diseases, any.
Without knowing the cause of a condition, it makes treatment especially difficult. But the work Professor Halliday and her team are doing has been credited with changing international diagnostic criteria by differentiating the characteristics for neurological diseases. She says she's honoured to become a Fellow of the Australian Academy of Science and hopes it inspires other researchers to keep tackling some of the human body's most complex mysteries.
Professor Rob Hindman. Rob Hindman is one of the world's most recognised applied statisticians and is internationally acknowledged for his research in time series forecasting. Although time series data are widely used in many fields of science and business, forecasting is notoriously challenging. Rob's textbooks and software have transformed the capability of many organisations to make accurate predictions.
Congratulations, Rob. I welcome you as a Fellow of the Australian Academy of Science.
Professor Rob Hindman has a job that keeps him one step ahead, even during the COVID-19 pandemic. While most of us woke to updates on daily infection rates, his team was using statistical tools to help the Australian government predict what would happen next.
So ever since March 2020, every week we have produced forecasts of COVID case numbers for every state in Australia. Those forecasts get used to decide policy responses to help with the pandemic.
Professor Hindman is renowned for his research in statistical forecasting. His algorithms have enabled organisations around the world to produce forecasts from millions of datasets. Professor Hindman was among the first researchers to develop automated time series forecasting methods that could work at very large scales. His work has many applications.
For example, a retail company will produce forecasts of sales so that they can make sure they have enough stock in the stores to meet the demand. Electricity companies forecast the demand for power so that they can make sure they have generating enough power for the future.
Professor Hindman was instrumental in creating one of the most used forecasting models in the world. Initially, he co-developed state space models to better determine projected costs for the Australian government's pharmaceutical benefits scheme.
Forecasting the difference between what actually happened and what they were forecasting before I got involved was about between $0.5 to $1 billion. After we built these models, it was more like $50 to $100 million. So it was a huge improvement in accuracy.
More recently, Professor Heinemann has also become involved in anomaly detection. He works with the Queensland Government to monitor their river network and look for any unusual activity, which could be an indication of pollutants or a sensor malfunctioning.
Once you've got thousands of sensors along lots of rivers, you can't actually manually monitor them anymore. You need some algorithmic approach to do it.
These same algorithmic approaches can be used in industries like banking to detect fraud.
I get a buzz out of seeing my work used everywhere, and that's one of the reasons that very early in my career I decided to write open source software implementations of whatever methodology I develop. And that's been key to the impact that I've been able to have. My forecasting algorithms are downloaded several million times every year and get used in pretty well every industry in the world.
For his remarkable contributions to science and its applications, Professor Heinemann has been elected a Fellow of the Australian Academy of Science.
Professor Dorit Jakob. Dorit Jakob's innovative and world-leading research exploring shallow and deep carbon behaviour is unravelling the underlying mechanisms of carbon mobility, sinks, sources and speciation at nano to global scales. She has pioneered research in Australia in the emerging field of biomineralisation and leads significantly new directions globally by integrating advanced imaging and microanalytic methodologies with innovative life science approaches.
Congratulations, Doug.
welcome you as a Fellow of the Australian Academy of Science.
Curiosity drives scientists to investigate unexplained phenomena, like how diamonds are formed hundreds of kilometers below the Earth's surface, or how clamshells and pearls are made.
My research looks at the basis of how organisms form their shells, but the implications from that research is that how these organisms can survive in an ocean that gets more acidic in the future, and how we have to adapt our aquaculture methods to feed our people in the world.
Professor Dorit Jakob is a geochemist, and in 2020 she became the first female director of the ANU Research School of Earth Sciences. One of her first projects in Germany was researching the only gemstones made by living creatures.
We had people from retail coming to us with pearl necklaces that had white spots, and they said, well, we can't sell those, so what's happening there? So we started studying this, and we found out whole lots of things where we thought this has all been known, but instead it was actually all new. That's kind of what triggered my curiosity, and that has developed in quite a solid field of research.
Professor Jakob seeks to understand the fundamental processes of Earth's carbon cycle, from the surface down to the depths of our planet. In Australia, she's conducting pioneering research in biomineralisation, where living organisms create mineral structures.
I'm using methods and instrumentation in the field of clamshell research that are not normally used in the diamond research, and I use those methods on my work in diamonds, and that gave us an insight at very small scale, and we found direct proof for how diamond actually forms.
Professor Jakob's research involves working with scientists from many disciplines. Her collaborative approach is helping facilitate findings in other fields.
Understanding how an organism forms a mineral is really important for teeth, for bones, for all of these medical reasons, as much as it is for marine species.
With so much still to learn and discover, Professor Jacob is thrilled to become a Fellow of the Australian Academy of Science.
Professor Barbara Novak. Barbara Novak's research on the effects of pollutants and environmental factors on fish diseases has advanced understanding of fish health and contributed to sustainable aquaculture. With her Norwegian collaborators, she discovered a new type of lymphoid tissue in salmon gills, redefining directions in fish immunology. She's developed methods used worldwide to assess fish health and investigate fish diseases.
Congratulations, Barbara. I welcome you as a Fellow of the Australian Academy of Science.
As the demand for seafood has increased around the world, new technologies have been developed in aquaculture industries to breed, rear and harvest fish and shellfish. But one of the biggest challenges is maintaining fish health and minimising disease.
My research contributes to the sustainability of aquaculture by improving fish health and also understanding better impacts of different factors, including pollution, on fish health.
Professor Barbara Novak is an expert in aquatic animal health and works with international aquaculture industries to solve problems related to farmed fish diseases. She led a research project that investigated the problem of blood flukes in bluefin tuna, a parasite that can kill fish. Her findings help reduce bluefin tuna mortality in the Australian industry from 12% to less than 1%. This blood fluke needs 2 hosts to complete its life cycle, tuna and another host. The team, led by Professor Novak, discovered the host of one of the blood flukes affecting bluefin tuna.
And following that, everybody focused on the same group of animals, organisms to follow, and they discovered many other hosts for other species of blood fluke. So we really led international field in this area. And that was a really huge wow moment, which was very important for the industry as well.
Professor Novak has also worked with the international salmon farming industry to identify a parasite that causes gill disease in salmon. Her research methods and knowledge have been adopted around the world, which improves fish health and enables fish farms to be more sustainable. Professor Novak's research also highlights the use of fish health as a biomarker of pollution, including investigation of the effects of environmental changes on wild fish.
Wild fish live in natural environment and they will eat whatever is there, and if it is contaminated by pollutants, then they will also accumulate the contaminants in their bodies.
Born in Poland, Professor Novak says she was inspired to study science by the life and achievements of Marie Curie. But it was her love of fish and the ocean that brought her to Australia in 1985 to do her PhD. And now she has been elected a Fellow of the Australian Academy of Science.
So now I'm the first female fellow at my university, so very, very, very honored.
Professor Andy Pittman. Andy Pittman is an international authority on the role of land surface processes in the climate system, including their influence on regional rainfall and temperature extremes. As a direct consequence of Pittman's work, there's now an accepted role of land cover change in regional climate projections and a new field devoted to utilising land cover to mitigate the worst impacts of regional climate extremes.
Congratulations, Andy. I welcome you as a fellow of the Australian Academy of Science.
This was the Bolivian province of Nuflo de Chaves in 1984. This is the same place in 2020. Mato Grosso, Brazil in 1984. And once again, the impact of humans is clear. Be it by fire, chainsaw, or bulldozer, we have perfected the clearing of forests. But such significant change to land cover has a direct impact on climate.
The land is where energy from the sun, water from the clouds, and carbon are exchanged in one place at one time.
Professor Andrew Pittman is an international authority on the role of land surface processes in the climate system. He doesn't think the world will be able to limit warming to 1.5 degrees.
We therefore have to be able to walk and chew gum at the same time. We have to be able to adapt to what we're already committed to, and we have to mitigate emissions so that we don't have to adapt to things that exceed our capacity in the next 20 or 30 years.
Professor Pittman says the land can help with both. His work has shown that changes we make to land cover, both good and bad, have local consequences. That means countries could look at regional measures such as greening cities to keep them cooler, or generating crops that are more reflective.
Local-based solutions for the local community responding to a global problem.
But the best way to solve the global problem is to dramatically cut emissions. He doesn't have great confidence in the ability of governments to deliver that. He says the scale of intervention needed just isn't happening. But he's relieved that many business leaders are now refusing to wait.
Issues around reducing carbon emissions, around solutions to climate change, are changing decisions in boardrooms, so trillions of dollars move from the fossil fuel sector into the renewable sector. We just have to make sure those trillions of dollars move into the optimal solutions, not just a bit better than coal.
Born in Bristol, Professor Pittman came to Australia after finishing his PhD. He planned to stay a year, but then couldn't think of a good reason to return to the UK. His dedication to understanding our climate has now seen Professor Pittman elected as a Fellow of the Australian Academy of Science.
Professor Barry Pogson. Barry Pogson has revealed how communication between different plants of a cell, different parts of a cell, influence growth, development, photosynthesis, and tolerance to drought. He's enabled new insights into the evolution and function of retrograde signalling networks in gene expression, photosynthesis, leaf development, and even water loss during droughts. Pogson has actively sought the translation of his basic research into beneficial outcomes and mentors upcoming leaders in science, policy, and industry.
Congratulations, Barry. I welcome you as a fellow of the Australian Academy of Science.
Professor Barry Pogson researches plant communication.
If you think in humans, one species, we have 6,500 different ways of saying hello. So how do plants communicate?
And not just with each other, but within the plant itself.
The plant needs to both detect what's happening and then communicate it to itself and understand the message it's receiving.
Professor Pogson's research has revealed crucial pathways by which communication between different parts of a cell influence plant growth, photosynthesis, and even tolerance to drought. One key component is a very small structure found in plant cells known as the chloroplast, which is responsible for capturing light and converting it into energy.
And what we discovered was a signal which the chloroplast produces under drought stress and tells the nucleus to turn on lots of genes that help protect the plant.
His team conducted field trials on wheat crops across southeastern Australia.
By trying to tune the signal, change the intensity of the signal, we found that we can increase its activity in a way that makes the plants more drought tolerant and the plants are yielding more.
As often happens with science, the breakthrough came at an unexpected moment.
The first time we found that this chemical signal made our plants more drought tolerant was seeing the plants looking better after they were unwatered for a few days. And that was a serendipitous discovery, which we had reason to believe, but we hadn't seen it yet. When we started this research, we didn't know it could lead to a more drought-tolerant crop, but now we're working with companies to try and turn it into something that's useful.
Producing crops that are more resistant to drought has become a global priority as our climate warms. But while he's focused on the future, Professor Pogson believes we can learn a lot from the past, especially from Indigenous communities.
Starting to learn their history of agricultural practices, how they managed the land, the crops they grew and harvested. Some Indigenous crops have more protein in them than chicken.
Professor Pogson's work has enabled a better understanding of plant physiology and has now seen him elected a Fellow of the Australian Academy of Science.
Professor Ian Reid. Ian Reid's works in computer vision has made landmark contributions in visual geometry, tracking, novel view synthesis, visual surveillance, and simultaneous localization and mapping. His emphasis on real-time processing and systems work means that he is one of few researchers worldwide to be active in both computer vision and robotics. His work has been instrumental in bringing computer vision into the mainstream of the robotics literature.
Congratulations, Ian. I welcome you as a Fellow of the Australian Academy of Science.
Hollywood movies such as The Terminator and RoboCop lead us to see autonomous robots as things to fear.
What I'd much prefer people to think about when they're thinking about how computer vision impacts their lives is the extra pair of eyes that can be provided to a surgeon conducting life-saving surgery, or the robotic helper that is able to enable people to have much more fulfilling, independent lives as they age.
Professor Ian Reid is one of the scientists shaping that future reality.
My research is motivated by the idea that we can try to make computers see. So the idea that you can take a camera and a computer and put them together to act a little bit like a human eye and a human brain together.
When he first started working in the field 30 years ago, the dream was to have computers recognize key objects in images.
For the first few decades of computer vision, I would say it moved pretty slowly and there weren't any commercial applications.
But the big tech companies saw the potential and soon injected major money into the field.
For example, an application of actually pretty limited computer vision, but at scale that we wouldn't have imagined earlier, is Google Street View. The fact that you can use computer vision technology to paste together images that have been taken at a global scale would not have been contemplated even 15 years ago.
Professor Reid says computers have moved beyond being able to recognize key objects in scenes.
Nowadays, we're more interested in generating a full understanding of the scene from our cameras and from our video, so that we can, for instance, enable a robot to navigate through a room, not just seeing what objects are there and recognizing them, but working out where they are in relation to one another and being able to plan paths through.
That's the same technology now being trialled in self-driving cars. Professor Reid has published more than 200 papers and remains at the forefront of innovation as head of the School of Computer Science at the University of Adelaide. He'll continue to advocate the benefits of computer vision as a new Fellow of the Australian Academy of Science.
Professor Alison Roger. Alison Roger invented 4 techniques that use polarized light to reveal the structures of complex biological molecules. She has also improved techniques to extract extra information about biomolecules. These approaches are particularly valuable in the development of biopharmaceuticals. She has successfully commercialized her inventions, which are now widely used by major companies and have significantly changed the biopharmaceutical research and development process.
Congratulations, Alison. I welcome you as a Fellow of the Australian Academy of Science.
Professor Alison Roger describes molecules as the fundamental building blocks of our world. It's her job to investigate how those building blocks interact.
You might have 2 molecules and you change what's on the edge of them so that they might be attracted together to assemble into a new structure.
Understanding those interactions is critical for applications such as pharmaceuticals.
We can take molecules into biological systems and hopefully begin to cure diseases by designing those molecules for where they're going to target and where they are going to influence how the biology of our bodies behave.
A useful endeavour, but not one that's easy.
The molecules I look at, the real challenge is we can't see them.
So instead, Professor Roger investigates how molecules interact with light. Some absorb light, for example, while others may reflect it away.
We're trying to deduce what the molecules look like by how they respond in some way, shape or form.
Professor Roger has become very good at deduction, thanks in small part to a series of novel techniques she invented.
My exciting work happens when somebody comes along and says, I think I've got a really interesting molecular system, it's doing really strange things and I don't understand it. So then I put their molecules in the instruments that I've designed or developed, and then we try to understand their exciting molecules.
Her techniques are used often to advance fundamental research. but some have also been commercialized and credited with changing the way pharmaceuticals and biopharmaceuticals are developed.
I'm absolutely convinced that molecules and intermolecular interactions are the key for us understanding and controlling much more of our world, whether we want to worry about the next drug to solve the current disease or whether we're worrying about climate change and all the other big problems that we're facing. Molecules are at the core of how we can deal with them.
Professor Roger has been based at Sydney's Macquarie University since 2017 after more than 20 years at the University of Warwick. Her election as a Fellow of the Australian Academy of Science is recognition of her international leadership in research and her active support for the advancement of women in science.
Professor John Sader. John Sader has revolutionised the characterisation of materials using the atomic force microscope. His scientific contributions have enabled breakthrough discoveries in material science at the molecular and atomic scale. He has made important contributions across nanomechanics, plasmonics, rarefied gas dynamics, and fluid structure interactions ranging from nano to macro scales.
Congratulations, John. I welcome you as a Fellow of the Australian Academy of Science.
Professor John Sader describes fluid mechanics as deeply beautiful.
Understanding some of the fundamentals of how fluids move, behave, you start looking at the world a little bit differently. Once you start getting your head around it and begin to understand the subtleties involved, you can see it all around you because we live in a fluid. It's called air.
Although now a professor of applied mathematics, his PhD was in electrical engineering.
It's really interesting having both an engineering and science background. There are two different ways of viewing problems. I feel like I bring both aspects to any problem which I may encounter.
And so it was when Professor Sader was asked by experimentalists in 1992 how to measure the spring of the delicate cantilevers on atomic force microscopes, advanced instruments that reveal the molecular and atomic detail of materials and biological specimens.
What they really wanted to know was how stiff is this lever? Right? Now you might say, oh, it's pretty easy, just push on it, you can see how stiff it is. But it's really tiny. It's about the width of a human hair.
The measurement was critical in order to calibrate the machines. Professor Sader's knowledge of fluid and solid mechanics, together with his background in engineering, enabled him to devise a practical method based on working out the maths of how cantilevers interact with air.
We started off by solving for one type of cantilever, right, back in 1999. And over the years, I worked out how to generalize it to any type of cantilevers. And there's many different types now.
The breakthrough garnered immediate interest worldwide and became known as the Sader method. Solving problems with useful solutions has become standard practice for Professor Sader.
People ask you all sorts of questions in all sorts of different areas, and you need a hook into the problem to get started. And as you get older, right, you have more experience, and then the hook gets a little bit easier.
His toolkit of techniques has been applied across areas as diverse as nanomechanics, plasmonics, rarefied gas dynamics, and even how flags flap in the breeze. Professor Sader says it's an honour becoming a Fellow of the Australian Academy of Science, especially since he's built a career out of having fun with maths, science and engineering.
I feel very fortunate in being able to just play around. It's fun for me. I mean, I don't feel like I work.
Professor Margaret Shiel. Margaret Shiel, a distinguished chemist, is a leader in the scientific and university sector. A trailblazer for women in science, she's Vice-Chancellor and President of Queensland University of Technology and Chair of the Queensland Museum Network. She's a strong advocate for science and scientists, especially early career scientists, women researchers and outstanding scientific mentors. She's played and is continuing to play a pivotal role in national science policy and has consistently sought to ensure that Australian scientists have access to world-class infrastructure and funding schemes.
Congratulations, Margaret.
I welcome you as a Fellow of the Australian Academy of Science.
Women in STEM have come a long way since Professor Margaret Shiel became Australia's first female chemistry professor in 2000 at the University of Wollongong. But women still only make up around 30% of the STEM workforce.
Unquestionably, we've come a long way, but the pipeline doesn't fix it, right? So it's not just a matter of time. You have to really make the structural changes at institutional levels and around people's careers to ensure that we aren't inadvertently putting barriers in the way of women.
Inspired to study chemistry by her mother, who was a nurse that worked in the chemistry department at UNSW, Professor Shiel is a pioneer for women in STEM. When she was the CEO of the Australian Research Council, she increased research funding for women with 2 laureate fellowships, the Georgina Suite and the Kathleen Franklin.
What they did was provided these amazing researchers with funds to support other women, and the outcomes of that have included the initiation of the Athena Swan and a range of other mentoring programs for women.
Professor Shiel then went on to become Provost of the University of Melbourne and is now the Vice-Chancellor of the Queensland University of Technology. And over the past 2 decades, she has helped improve the lives of women in STEM and champion diversity in science.
There's so much evidence that if you have a diverse group working on problems or working in teams, that you get better outcomes. So that's what I think we need to do. We need to, across all our institutions, ensure that we're reflecting the society we're trying to serve.
And for Professor Shiel, that includes trying to encourage more Indigenous students and staff into higher education.
We've got an elder in residence now, we've got partnerships with key Aboriginal organisations, and I think people feel that it's a real palpable difference in how we embrace our Indigenous colleagues here at QUT.
As a distinguished chemist and scientific and university leader, Professor Shiel has been elected a Fellow of the Australian Academy of Science.
Oh, well, it's wonderful to be amongst so many amazing scientists and to be recognised in that way. I'm just delighted and honoured.
Professor Sveta Venkatesh. Sveta Venkatesh is a leading computer scientist who has made fundamental and influential contributions to the field of activity and event recognition in multimedia data. Venkatesh pioneered many theoretical and algorithmic foundations for detecting normal and anomalous activities and deriving meaning from digital video. This underpinning theory has significantly impacted applications, including in automated security and video search, as well as advanced risk prognosis algorithms for medical data.
Congratulations, Sweta. I welcome you as a fellow of the Australian Academy of Science.
Artificial intelligence, or AI, has become ubiquitous in modern life. It's often employed to help solve problems or make predictions much more efficiently than a human could.
Data has a lot of patterns, and some of these patterns are very useful. For example, they can be used to predict events in the future, or they might indicate to you that there's an abnormality or something is wrong.
Professor Sveta Venkatesh is an internationally renowned computer scientist who works in artificial intelligence. She's pioneered new technologies in large-scale pattern recognition, which sift through video data for anomalies that might represent security threats.
The idea was that for every camera would learn what's normal and be able to detect what's abnormal in it, so that you could have a city with thousands of cameras and you could just have 2 guards watching them, because the camera would automatically tell you what is abnormal.
Professor Venkatesh's research has also helped develop a health analytics program that enables doctors to predict suicide risk. She's even helping teams making new alloys, nanofibers and biomaterials to streamline their experimental designs. Her research also contributed to the Toby Playpad app, which provides therapy for children with autism.
We did it with speech therapists and a lot of experts in the field, and effectively made the parent the therapist for that period of time. And it was the first computer-aided method of doing it at that time.
Professor Venkatesh immigrated to Australia in 1983 when her son Akshay was just 2. He won the prestigious Fields Medal for Mathematics in 2018 and became a Fellow of the Australian Academy of Science in 2019. Now she has also become a Fellow, making them the first mother and son to be elected.
We're just a normal family doing dorky things, really. It just so happened that he won the Fields Medal and he's in the Academy and I'm in the Academy. That's kind of cool, right? That's very cool.
Professor Hala Zreikat. Hala Zreikat has made significant contributions to biomaterials, regenerative medicine and translational orthopaedic research. She introduced advanced cell, molecular biology and nanoscience approaches to the biomaterials field. Her achievements are leading to the development of novel orthopaedic implants, including the world's first synthetic material for healing large bone defects under load, enabling personalised approaches to the repair and regeneration of musculoskeletal tissues.
Congratulations, Hala. Thank you. I welcome you as a Fellow of the Australian Academy of Science.
Imagine if we could rebuild human bones by using a 3D printer. Most bone grafts currently used in orthopedic surgery include metal components such as plates and screws. Professor Hala Zreikat and her team were determined to come up with something better.
The material we developed were inspired by the composition of bone.
Just like metal, the material had to be strong to match the load-bearing ability of bones. But unlike metal, they wanted their material to actually encourage natural bone to grow. The synthetic material can be printed in any shape or size to fit a specific bone defect and is designed to degrade and disappear from the body once enough new bone is formed. Work on the project began in 2012. The breakthrough came when the material was shown to work in animals.
I do remember that moment, and right away I knew we're on something very, very big.
The remarkable innovation was made possible by Professor Zrijkat working at the interface of engineering and medicine. She's director of the Australian Research Centre for Innovative Bioengineering.
I have a one-stop shop because I have access to medicine, science, engineering, everything.
But her career in science almost didn't happen. After growing up in Bethlehem, she was keen to study interior design upon returning to her native Jordan.
To study interior design meant that my father had to sell lands and send me to England because we didn't have interior design at the time in Jordan. I didn't want him to spend more money, so I opted to go into science.
Her studies soon brought her to Australia, where she completed her PhD in orthopaedic implants at UNSW. Since then, Professor Zrijkat has risen to become one of the most influential figures in Australian engineering. But she says finding success in the field as a woman is not easy.
I am so sad that it is the case. I even get emotional when I think of that. Clearly there is a problem. And it's not getting any better at all. Trust me. I am in engineering and I know it's not getting any better at all.
She says Australia is at risk of losing out on the best talent unless our culture changes. That's a message she's keen to continue sharing as a new Fellow of the Australian Academy of Science.
Congratulations to all our new fellows. I now invite Jagadish to the microphone to provide the President's address.
What a treat. What an exciting science. Thank you, Malcolm Helaine, and welcome to our 2021 new fellows. As I stand here today, officially welcoming our 2021 fellows to the fellowship, I cast my mind back to 2005. 2005 was the year that I stood where you're all now and made my own solemn promise to promote, declare, and disseminate scientific knowledge and to serve the Academy according to its charter and bylaws. 17 years later, I look back on that day and reflect on the importance of upholding the promise now and more than ever. Historically, Academy has been a symbol of scientific excellence, delivering on our remit to advance Australian science and showcase excellence at home and abroad. The Academy has always been a trusted source of evidence-based counsel. It has been science that has been propelled our community forward, whether through medicine, technology, defense capability, environmental studies, so much more. There is not one part of our history or our future that is not touched by science. This is true today as it was on the foundation of the Academy in 1954. We need only to look over our shoulders at the past 3 years and the advent of COVID-19 to see the importance of science in everyday life. It was science that illuminated a pathway through the pandemic, and it will be science that helps us to navigate the future. In my youth, studying by the light of a kerosene lamp in India, I had no idea that my love of learning would one day see me standing here in front of you. But I'm thankful that it did. It is wonderful to be in the company of so many with the same passion for science and love of learning, and it is not only our responsibility, but also our privilege as Fellows of the Australian Academy of Science to extend that joy for the benefit of all and to celebrate, promote, and honor science as a keystone of each and every community. Today is a reminder to all Fellows, old and new, of our commitment. This is a promise that we make as Fellows. I encourage you to engage with the Academy to pursue this cause. There are many opportunities to engage, including through the Academy's National Committees for Science, sectional and award committees, and through regional, state, and territory-based activities. The latter, in particular, as an area that we are looking to grow, and we welcome your thoughts, insights, and ideas on ways the Academy can support you to champion science in your region. Many of you have already made significant contributions in the few years since your election, and for that, I thank you. And I look forward to working with you for many years to come. We will now watch a short video on ways you can be involved in the Academy activities.
Congratulations on your election as a Fellow of the Australian Academy of Science. You join approximately 590 Fellows who represent excellence in science. A good place to become familiar with the activities of the Academy is through its annual report, released at the AGM in May each year. You can download a copy by scanning the QR code on your screen. The governance structure of the Academy includes 17 Fellows on Council, and among them 7 Fellows on the Executive Committee. ExCom, as it's known, includes the President, the Vice Presidents, who are the Secretary for Physical Sciences and the Secretary for Biological Sciences, Foreign Secretary, Secretary for Science Policy, Secretary for Education and Public Awareness of Science, the Treasurer, and the Spokesperson for Integrity. The Fellowship team collects and maintains all the information about Academy Fellows, including the database, personal records, obituary notices, biographical memoirs, website profiles, and other material. It's very important to keep your information up to date. Let the team know if your contact details change, or if you move into a new position, and also about any significant award or prize you receive, as they are publicly acknowledged by the Academy. To update the team, email fellowship@science.org.au. The Fellowship portal on the Academy's website is where most confidential information is located, including the AGM papers, council papers, updates from the President, the place to pay your annual subscription, and the Fellowship election material. There are many opportunities for you to engage with Academy activities. These include nominating and assessing candidates for Fellowship and the Academy's awards, serving on Council or committees of Council, joining the Reconciliation Action Plan Working Group, contributing to policy and international work, engaging with Fellows in your region or state-based activities, consulting for the Academy's education programs, national committees, which are made up of Fellows and other experts within a field and help to steer engagement with their research communities and connect to the international science unions. Every day, the Academy publishes scientific information on its social media channels with over 2.4 million followers to engage, inform and influence. The information can be in the form of short articles, videos and images with detailed descriptions. Fellows are involved in the review of content and in providing scientific material that may be used. If you have questions about any of these opportunities, please get in touch by emailing fellowship@science.org.au. We're looking forward to working with you to make the most of your election to the Australian Academy of Science.
This video can be found on the Fellows portal, which you can log into the Academy's website. The Academy is its Fellows, and I know I speak on behalf of my colleagues on the Academy's Executive Committee and the Council, and also Anna Maria Arabia, when I say that our doors are always open. We want to work with you so that Academy can continue to grow now and into the future. I will end by offering once again my heartfelt congratulations and welcome to our new Fellows 2021, and thank you to everyone here today for joining us to celebrate. We'll be hosting a cocktail reception from 6 p.m. this evening in the marquee near the recently restored Ian Potter House and invite you all join us for celebratory drinks. It promises to be a lovely evening despite a bit cooler, particularly for Queenslanders and Western Australians, than you would like it to be. I now invite Anna Maria Arabia to introduce key staff members and to close this afternoon's ceremony. Thank you and good afternoon.
Thank you very much, Jagadish, and a very, very warm congratulations to all of the 2021 fellows. It's such a pleasure to hear about your work and to have you here in person. Although we're celebrating your admission today, we have, of course, called upon many of you already, so thank you for your contributions to date to the Australian Academy of Science, and we will be calling again. The Academy is its fellows, and without you, the vast majority of our work simply couldn't happen. So I'd like to now take this opportunity to introduce to you the senior management team at the Academy. These are some of the people who may call on you also and with whom you'll be working, in addition to other fellows, the Executive Committee and Council. So if our senior management team could come by. I'll perhaps across the front side.
My name is Zaki Riddell. I'm the Director for Diversity and Inclusion.
Good afternoon. I'm Nancy Pritchard. I'm the Director of International Awards and National Committees.
Hello, I'm Karen Holt. I'm the Fellowship Director and Director of the Archives.
Hello, my name is Chris Anderson and I'm Director of Science Policy.
Good afternoon, everyone. My name's Andrew Hood. I'm the Head of IT.
Hi, everyone. My name is Petra Lundgren and I'm the Director for Future Earth Australia.
Good afternoon, everybody. My name's Melissa Abberton and I'm the Chief Operating Officer of the Academy.
Hello there. My name's Claudette Bateup and I'm the Director of Education.
And hello, it's great to see you all here in person. My name is Paul Richards. I'm the Director of Communications and Outreach.
Thank you so much. Thanks team. We encourage you all to stay in touch and indeed do visit us either here at the Shine Dome or at Ian Potter House. Both of these buildings are yours. They're for you to enjoy. When you're visiting Canberra, whether that's on Academy business or not, please do pop into Ian Potter House. You can leave luggage there and get on with other things or take meetings, or there are ample meeting rooms. There's now a Fellows Lounge. We recently renovated Ian Potter House, so many amenities are there that were not there previously. So a Fellows Lounge for you to sit down, have a cup of coffee. I know staff really, really enjoy interacting with our fellows in our annual staff survey. It's one of the things that they value most about working at the Academy, and that's working with our fellows. So we really do encourage you to pop in whenever you're in Canberra. If you're in Canberra base, walk across the way and we'll see you. So as we draw this admission ceremony to a close, I ask that all 2021 fellows meet in the foyer for a group photo. I also take this opportunity to remind you to make your way to the Becker Room for your official Academy portrait when is convenient to you over the coming days, so today or tomorrow. I also invite you to enjoy afternoon tea, which is being served in the Jaeger Room, the Dorothy Hill Room and the Marquees outside. For those with dietary requirements, special meals will be available in the Dorothy Hill Room. And please do make use of the lovely environment and space, both indoor and outdoors. You are also welcome to pop up to the stage and have a look at the charter book with all of its historic signatures. If you flick through, you'll find David Attenborough's signature, you'll find the late Queen's signature, you'll find now King Charles's signature, and indeed around 590 fellows. So I wish you all a lovely afternoon, and we'll see you this evening at 6 o'clock. Thank you.
Professor Tom Calmer is the first fellow elected to the Australian Academy of Science who identifies as an Aboriginal person.
And it doesn't come without recognising the responsibility of such a role, and that is both working within the Academy but also within the general population to get other Aboriginal and Torres Strait Islander people recognised as fellows into the future.
Professor Calmer is used to breaking new ground. He became the first Aboriginal man to hold the position of Chancellor of any Australian university when appointed to the role at the University of Canberra. It's one of his passions. Despite significant growth, the gap between Indigenous and non-Indigenous student enrolment at Australian universities remains large. Professor Calmer says the problem starts much earlier in life.
If you don't have good experiences at the primary and secondary school level, your chances of going on to higher education are pretty much diminished.
He says colonisation meant that Indigenous children often weren't able to practice their own culture or language. That lack of natural comfort is often compounded by economic and health disadvantages. Professor Calmer has spent much of his career trying to improve those everyday realities. While serving as Australia's Aboriginal and Torres Strait Islander Social Justice Commissioner, he released a landmark report in 2005 that became the catalyst for the Close the Gap campaign.
We managed to get the government of the day to agree that at the opening of Parliament each year, they would provide a report about what they'd achieved in the previous year on addressing health equality, which was fantastic. That's a great level of accountability.
He's currently the National Coordinator for tackling smoking in Indigenous communities.
Governments, right up until the late 60s, paid Aboriginal and Torres Strait Islander people, if not all, but in a good proportion of their wages by way of rations, sugar, flour, salt, tea and tobacco. And so we developed a culture of smoking.
Poor policy is something he hopes introducing an Indigenous voice to Parliament will help overcome. Professor Calmer was co-chair of the Voice Co-Design Senior Advisory Group. He says while a voice to federal Parliament is important, so too is a second tier of voice, which will enable Aboriginal and Torres Strait Islander people within different regional areas to determine their own priorities.
Then they will sit down with the three tiers of government and identify the solutions, and they should do that in a co-design way, and that's when we'll see a real bite and we'll see change.
Bringing people together is a common theme for Professor Calmer. He says this also applies in science and believes researchers of all backgrounds should tap more into Indigenous knowledges.
You can't survive living in an arid environment like we have in Australia across tens of thousands of years without having an understanding of science.
Professor Calmer has praised the Academy's Reconciliation Action Plan for respecting the diverse cultures of Australia's First Peoples.
The more we can profile Aboriginal and Torres Strait Islander scientists out there, the more aspiration there'll be for our kids to say, I can, that's the role I can play.
Well, welcome back to Science at the Shine Dome here in Canberra. My name is Paul Richards. I'm the Director of Communications and Outreach at the Australian Academy of Science. And we're thrilled to officially welcome the Fellows elected to 2021. Our audience here at the Shine Dome is breaking for afternoon tea. I can hear the chatter of voices and conversation happening behind me, which is really so wonderful, seeing so many of our fellows and other interested people who have come to Science at the Shine Dome this week here in person. So grab your afternoon tea too, and we'll be hearing from some more special guests shortly. But I'd like to take this moment to thank all our sponsors that have made Science at the Shine Dome possible. Our platinum partners, CSIRO and Defence. Our major partners, the University of Queensland, who are also supporting diversity and inclusion initiatives like childminding at our events. The University of Sydney, who are also supporting tomorrow night's gala dinner. The Department of Education, who are our live stream partner for Science at the Shine Dome. The ANU and University of New South Wales. Our gold partners proudly include the Department of Industry, Science and Resources, Deakin University and the University of Melbourne. And we also thank QUT, Evans and Partners, the University of Adelaide Nature Portfolio and the University of Newcastle. And thanks to all the organisations who have made it possible for early and mid-career researchers to attend our events. One of our fellows we're going to meet next, Professor Stuart Bunn, is internationally recognised for his research on the structure and function of freshwater ecosystems. Take a look.
Professor Stuart Bunn spends a lot of time fishing on Australian rivers, all in the name of science.
The more fundamental work that I do is really focused on understanding where do things that live in these freshwater systems, where do they get their energy and nutrients.
One way of doing that is to study the chemical signatures that occur naturally in plants and animals. Professor Bunn analyses small tissue samples for traces of carbon, nitrogen and sulphur. These isotopic signatures are transferred from prey to predator, proving the old saying, you are what you eat.
And so by studying the chemical signatures in the animals, we can tell not only what they've eaten, but where they've done their feeding.
It was during one such project that he discovered that large crocodiles in northern Australia were preferring to feast on visitors to the river rather than aquatic prey.
Most large crocodiles in that part of the country are feeding predominantly on feral animals, feral pigs in particular. So that's a big aquatic predator that's not even feeding in the river.
Professor Bunn is internationally recognised for his research on the structure of freshwater ecosystems, which are home to incredible biodiversity, including around 40% of the world's fish species.
Freshwater systems are the most threatened ecosystem on the planet, largely from pressures that come from intensive land use, the use of water for industry and agriculture, the pollution from cities and farming as well.
And as Australians know only too well, our rivers and catchments have become far less resilient to extreme weather events.
What that means is that water that lands on the landscape flows into the river systems much more quickly, at a lot more velocity, because there's not the protective vegetation along the river banks.
Professor Bunn says recent natural disasters demonstrate the importance of learning from science. He's currently developing a set of tools that model various strategies for preparing our landscape for the inevitable consequences of climate change.
How do we maximise our investment, slowing water down, reducing erosion, reducing pollution, and of course reducing the damage that flooding causes?
He says he hopes becoming a Fellow of the Australian Academy of Science will allow his work to resonate more widely.
That's a really important role for science, is not simply just to sit back and publish your work and hope that someone will actually read it and make a decision based on it, but to actually get out there and work to influence policy along the way.
And I'm pleased to say Professor Stuart Bunn has taken some time out from his very busy day today to have a chat with us. Welcome, Professor Bunn. Thanks so much for taking the time.
Yeah, it's great.
Tell me a little bit about how you got into researching freshwater ecology.
It was one of my first ever jobs, actually. As a new graduate, I had the opportunity to work as a field biologist, and the person I was working for at the time said, this is in Western Australia, that, you know, if you wanted to make your name, come and study freshwater streams, because no one in Western Australia had done that at the time, and so that kicked off my career in freshwater science.
So why is it important to understand the health of our waterways?
Well, freshwater systems are just a tiny fraction of our planet, but they make up a huge part of our the planet's biodiversity. It's 40% of all the species of fish, a third of all the animals with backbone. So, you know, they're extraordinary biodiversity that they represent. And of course the freshwater systems also underpin our own human security, so managing these things, making sure that they're healthy, is a really key way of ensuring our own security as well.
So in some ways studying freshwater ecology is a bit of a pulse check for the health of our planet.
It is, and you can think of that, measuring the freshwater animals are living in our freshwater systems, monitoring the water all the time. And so if it's healthy for them, it's going to be, healthy for us as well.
How do you go about your research then? What do you look at in order to measure the health of our waterways?
Yeah, it's an interesting thing. There are a large number of ways in which we can do that. We tend to focus on a whole range of parameters because we, in the work that I've done, we believe that measurements of ecosystem health should be sort of all-encompassing, so they should be talking about the structure and the function. And so we measure not only the things that live in there, the smallest creatures, but also rates of key ecosystem processes, so how productive the system is, are the nutrients being cycled in the right way. So there's a range of different measures, and all of those really tell us that the system is functioning in a normal, if you like, a healthy way.
Yeah, one of the waterway systems that has obviously experienced a lot of trauma in recent years is the Murray-Darling system, the fish kills incident that's happened in recent years. Is it under threat of occurring again, is my understanding, and you know, what can be done to address these issues?
I mean, in the events, some of the fish kill events, and you know, the risks that we're seeing at the moment with flooding are because of these black water events, the large amounts of organic material that are coming down through these big flood events. But from I guess there are lots of things that we can do to improve the health of freshwater systems, and in fact, you know, when you look at how do we go about bending the curve of freshwater biodiversity loss, there are lots of interventions that we can do about managing environmental water better, reducing the effects of fragmentation from dams and impoundments, improving water quality, managing our catchments in a much more sustainable way. So there's lots of interventions we can do to really turn things around for freshwater systems.
Now, I imagine part of the joy of field research, if you ever get time to do it, is to actually be able to go fishing. Do you ever get to do that these days, to catch the specimens that you will then analyse?
Increasingly, it's become a bit of a recreational obsession rather than a professional one. But yeah, certainly catching fish has been a key part of the work that I've done, and that's certainly the fun part of it. For every fun day that you get to doing that, there's certainly lots of time in the lab and many more months sitting in your office doing other things as well. So that's been the really pleasurable part of the job.
Now, one other question I had for you was around the Northern Territory and the health of crocodiles. What can you tell us about the diets of crocodiles that you've been able to discover through your work?
Yeah, well, some of the early work that we did was trying to understand, using a range of techniques, what are the big apex predators in those systems, what are they feeding on? Most people would assume that they're a big aquatic animal and they're eating lots of fish and other aquatic things, but it turns out the larger crocodiles in those systems, quite a number of them, the large proportion of them, are feeding on terrestrial animals. So they're a big aquatic animal wading effectively in there and taking things from the land. And so most likely their diet is sustained at the moment by feral animals, feral pigs in particular.
Yeah, that's fascinating. I mean, so you get to really cover the full range from small, fish and other organisms through to the big apex predators, and all of those things help you to measure the health of
well, that's right, and it's really studying. I mean, to understand these systems is really understanding, what is the transfer of all those materials from the smallest scale, microscopic algae that really sustain and drive the food web, right up to these bigger predators. And not all of them are, as I say, doing the same thing. So.
Amazing. Well, Professor Stuart Bunn, thank you so much for spending some time with us this afternoon, and congratulations again on your
Thanks very much, Paul.
Thank you. The Parkes Telescope in New South Wales has been at the forefront of Australian astronomy for over 60 years, and it's still used very often today. In a moment, we're going to meet two fellows who are big fans of the dish.
The Parkes Radio Telescope is by far one of the greatest telescopes in the world.
There's a smell and there's sounds, and every part of it I love.
My first experience at Parkes was just crazy. The second you see the 64-meter big telescope, the wonderful weather, blue sky, I was really shocked. I saw this is the way to do astronomy.
It's 1,000 tons of steel that sit up on 4 big wheels and can point to almost any direction in the sky. I mean, as an engineering feat, it's amazing, but it's aesthetically marvelous.
It's 64 meters across. That's in the biggest of the big telescopes.
The bigger your telescope, the more energy you collect.
So it's very sensitive. And the people here at CSIRO are very good at building actually receivers, we call backends, the computers to process the data, which makes the telescope really powerful.
The most recent upgrade was just a couple of years ago with a very wideband receiver system that allows us to observe the radio waves over a much wider bandwidth than any other telescope on the Earth.
So we are in the southern hemisphere. When you look up the sky, you see the galactic center. So this is the best location if you want to study film objects in our Milky Way.
And then we have another advantage in Australia, which is that we don't have very many people. And radio telescopes are perpetually swamped by the radio signals of all the things that we have around us. Our computers, our mobile phones, our microwaves, radio stations, everything else that happens at radio frequencies. So if you can build your radio telescope where you don't have a lot of people, then that's a much better place for it to be.
The Australian Academy of Science, because questions need answers.
And I'm joined now by Professor Naomi McClure-Griffiths and Professor Matthew Bales. Welcome to the Shine Dome.
Thank you.
It's fantastic to see you both.
Yeah, good to be here.
Now, tell me, Naomi, to begin with, what's been your relationship with the dish?
Well, Parkes was my first love in radio astronomy and has remained my great love throughout my career. My very first astronomical observations were made at the Parkes telescope when I was just an undergraduate student, and I've observed there over many, 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 many weeks for my whole career.
Why is it so special as a facility for the work that you do?
Well, it's special in lots of different ways because it's beautiful, but for the work that I do, it's special because it's a big telescope. So radio signals are incredibly weak. You know, there's very little energy that comes from the universe in the form of radio signals, and you want a really big bucket to catch that in. And the Parkes bucket is a really big bucket. It's also a bucket that you can point in just about any direction. So you can see things that are on the far side of the galaxy, on the other side. You can look in a lot of different places, and that flexibility plus the size and the fact that it's been continually upgraded means that it's just a very powerful telescope.
Yeah, and I think a great example of investment, early investment in science and the way that can be continued over time. Matthew, you analysed the data received from places like the Parkes radio telescope, and in fact, you were part of the first detection of FRBs using data from the dish. Tell me, what was that moment like?
Yeah, it was supremely exciting actually, and very special because it was with one of my former students, and we were in the tower of the dish. And I just asked him nonchalantly, have you found anything interesting lately? And he said, well, I've got a signal I can't really understand, but he had quite poor diagnostics, and we had some tools and we kind of manipulated it. And then we just saw this beautiful swept signal that just went, oh my God, it's so bright and it's so far away, and I just couldn't sleep at night. It was a remarkable time, really. I
can only imagine. And was this something that was known theoretically that could be seen, or was it really just trying to understand what you were seing when it was discovered?
Look, I think we'd always had wild fantasies that maybe something in the universe would flash and we'd be able to see it. But we're actually looking at a galaxy that was very close, and this thing was behind the galaxy. And in fact, the data was on archival tape. We just happened to be in the dish at the time. Wow. And we sort of did the numbers, and it was 1 trillion times brighter than what we knew about. And it was like, well, that can't be real, but it seems so real. And it was a very joyous time. And I literally couldn't sleep that night. I was just thinking about how could this thing be 1 trillion times brighter than anything else we've ever discovered, and maybe we could use it in wonderful ways.
And I was going to say, and then what that would lead to after making that discovery. I mean, it just opens a whole new door, doesn't it, in terms of areas of research?
Yeah, and it actually took us 6 years to get the next one. So that was a tremendously uncertain period in my career. I was like, oh, is this just some mindless fantasy, or is it really real? And then we saw the second one, and a few days later we got the third, fourth, fifth, and it was like, oh, thank God.
That's really... Now, Naomi, speaking of seeing things perhaps in plain sight, you were responsible for making a rather remarkable discovery of one of the arms of the Milky Way. This might sound like a bit of a silly question, but how can something so big remain undiscovered for so long?
It's not a silly question. It's a perfectly reasonable question, and it's a question I asked myself for about 12 months while trying to figure out what it was that I had found. It was like, that can't be real. Somebody would have found it. But the key was that we found this atomic hydrogen signature over a large area of the sky, about 70 degrees across the sky. And we couldn't have detected it in the past, not because we didn't have the data, but because we couldn't visualize the data. So, in the past you would have looked at a contour map of atomic hydrogen emission. It would look like a contour map when you go out bushwalking or something. And trying to tell a little tiny hill on that contour map is a little bit tricky. And that's the kind of thing that we were looking at, was contour maps that showed a little bump, tricky to find. But in modern days, we can look at computers where we look at movies, we can see how this moves dynamically, and that allowed it to jump out.
It's one of the exciting things, isn't it, when it also, as technology evolves, for the sort of work that you're doing, but this is true of across many areas of science, that as technology evolves, it's so exciting to see what you can now see and discover. The James Webb Telescope, I wanted to ask you both for a bit of a reaction from people who really can appreciate what the beautiful pictures that we're now seeing and being able to enjoy as members of the general public. So Matthew, what has this meant, having this sort of technology brought to bear in the research that you can do?
I think it's been amplified by the fact that we've been waiting for so long for James Webb to actually turn on. And I used to be on advisory committees for the James Webb, and it was like, oh, it's so long away. And we knew in theory it had this amazing resolution and sensitivity, but to see the images, it just makes your jaw drop. And I just like a starry-eyed kid when I look at them. I don't actually know that much about the science behind it, but I can appreciate beauty when I see it.
Well, yes, as can we all. How about for you, Diana?
Yeah, well, I think the beauty fact shouldn't be overlooked, really. I mean, science is about inspiring, and it's about trying to get people engaged in the science. And a telescope like JWST is a fantastic vehicle for that inspiration, to see images pop and to demonstrate how sort of three-dimensional they look when we look at dust clouds in a star-forming region. That's what gets kids excited, and that's what gets us excited as well, but it gets everybody behind this as a base level of science where you want to jump into it and go, what's happening there?
I think it makes it a lot easier to sell what we're doing to the general public too, because you can just show them these amazing images and go, wow, that's amazing, rather than some of these other more technical things about baryon content of the universe is like a little bit of a harder sell.
Yeah, but it helps bring that to life, and you can connect one to the other then, can't you, through those sorts of images. And Matthew, your big passion is gravitational waves, and there are moves to set up a gravitational wave detector in Australia, a bit like LIGO. What can you tell me about that?
Yeah, so we have about 150 people in my Centre of Excellence, and we just got renewed funding for another 7 years. So we're looking forward to not just doing catch-up science, but being at the forefront of gravitational waves. And there's some very exciting multi-billion-dollar international projects. We'd like Australia to be part of that. And so I guess we'll be leaning on the government to not just fund the researchers, but also some of these new tools which will sense gravitational waves from the entire universe in a very unbiased and clear way.
And we're in a pretty unique position in Australia, aren't we? Why is Australia such a good place for the sort of research that you do?
Yeah, if you are trying to study gravitational waves, you need to triangulate where the source is coming from. So if you have a detector in America and a detector in Europe, you'd love to have one as far away from those two places and on the other side of the world as you can get. And so in my grand vision, Australia is part of an international collaboration which has detectors in the three continents that I just mentioned, and doing some fantastic science, not just for the next 7 years, but the next 100.
Brilliant. And Naomi, the SKA construction is about to be announced. How important is it that a facility like that is a facility like that to the future of radio astronomy?
It's everything. The SKA is a €1 billion facility. It's the chance to operate on the world stage and do major science infrastructure. It's the chance to be able to see the very first stars in the universe and when those turned on and reionize the universe. And then everything from the very beginning to us here and looking at how planets form in our own galaxy. And that's a huge, you're talking about 13 billion years of space that you're trying to to study, and the SK is the way to do it. It gives you, when I talked about the big bucket before, well, this is the ultimate big bucket.
That sounds pretty exciting. Well, Naomi McClure-Griffiths and Matthew Bales, thank you so much for taking some time to have a chat with me.
Thanks
and
very much.
Congratulations.
Thank you.
Our pleasure.
Well, we'll be back with some more guests in just a moment, but first we're going to take a look at something completely different, a bit closer to our planet, and that is the lives of seahorses, a bit more deadly than you might think.
Seahorses are one of the ocean's most unlikely predators. Although they're small and delicate, they have a vicious hunting technique. They won't hurt most animals, but if you're a small crustacean, watch out. Super speedy, tiny crustaceans are the seahorse's main prey.
Because of the body shapes, seahorses are very poor swimmers and they don't move very fast. And because of this, they have to wait for the prey to come close, and then with the fast movement of the head, they catch the prey and eat it.
Experts at camouflage, seahorses will change colour to blend into their surroundings. With their unique horse-like head shape, their movements create minimal disturbance in the water. And when they attack, they rarely miss.
Seahorses have a fantastic attack rate with around 90% success rate, and that makes them one of the most effective predators in the sea.
Seahorses use their tube-shaped noses to suck up small animals because they have no teeth and no stomach. The technique of sucking up prey is called pivot feeding, and it requires very strong muscles in the snout to create a vacuum.
The Australian Academy of Science, because questions need answers.
Well, how about that? Well, we're coming to you from the Shine Dome here in Canberra, and we're about to meet a couple of our new fellows who are both from the University of Sydney, but they have some other things in common as well. Also, I have to take the moment to thank University of Sydney for sponsoring Science at the Shine Dome and their support to make this event possible. Professor Hala Zreikwat, welcome.
Thank you.
And Professor Marcella Bilek, welcome.
Thank you.
Hala, tell me what brought you to Australia in the first place?
My love to research, although I've never done it before, but I just wanted to do research. It's innate passion for doing research and discoveries, I think.
And I understand there was a bit of a sliding doors moment for you, where perhaps science wasn't the path that you were going to choose. Tell me about that.
It wasn't. I always wanted to do interior design, but then for me to do that at the time in the Middle East, or in Jordan in particular, meant that I had to go to England, and my father had to sell a land and send me to England, which he already spent so much money on me, so I didn't want to do that. So I thought, okay, science is also creative, it's beautiful, so I will do science, and that's what brought me to, first I did science in Jordan, and then I came to Australia to pursue a career in medical research.
I love the way that you express that, the creativity in science, which all scientists know, but I think is often misunderstood. Would you agree?
I totally agree with you, but science is all about creativity if we let them be, if we let the scientists be and do what they do best, which is creativity and development.
Marcella, how about you? How did you end up coming to Australia?
So my parents were political refugees. They left the Czech Republic. I was born in Prague, and 10 months later there was the Prague Spring. Russian tanks rolled in, and my father was actually posted overseas already. He was in Bangkok, so he just told my mother to take me and get out of the Czech Republic, at the time Czechoslovakia.
And how did that impact, you know, your future choice of career? Was that so early on that you know, it possibly, you know, laid a bit of a path for the career that you chose?
I think it gave me more opportunities than I would have had, because my father's political leanings would have meant that I wouldn't have had the sort of educational opportunities I had here. And really, I pursued science because I loved maths and physics, and I just loved the logic of, you know, of those subjects and how they contributed to the way we could understand the world around us.
Yeah, and you must be watching what's happening in Eastern Europe at the moment, and what's that like for you, having really fled as a result of something similar many years ago?
Yeah, it's very disturbing actually, because yeah, I kind of relate to it, even though I got out before I even understood what was happening. It's just, yeah, knowing people that were there and suffered through that Russian occupation and so on. It's, yeah, horrific.
So, Hala, tell me a bit more about then your journey through science. You are someone who is incredibly passionate about diversity in science, having more women in STEM. What drives that passion for you?
I think it's the experience I encountered when I came to Australia and when I wanted to do research. The first job I landed was at the Faculty of Medicine at UNSW with a professor who was a pathologist, a late Professor Rolf Hallett, and there I could see that he was relying on the physicists. In fact, Marcella and I collaborated back then, right? Yes. Where the physicists were trying to modify the surfaces of the implants for the biologists. I'm a biologist, by the way. I'm a medical scientist, not an engineer. And we were trying to look at what is it that these surface modifications do to the tissue around them. And right there and then I realized that if we really want to advance in the field, we have to have people from different disciplines around us. And we're talking back in 2006 when I was lucky enough to get my first National Health and Medical Research grant and my first ARCDP grant. Then, of course, University of Sydney recruited me and I went from medicine to engineering, and there that was my opportunity to launch my research career, building a multidisciplinary group. So I had people in chemical engineering, material scientists, even medical doctors, in order for us to develop what we want to develop to be used in a human body.
And so that experience, though, really also made you see through difficulty, perhaps, you know, things have to change.
Absolutely. I mean, I come from Jordan. I've been talking to people here, undeveloped country. Coming to Australia, you think everything has to be glorious. Everything has to be just laid down for you, far cry from it. So my job here is to really inspire the next generation. And to that, I have established a few networks. One of them is called Biotech Future Challenges, which team up high school students with university academics, PhD students, undergraduate students. The whole network is driven by the undergraduate students at the university from different faculties to inspire the next generation to work on innovation, technology, STEM, if you like to call it as well.
Marcella, what makes science such a difficult career for women to remain in? What's been your experience?
I think that, well, I guess we're on top of a lot of the things that make it difficult to remain, but I think there are a few things that stop women even entering that we need to address. But in terms of remaining, there's the unconscious bias or the subconscious bias, which we now understand is with us all, even women, when we're reviewing people's CVs and so on, so they don't tend to get ahead as quickly. It is also a confidence issue, and that's potentially due to the fact that we belong to a stereotype group that's not supposed to be good at science. So you tend to present yourself less confidently than a male counterpart. And I see that all the time in my PhD students and early career researchers. And the women, in fact, are as excellent as the men, if not more so sometimes, and yet they still lack that confidence, which does make a difference. Whether we like it or not. So, and then there's the other crucial one that I think pretty much all women buy into and recognise is the role that women are meant to play in raising a family. And that was interesting. My daughter just did a story on women in STEM as part of her Year 10 assignment, and she interviewed a bunch of my colleagues, and that was the one topic that resonated. That was the difficulty, having children and trying to balance that, being the primary carer. So I'd really like to see the men step up, and they are doing so. I want to see a world where it's expected that the parents are sharing equally. Just like the penguins, the dad sits on the eggs as well.
That's a great way to put it. And yeah, I can see that there is a long way to go in that, but seeing more of a shared role taking place for men, we would just need all men everywhere to step up, don't we? Tell me a bit more about this stereotype threat, and how have you been able to overcome it, and what advice do you give?
So I don't think I was even aware of it when I overcame it, but I think the way I did overcome it, maybe I should even explain what it is. So it's basically when you recognise that you identify as part of a stereotype group that's meant to be less able at the particular task that's being tested, like for example a maths test for women. You have a bit of a fear that you're going to reinforce that stereotype, and that tends to interfere, the theory is it interferes with working memory, and it actually makes you less able to perform well at that task. right, because of the way that's affecting your brain and your confidence levels. And I think that I overcame this simply because wonderful teachers in high school who really encouraged me. You know, they were telling me all the time that, oh, you're really good at this, and you know, you're going to do so well in your exams, and that message is what I needed to hear, and I needed to hear it a lot to overcome that bias that was already in my head. And I think that's what we need to be telling girls in schools, and it unfortunately seems to be kicking in around 6 years of age. There was a study in Nature not so long ago that showed that. They looked at 5, 6 and 7-year-olds, and they saw this change in attitude and confidence towards science and smart activities in girls that young. So we really need to start building confidence of girls in these fields.
I really see that. I have 2 daughters, and one in particular is battling with those sorts of emotions at the moment, and it's really helpful to hear the way that, you know, those positive messages and that reinforcement, and that you can do it, and is really important. You can't just take that for granted.
Yeah, you've got to believe you can do it, I think, before you can do it.
Yeah, absolutely.
Yeah.
Well, Hala and Marcella, thank you so much for taking time out to have a chat with me. Congratulations on your fellowship.
Thank you.
And enjoy the rest of the day.
Thank you.
Thank you.
Well, nearly 80,000 people have contracted COVID-19 in the 7 days before last Thursday, and it's subvariants of the Omicron strain that are wreaking havoc. Take a look.
Viruses are microorganisms that require hosts, like humans, to survive. As a virus enters our body, it binds to our cells. Our cells react by reading the genetic code of the virus and creating viral copies. But sometimes a piece of the genetic code gets lost or changed during the copying process. This creates a mutation in the virus. Many of these mutations will do almost nothing, but some can help or hinder the virus's ability to survive. If a new version benefits the virus, it can become the dominant variant by out-competing the old one. That's why we get a new flu vaccine each year, which is updated to fight the new variant. The virus causing COVID-19 is also evolving, but because it is larger than the flu virus, each mutation causes less change. This is why our current COVID vaccines still protect us against serious infections. These small changes happen continuously to create new subvariants, but sometimes an abrupt shift can happen when mutations build up or 2 subvariants merge. When this happens, the structure of the virus changes, creating a new variant. Globally, in the COVID-19 pandemic, Delta and Omicron remain the 2 major variants of concern. But each variant also has subvariants or sublineages. Delta, for example, is an umbrella term for more than 200 sublineages. They're all closely related genetically and derived from a common ancestor. Many current COVID infections in Australia are caused by an Omicron sublineage known as BA.2. New variants and sublineages will keep emerging as people continue to become infected. That's why scientists are pushing for higher vaccination rates and for strategies such as physical distancing and mask wearing to help slow global transmission.
The Australian Academy of Science, because questions need answers.
And Professor Brendan Crabb from the Burnett Institute joins me now. Welcome, Brendan. Thank you for taking time to have a chat to me. There's a lot of talk about the rise in cases of COVID-19 happening at the moment. How concerned should we be?
Well, it's great to be here, but not so much during the 4th wave for the year. So it is our 4th wave. It's an incredibly unusual thing to happen. I can't think of another infectious disease where you'd have more than one wave in a year. So, for us to have this Omicron strain come sort of almost exactly a year ago, and for us to have gone through 10 to 15 million people of Australia's 26 million who have been infected, and now to be facing another significant wave, it's really quite something for the country to deal with. And my own personal view is that we are underappreciating its significance at the moment, but I totally get why, basically.
We've been through a lot the last few years, and that's the reason,
exactly.
big reason, isn't it? We desperately want to move on, but it's not necessarily going away.
We do, and as an example of that, we've got more people in hospital today, and the new wave has only just started, so we're at the trough, we're at the low point. We've got more people in hospital today than we had for influenza for the whole year for COVID. So there's over 1,800 people in hospital. So it's just a different scale than we're used to. We've got the blessing of science having delivered us vaccines and therapies and diagnostics that are allowing us to keep things at bay for the individual. So you or I get infected, we feel pretty confident about ourselves not getting terribly sick. We're pretty worried about long COVID, it's another issue. But it's because of the scale of it, it's still going to kill sort of 25 to 30,000 Australians this year who would otherwise have not died. I mean, this takes it into the league of sort of cancer and heart disease as a cause of death. So it's a big issue. Please try and not get COVID. That's my message.
Yeah, well, I've noticed actually that you have been wearing a mask a lot around the Shine Dome, but really good practice there that you're demonstrating for the rest of us. And do you expect to see mask mandates return? Do you think that's a good idea, necessary? I mean, really, is the message take all precautions?
I don't think we will see mandates, and I'm not terribly concerned about that. My plea is for a change in the message. I don't think the message that I just delivered, that COVID is a really significant danger to the community, that it's not a normal problem, it's an exceptional problem. I don't think people understand that. I think our politicians are shy of that message at the moment, for reasons I understand, as I said before. But what it does mean is it allows complacency to creep in, and we think, oh well, we're at a low point now, we'll worry about when things get higher. But there's still probably 200,000 people with COVID at the moment in Australia, and that's going to go up 4 or 5 times in the next few weeks most likely. I think it's the change of mindset. And then the message needs to be, well, if there's some simple things, get your booster. Australia flatlined in our booster rate probably 4 or 5 months ago. We're now a very moderately vaccinated country. We think of ourselves as highly vaccinated. We're very middle of the road. We haven't cottoned on that we've moved on so much from hand washing and so on to wearing a high quality mask in a high risk situation. It's an airborne disease. Science has taken us there. It's an airborne disease, but we haven't shifted the way we do things. So you want to wear a mask if you're in a room that you don't trust. Preferably you want to be in a room you do trust, because it's got ventilation and filtration systems and so on. And so there's get vaccinated, think about this airborne, and there's get tested. Now testing is also dropping off a lot. And testing is incredibly powerful, because if you get COVID and you know it early, there's a fantastic drug you can take. But you can only take it if you know early, in the first 5 days or so. So please get tested. Plus, of course, if you know you're positive, you can protect other people. So, look, it's an attitude shift. It's not a rule that needs to change.
But you commented on Twitter the other day that the real story with Omicron is that there are peaks but no troughs. Why does that matter?
Well, it matters effectively because I think we become transfixed on, I've even done it, I've said there's been 4 waves this year, but it means you transfixed on just this peak period, and then as soon as it starts to go off you say, oh, we're in good territory, but actually we haven't been in good territory for the whole year. Sort of the least number of deaths we've had each day from COVID has been about 20. That's a very big number of deaths, and the lowest number of hospitalisations has been about 1,400. And the total number of flu hospitalisations for the year is 1,700. So it matters because there's just been a constant burden. We need to get away from thinking so much about the peak. Peak does matter because it can overwhelm our hospital system. We do not want it to overwhelm our hospital system because it affects so much other healthcare if that happens. But the troughs are way too high, and we can't go on like this. And I think we've been hoping that actually infection on top of vaccination is our way out, because it'll give us extra immunity. That's not proving to be quite right. And so I think we're going to need that mind shift change, apply the science really well, Don't make too many rule changes unless you absolutely have to, but some really good messaging. Imagine Prime Minister getting up and saying, I need you all to do this, please do that, come with us on this journey, and some ads on TV about how to do it. I think it would make a huge difference.
Yeah. Now, Brendan, you spent part of your childhood in PNG. How did that shape your career?
Oh, look, it's a good question. I probably didn't know it shaped my career much at the time. One bit I do know, my family is not in science, but my father had a friend who was a scientist, and I was so impressed with what this person did. So that was a big influence for me. Not impressed by the things you think of. He didn't wear a tie. I thought that was pretty impressive. All the businessmen that my parents knew wore ties. I didn't want to wear a tie. And he didn't seem to be into money, but he was very excited about his job. That's a very strong memory I had, and as a result, really, I did a science degree. So in that sense, it wasn't the country of PNG, but it was my parents' friends that influenced me. But in later life, and the things I've chosen to work on, and how I work on them, it's influenced me a lot, because I see the science as a solution to the problems people have, but it's not enough. They've got to access that science. There are other barriers to people getting, because of cost or because of knowledge or whatever the barrier might be. We've seen it with COVID. In Papua New Guinea, the country that I grew up in, they've got a lot of vaccine, but only 3% of the country are vaccinated.
Brendan, we have to wrap up, but I do just want to briefly ask you about malaria and your research there. Why is it such a tricky disease to find treatments for, effective treatments for?
Yeah, look, it's because it's in a way like HIV. It's incredibly variable. It's a very complex pathogen. So you've got this dual whammy with malaria. It's genetically very complicated, like a leopard that's changing its spots, and it's also a disease of poverty. So even with the solutions, it doesn't fix it. You have to fix the access issue as much as the scientific challenge.
I wish you all the best in that research, and congratulations on your fellowship.
Thanks so much.
We'll take you now to the Shine Dome.
A very good afternoon to you all, and welcome to the Australian Academy of Science and to this beautiful and iconic Shine Dome. It's such a pleasure to welcome you here this afternoon at Science at the Shine Dome 2022. For those of you who I've not met, my name is Anna Maria Arabia. I'm the Chief Executive here at the Australian Academy of Science. We have had such an inspirational morning. We've been able to admit some fellows who were elected in 2019 and who were unable to attend their admission ceremony. Who would have thought they would have needed to wait till 2022? We've admitted our 2020 fellows and our 2021 fellows, and I'm absolutely delighted to welcome our 2022 fellows here today for your admission. I'd like to begin by acknowledging the traditional owners of the land on which we meet, the Ngunnawal and Ngambri people. It's upon their ancestral land that the Australian Academy of Science was built. And as we share our own knowledge, teaching, learning and research practices, may we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. Before I hand over to our President, may I ask that you place your phones and devices on silent, but please don't turn them off. We'd love for you to share your experience on social media using the hashtag ShineDome 2020. ShineDome 22. I'd also like to particularly welcome our guests joining us online. We have a live stream of everything that's happening in this theatre over the course of Science at the Shine Dome that we are sharing with the world. And I know that there is great interest in the work of the Academy and the work of our fellows. And there's also exclusive content available for our online audience through interviews that have been conducted over the breaks today. You will have seen the marquee set up outside. It looks like a bit of a studio out there. To our online audience, thank you for joining us. We strongly encourage attendees to practice good hand hygiene. We've made a sanitizer available throughout the venue and also face masks should you wish to wear one. Similarly, for everybody's comfort and out of an abundance of caution, we'll be foregoing handshakes today throughout this admission ceremony. One final note before we welcome Professor Jagadish to the microphone. Official portraits of all of our new fellows will be taken in breaks today and tomorrow. So I invite you to make your way to the Becker Room at some stage, today or tomorrow, to capture this occasion. Now, without further ado, please join me in welcoming Australian Academy of Science President, Professor Jagadish. Thank you.
Thank you, Anna Maria. I would like to pay my respects to the traditional owners of the lands we meet, Ngunnawal and Ngambri people, and I pay my respects to their elders past, present and emerging. Colleagues, it's an honor to welcome you to the Australian Academy of Science this afternoon. In my first year as Academy President, I could have not asked for a better start to my tenure than our return to the Shrine Dome after an extraordinary 2 years, and to be celebrating excellence with you over the next 3 days at Science at the Shrine Dome. Australian scientists are among the best and brightest minds in the world. At our core, we ask questions and seek answers to understand our world better, and we look for ways to secure the future of our nation and our neighbors all over the world. Taking up this challenge isn't easy. The questions are hard, and then the answers sometimes harder. So it is important to recognize outstanding achievements and inspire our upcoming generations to continue to question, innovate, and create. The admission of our new fellows is a time-honored tradition established by the founding fellows of the Australian Academy of Science and the founding fellows of the Royal Society of London before that. Upon admission to the Academy and by signing the Academy's charter book, you subscribe to the following obligation. I hereby solemnly promise to promote, declare, and disseminate scientific knowledge and to serve the Academy according to its charter and bylaws. The charter book was a gift from the Royal Society, has been signed by every fellow of the Academy. Your signature today will sit alongside those of some of the world's most esteemed scientists, and you are welcome to look through what is a significant piece of Australian history at the conclusion of the ceremony to see how deep the traditions and knowledge of this learned academy run. To officiate the formal admission, please let me introduce our Vice President, Secretary for Physical Sciences, Professor Malcolm Sambridge, and Secretary for Biological Sciences, Professor Helene Marsh. Malcolm and Helene will announce the names of each fellow and read your citation, and I invite each new fellow to come up to the stage at the conclusion of their citation reading to sign the charter book and receive their certificate. A photo will be taken on stage before we enjoy a brief video summary of your achievements. Fellows will be called in alphabetical order to come forward and join me at the charter book. The first fellow we'll call upon is from the physical sciences. So now I'll invite and hand over this to Malcolm.
Thank you, Jagadish. So good afternoon. My name is Malcolm Sambridge, and I'm Vice President and Secretary for the Physical Sciences of the Australian Academy of Science. So our first fellow for 2022 is Professor Matthew Bayles. Matthew Bayles is an astrophysicist who has specialised in the study of pulsars, transient radio bursts, and gravitation. He has made major contributions to these areas and played a pivotal role in development of a new branch of astrophysics, fast radio bursts, guiding projects that led to Australia's dominance in the field. Matthew.
Congratulations, Matthew. welcome you as a Fellow of the Australian Academy of Science.
Professor Matthew Bales says it's simple to sum up what he does.
Look, I just have fun exploring the universe. Explore what I think is the most exciting science we can do, because I've always had a fascination for how the universe works.
A fascination inspired by another scientist who loved the universe.
How many advanced civilizations capable, at least of radio astronomy, are there in the Milky Way galaxy?
When I was about 19 years of age, I think it was, the TV show Cosmos by Carl Sagan was on TV, and I found it absolutely riveting and quite a life-transforming TV show for me. It showed there was a mathematical foundation to the universe.
And that mathematical foundation is something he's dedicated his life to understanding. Professor Bales founded the Swinburne University Centre for Astrophysics and Supercomputing, where, just like Carl Sagan did with him, he's able to inspire the next generation of scientists.
We actually made Australia's first 3D IMAX film about space, but we also create educational 3D virtual reality content that we use for school tours here at Swinburne in the virtual reality theatre, but also in headsets as part of something called Mission Gravity.
But the supercomputer here at Swinburne is also capable of some serious research. Professor Bales has been at the forefront of discovering high-energy cosmic explosions known as fast radio bursts.
I was very lucky to be present when the first one was discovered. One of the reasons we were so confident that the first fast radio burst was real is that we had the tools to visualise the data.
Since then, many have been spotted, particularly by the Parkes Radio Telescope in New South Wales. But while we know they're real, scientists still aren't certain what they are.
We've certainly got theories. It's almost certainly some sort of highly magnetised and energetic neutron star from sort of halfway across the universe, but we don't know.
But exploring the unknown is the point of science. It's also why he took on the role as director of the ARC Centre of Excellence for Gravitational Wave Discovery, which is dedicated to understanding the extreme physics of black holes and warped space-time. His impact in the field of astrophysics has seen Professor Bales elected a Fellow of the Australian Academy of Science.
Good afternoon. My name is Helene Marsh and I'm a Vice President and Secretary Biological Sciences of the Australian Academy of Science. And our first new Fellow from the Biological Sciences is Professor Kathy Belov. Kathy Belov is acknowledged for her groundbreaking work using genetics and genomics to trace the evolution of mammalian immunity to overturn the paradigm that marsupials and monotremes have primitive immune systems. After determining the role that the major histocompatibility complex plays in the spread of Tasmanian devil facial tumour disease, Kathy led the genetic management of the recovery program to successfully increase the immune fitness of wild populations through genetic rescue. She continues to work with government agencies to boost the immunogenetic resilience of native species threatened by disease.
Congratulations, Kathy. I welcome you as a Fellow of the Australian Academy of Science.
This facial tumour is a telltale sign of a contagious cancer that has come close to wiping out the Tasmanian devil.
It's spread by animals when they bite each other.
And basically cells pass from one animal to another and then start growing until the animal's not able to feed anymore because of the tumour masses. It arose in one devil, a female devil, and it's passed through tens of thousands of animals since then, killing them as it went.
Geneticist Professor Kathy Belov was determined to understand why the devil's immune system wasn't protecting them.
It wasn't a virus or a bacteria. It was a cell that spread from animal to animal. That shouldn't have been able to happen, because if you were to take some of my cells and put them into you, your immune system should reject them and know that they're foreign.
She traced the problem to a lack of genetic diversity in devil populations. The cells that were being passed from animal to animal were so similar, the immune system didn't see a need to reject them.
It became more complex than that, of course, because the tumour also found a way to hide from the immune system. But the low levels of genetic diversity in devils allowed this horrible cancer to spread.
A network of wildlife sanctuaries across mainland Australia, including here at Sydney's Taronga Zoo, has been actively building an insurance population of devils.
And my team have been managing the genetics of that program for many years. And we've been deliberately breeding devils to improve genetic diversity in the population.
Professor Belov is renowned for overturning the misconception that marsupials have primitive immune systems. She's done that by studying the genomes of many Australian animals, including the koala.
Mapping and sequencing the koala genome was a big deal because it was the first time we'd used all of those technologies here in Australia and used Australian researchers to characterise such a complex mammalian genome.
The project identified the genes that make some koalas more susceptible to chlamydia than others. It even revealed how koalas are able to detoxify eucalyptus leaves, allowing them to eat something that could kill us. Professor Belov is a key driver of the Threatened Species Initiative, which is creating a national library of genomic data to help make more informed decisions about wildlife conservation.
We're very lucky in Australia. We've got the most unique animals, and we have this unique opportunity to study animals that have been evolving independently from any other animals for, 50 million years.
Professor Belov says it's a great honour to join some of her mentors as a Fellow of the Australian Academy of Science. She sees it as further inspiration to support emerging researchers.
I worked out this morning that about 70 people have gone through my lab over the last 20 years, and most of them are young women. And I'm really proud of that, and I look forward to welcoming many of them into the Academy in years to come.
Professor Marcela Bielek. Marcela Bielek is internationally known for her work on plasma processes for surface engineering of materials and advanced biointerfaces. Her work has enabled new capabilities in a range of settings, including magnetic storage devices, solid fuel plasma thrusters, implantable biomedical devices, in vitro cell culture systems, diagnostics, stem cell, gene therapy, and nanomedicine.
Congratulations, Marcela. I welcome you as a Fellow of the Australian Academy of Science.
Professor Marcela Bielek was born in what was then known as Czechoslovakia in 1968. It was a time of sweeping political reform and liberalisation. But the so-called Prague Spring came to an abrupt end when Soviet tanks rolled in.
I was born in January, so I was a little baby at the time, and my father happened to be posted in Bangkok. When he heard what had happened, he just told my mum to grab me, leave everything behind, get on a plane. We applied for political asylum in Australia and came here.
She excelled at school, earning the right to apply for any university course she wanted.
I knew I liked science and I knew I liked learning.
She showed great promise as a software engineer, suspending her studies to take up an internship at the technology company IBM in Tokyo.
Walkman had just come out at that time. I had one of those and I did a Japanese lesson a day and then practiced on all my colleagues, and it was fantastic.
But although she loved the culture, she longed to be back in a science lab. And so, upon arriving back in Australia, Professor Bilek chose to focus on physics. She's now world-renowned for her contributions to the science and technology of plasma processes. Plasma is the so-called fourth state of matter, after solid, liquid, and gas.
An example actually of a plasma you can see on Earth is the aurora. If you go to Sweden or somewhere far north, you can see those glowing lights. That is a plasma in our atmosphere.
Her team uses these stainless steel vessels and electricity to create plasma from low-pressure gases with finely tuned chemistry.
And we can manipulate them using magnetic fields and electric fields.
Their work has many applications, including creating bio-instructive surface coatings that improve the way implants interact with a human body. For an implant to work, it must bond with the surrounding tissue and elicit optimal responses from nearby cells. And that's where hydrogel comes in. The jelly-like substance is similar to the matrix that holds cells together in tissue. But hydrogel is notoriously difficult to work with in devices that need to maintain a stable structure. So Professor Bilek's group created a plasma technology that can attach signaling biomolecules and hydrogel to polymers without using any chemical initiators. This innovative coating encourages the body to accept the implant. Professor Bilek says the endless possibilities keep her motivated.
If I get bored, I zone out. It definitely is a curiosity and a willingness to keep learning.
A curiosity she intends to share with others as a Fellow of the Australian Academy of Science.
Professor Stuart Bunn. Stuart Bunn is an internationally recognised for his research on the structure and function of freshwater ecosystems. His work challenges established wisdom about aquatic food webs, establishing a new understanding that emphasises the key role that high-quality algae as a basal resource and the connectivity of energy and nutrient flows across rivers, floodplains and estuaries, along with terrestrial inputs. Stuart Bunn has played a key role in building Australia's national research capacity in freshwater ecology, forging international connections and visibility, and translating his deep knowledge of ecosystem function to guide the management of flow regimes of freshwater systems in Australia and internationally.
Congratulations, Stuart. I welcome you as a Fellow of the Australian Academy of Science.
Professor Stuart Bunn spends a lot of time fishing on Australian rivers, all in the name of science.
The more fundamental work that I do is really focused on understanding where do things that live in these freshwater systems, where do they get their energy and nutrients.
One way of doing that is to study the chemical signatures that occur naturally in plants and animals. Animals become labelled with the same signatures as their food.
And so by studying the chemical signatures in the animals, we can tell not only what they've eaten, but where they've done their feeding.
It was during one such project that he discovered that large crocodiles in northern Australia were preferring to feast on visitors to the river rather than aquatic prey.
Most large crocodiles in that part of the country are feeding predominantly on feral animals, feral pigs in particular. So that's a big aquatic predator that's not even feeding in the river.
Professor Bunn is internationally recognised for his research on the structure of freshwater ecosystems, which are home to incredible biodiversity, including around 40% of the world's fish species.
Freshwater systems are the most threatened ecosystem on the planet, largely from pressures that come from intensive land use, the use of water for industry and agriculture, the pollution from cities and farming as well.
And as Australians know only too well, our rivers and catchments have become far less resilient to extreme weather events.
What that means is that water that lands on the landscape flows into the river systems much more quickly, at a lot more velocity, because there's not the protective vegetation along the river banks.
Professor Bunn says recent natural disasters demonstrate the importance of learning from science. He's currently developing a set of tools that model various strategies for preparing our landscape for the inevitable consequences of climate change.
How do we maximise our investment, slowing water down, reducing erosion, reducing pollution, and of course reducing the damage that flooding causes?
He says he hopes becoming a Fellow of the Australian Academy of Science will allow his work to resonate more widely.
That's a really important role for science, is not simply just to sit back and publish your work and hope that someone will actually read it and make a decision based on it, but to actually get out there and work to influence policy along the way.
Professor Thomas Kalmer. Tom Kalmer is an Aboriginal elder from the Kungarakan tribal group and a member of the Iwaja tribal group. He has long been a champion for the improvement and advancement of Indigenous people's health, justice, education and employment status, and also a fierce advocate for progress and change. His work continues to have an enduring impact on public discourse in Australia and beyond.
Congratulations, Tom. I welcome you as a Fellow of the Australian Academy of Science.
Professor Tom Kalmer is the first Fellow elected to the Australian Academy of Science who identifies as an Aboriginal person.
And it doesn't come without recognising the responsibility of such a role, and that is both working within the Academy but also within the general population to get other Aboriginal and Torres Strait Islander people recognised as fellows into the future.
Professor Kalmer is used to breaking new ground. He became the first Aboriginal man to hold the position of Chancellor of any Australian university when appointed to the role at the University of Canberra. Education is one of his passions. Despite significant growth, the gap between Indigenous and non-Indigenous student enrolments at Australian universities remains large. Professor Kalmer says the problem starts much earlier in life.
If you don't have good experiences at the primary and secondary school level, your chances of going on to higher education are pretty much diminished.
He says colonisation meant that Indigenous children often weren't able to practice their own culture or language. That lack of natural comfort is often compounded by economic and health disadvantages. Professor Calma has spent much of his career trying to improve those everyday realities. While serving as Australia's Aboriginal and Torres Strait Islander Social Justice Commissioner, he released a landmark report in 2005 that became the catalyst for the Close the Gap campaign.
We managed to get the government of the day to agree that at the opening of Parliament each year, they would provide a report about what they'd achieved in the previous year on addressing health equality, which was fantastic. That's a great level of accountability.
He's currently the National Coordinator for tackling smoking in Indigenous communities.
Governments, right up until the late 60s, paid Aboriginal and Torres Strait Islander people, if not all, but in a good proportion of their wages by way of rations: sugar, flour, salt, tea, and tobacco. And so we developed a culture of smoking.
Poor policy is something he hopes introducing an Indigenous voice to Parliament will help overcome. Professor Calma was co-chair of the Voice Co-Design Senior Advisory Group. He says while a voice to federal Parliament is important, so too is a second tier of voice, which will enable Aboriginal and Torres Strait Islander people within different regional areas to determine their own priorities.
Then they will sit down with the 3 tiers of government and identify the solutions. And they should do that in a co-designed way. And that's when we'll see a real bite and we'll see change.
Bringing people together is a common theme for Professor Calma. He says this also applies in science and believes researchers of all backgrounds should tap more into Indigenous knowledges.
You can't survive living in an arid environment like we have in Australia across tens of thousands of years without having an understanding of science.
Professor Calma has praised the Academy's Reconciliation Action Plan for respecting the diverse cultures of Australia's First Peoples.
The more we can profile Aboriginal and Torres Strait Islander scientists out there, the more aspiration there'll be for our kids to say, I can, that's the role I can play.
Professor Jonathan Karapetis. Jonathan Karapetis is a global leader in rheumatic heart disease and Group A streptococcal disease. He was the first to quantify the disease burden in Australia and globally to prove that skin infection is key in parthenogenesis and to demonstrate that environmental rather than genetic or organism factors drive the disease burden. Karapetis has reshaped the control of rheumatic heart disease globally, particularly among Australia's Indigenous peoples, and changed the way medical research is done.
Congratulations, Jonathan. I welcome you as a Fellow of the Australian Academy of Science.
When Professor Jonathan Karapetis began researching rheumatic heart disease more than 3 decades ago, it was a fairly unknown condition to most Australians. Although cases occurred in remote Australia and low-income countries, no one knew just how many people were affected.
For the first time, we documented the true burden in Australia and then the true burden globally. We challenged some of the paradigms around what caused this disease, particularly rheumatic fever. Classically, it was thought to be caused only by a throat infection with the strep A bug, And we really have documented that it's not just the throat infections, it's also skin infections. By documenting that, it has led to significant changes to how we try and control the disease.
Professor Karapetis is now a leader in an international consortium to develop the first ever vaccine against strep A. But he says his work is far from complete. Rheumatic heart disease is the most commonly acquired heart disease for people under 25. And while it's now very rare in most high-income countries, it continues to be rife in many of Australia's remote First Nations communities.
They're exposed to so much infection, including the strep A bug that causes rheumatic fever, and that's related to overcrowded housing. It's related to inadequate access to the sort of infrastructure like basic washing facilities and hygiene facilities that the rest of us have. Rheumatic heart disease is the emblematic condition of the gap that we're trying to close.
Professor Karapetis says that closing that gap starts with bringing Indigenous voices to the forefront of research. He says partnering with First Nations communities to steer the direction of research can lead to far more meaningful outcomes.
All of our projects now in rheumatic fever and strep infections that involve Aboriginal communities have Aboriginal investigators. They have an Aboriginal governance committee that has right of veto over all aspects of the project.
Professor Karapetis says he's always been driven by a passion to make a difference.
I became a doctor loving the idea that I could deal with a child and a family and hopefully have an impact on them. I then became a researcher knowing that if I did that well, then what I did would have an impact on many, many families. And then I became a research leader to amplify that even more.
For his impactful research and scientific leadership, Professor Karapetis has now been elected a Fellow of the Australian Academy of Science.
Dr. Beth Fulton. Beth Fulton is a global pioneer of whole ecosystem modelling, from microbes through food webs to human decision making. Her groundbreaking modelling approaches are recognised by FAO as world's best practice and have influenced the sustainable management of marine systems on 5 continents and advanced evidence-based decision-making and ocean literacy.
Congratulations, Beth. I welcome you as a Fellow of the Australian Academy of Science.
Dr. Beth Fulton uses maths to see the future of our oceans.
I do what's called ecosystem modelling, where you create versions of the world inside a computer so you can play it forward and understand all the different ways that we use the ocean.
Dr. Fulton takes a whole-of-system approach. It's unlike other conventional ocean models which tend to focus on just one thing, such as fish or shipping.
You piece all that together like a mathematical jigsaw puzzle so that you go from the climate through the oceans up through the entire food web and then on to the people and how we use it so that you get that big picture view of what's going on.
She led the development of CSIRO's Atlantis, rated by the United Nations as the best model in the world for looking at ecosystems and large-scale fisheries management options. It's now being used to evaluate more than 40 ecosystems across the planet.
It can be looking at what's the contribution of climate change to the change in the number of fish versus the effects of fishing. You can look at where, say, having noise from a vessel can affect the behaviour of whales and make it more or less likely that they'll interact with the boat. You can look at how having seabed mining or energy generation in one area affects fishing and where those fishing boats go, which then might affect them getting different forms of species. It's that juggling that jigsaw puzzle of if I do something over on one side of the area, what happens to other things in that area?
Dr. Fulton grew up on a farm, but as a child, her family visited the coast during summer holidays.
And I fell in love with the place, being able to crawl across the rocks and see crabs and the life that was so vibrant there, being able to hang underwater and see the fish go past. But I'm an asthmatic, so I can't dive. I had to find another role of easily interacting with the oceans, and that's where my love of maths came along. So maths became my way of exploring the oceans and going to places either to the deep ocean or into the future of the ocean that I can't physically go, and it became my way of giving back to the ocean.
But the oceans she loves so much are under mounting pressure from factors such as climate change. As a scientist based in Tasmania, Dr. Fulton is seeing the impact firsthand.
So we're seeing species change. About 100 new species live in Tasmania that never lived here before. We're seeing ocean currents move by hundreds of kilometres. Things that used to stop off Victoria now come down to Tasmania. So we have a glimpse into the future that the rest of the world is yet to see.
Dr. Fulton says being elected a Fellow of the Australian Academy of Science is a great honour, and one she hopes will lead to greater collaboration.
I see it as a learning experience. It's always great to be in a place, whether it's within the CSIRO where I work or within the Academy, where you know for sure there's someone smarter than you there and someone who can teach you new things.
Professor Catherine Greenhill. Catherine Greenhill is internationally recognised as a leading expert in asymptotic, probabilistic and algorithmic combinatorics, undertaking research at the interface between combinatorics, probability and theoretical computer science. Her highly cited research provides new formulae and algorithms that can have found broad applications in many areas, including cryptography and physics.
Congratulations, Catherine. Welcome you as a Fellow of the Australian Academy of Science.
Professor Catherine Greenhill makes no secret of her love for mathematics.
There's a stereotype of the mathematician not being very emotional, but I think for a lot of us we really care about our mathematics. It's very personal as well. It's a bit more like how a poet feels about their poetry or a musician feels about their music, I think.
Professor Greenhill tackles fundamental questions in an area of mathematics known as combinatorics. In particular, she studies the theory of graphs.
Graphs and hypergraphs have heaps of applications, like the vertices of a graph could be cities and the edges between them could be direct train links.
But those sorts of properties are often too predictable for Professor Greenhill. So instead, her research focuses on random graphs, which can be used to help understand the typical structure of a complex network.
And that can help people who have a network that they've found in their own research, say in physics or something, and they've noticed some properties of that network. They want to know whether those interesting properties are because of the function of the network or whether they would just be there by chance.
Her work has been highly cited, with applications in areas such as computer science and coding theory. She says she does it mainly because it's fun and describes the moment of solving a problem as a natural high.
One nice thing is when colleagues say, oh, I was impressed that you solved that problem, or when it hasn't been solved for a long time and you managed to solve it.
But solving a complex problem can sometimes take years. She says any good mathematician needs perseverance and curiosity, two traits she tries to instill in her students at UNSW Sydney.
What I want to get the students to do is to play with the concepts independently, and sometimes they're really worried about saying something that might be wrong. I hope that even the students who would never answer a question externally are sort of thinking about the question in their minds.
Professor Greenhill describes becoming a Fellow of the Australian Academy of Science as a great honour, and one she hopes will inspire other women to pursue a career in maths.
It's not just about getting women and other underrepresented groups into the field, it's about making sure the field is a welcoming and safe and supportive and encouraging environment. And that's a challenge for everybody. It's making sure that people feel that they have the chance to shine and do their best.
Professor Michelle Haber. Michelle Haber is a world-renowned authority in the field of childhood cancer research and a key leader of the Australian biomedical research community. She's made fundamental discoveries in the area of drug resistance in neuroblastoma and has pioneered molecular diagnostics and precision medicine for Australian children with leukemia and other high-risk cancers.
Congratulations, Mr. I welcome you as a Fellow of the Australian Academy of Science.
Professor Michelle Haber is not just Executive Director of the Children's Cancer Institute, but also one of its longest-serving employees. She was appointed the Institute's inaugural postdoctoral scientist in 1984.
That means that I am coming up to 40 years very soon since I have been working here, and it's changed dramatically.
The biggest change has been survival rates for children diagnosed with cancer. Just a few decades ago, childhood cancer was considered something almost impossible to beat. Today, more than 80% of young patients do. But on average, 3 Australian children still die from cancer every week. And even for those who do survive, it often comes at a cost.
Because the treatments that are given are exceptionally harsh on a young growing child's body.
Standard chemotherapy involves drugs that are designed to stop rapidly dividing cancer cells from growing.
That's fine if the only thing in the body that's rapidly growing is the tumour. It's not fine if you've got a child whose entire organ system and body, all the cells are growing and rapidly dividing. So these kids are more often than not left with serious, lifelong and potentially fatal side effects.
Professor Haber has dedicated her career to improving those outcomes. In the 1980s, she and 2 colleagues developed a new molecular approach for the most common form of childhood cancer, acute lymphoblastic leukemia. Their techniques more than doubled survival rates for children with the high-risk form of the disease.
That said to me, oh my God, if we could really understand the genetics of children's cancer, if we had a picture of what's going on in every tumour, we can begin to tailor treatments.
That became possible with the mapping of the human genome. Professor Haber has been the driving force behind the Zero Childhood Cancer Program. Zero sequences the unique genome and transcriptome of each child's cancer and compares it to their normal genome. That then allows doctors and scientists to formulate a personalized medicine recommendation for each child.
These drugs that match just specific genetic aberrations, they're not targeting all the normal cells in the child's body because those normal cells don't have that genetic problem. It's only the tumour cells.
70% of the first 250 children with high-risk cancer who received their personalised treatment recommendation as part of a national clinical trial entered either a complete or partial remission or had their disease stabilised while avoiding the side effects of chemotherapy. The program will now be made available to all Australian children with cancer.
It is a revolution in the model of care for these kids.
In addition to improving treatments, Zero is collecting massive amounts of data, which will then be shared globally and entered into a new National Child Cancer Predisposition Registry.
Then begins to lead to the opportunity not only for treatment of children's cancer, but prevention. And of course, that's the Holy Grail.
And something not even discussed when Professor Haber started researching kids' cancer. She describes becoming a Fellow of the Australian Academy of Science as the pinnacle of recognition.
Makes me feel very special, and it's a recognition for everything that we've managed to do together over the years. I'm over the moon.
Professor Timothy Hughes. Timothy Hughes has made key contributions towards the development and refinement of kinase inhibitor therapy for cancer through his pioneering work on chronic myeloid leukemia, also known as CML. He was a leader on many of the clinical trials that underpinned the transformation of CML from a fatal disease to a treatable chronic disease. He pioneered the concept of treatment-free remission as a pathway to cure in CML. This has heralded an exciting new era in cancer therapy where molecularly defined targets are identified and specifically inhibited.
Congratulations, Timothy. I welcome you as a Fellow of the Australian Academy of Science.
Chronic myeloid leukemia is a blood cancer thought to arise from a genetic mutation.
When I first started treating and studying chronic myeloid leukemia in the 1990s, our experience was that the vast majority of patients would survive for 3 or 4 years, but then the disease would progress into an acute leukemia and the patients would in most cases die, so that by 5 years, only about 20% of patients were still alive.
Thanks to the work of Professor Tim Hughes and his colleagues, a lot has changed since then.
When we see a patient today with chronic myeloid leukemia, we can tell them that we have highly effective treatment and that their outcome, if they can take that treatment on a regular basis, is extremely good. So that today, over 80% of patients are alive and well, living with their leukemia after 10 years of therapy.
Professor Hughes helped create an accurate way to measure the amount of leukemia in a patient's system.
One of the critical ways to treat this disease most effectively is to know exactly what your current treatment is achieving in terms of, is it reducing the amount of leukemia in the bone marrow and the blood? Is it keeping it stable, or is it actually increasing?
Clinical trials he led in Adelaide developed a sensitive PCR technique that could answer those very questions. It became a potent tool for optimising therapy. So much so, around 30% of patients now enter treatment-free remission.
And we really pioneered this idea that we can go beyond just controlling this disease to the point where we can actually bring patients off therapy. We piloted a study in 2006 which demonstrated that some patients who achieve an excellent response can actually safely stop their therapy and the disease will not come back. And that's now become a globally applied therapy in chronic myeloid leukemia.
Professor Hughes leads the Precision Cancer Medicine Unit at the South Australian Health and Medical Research Institute and is a Fellow of the Australian Academy of Science.
One of the things I've really enjoyed over the last couple of decades has been to build a team of really excellent clinician scientists and scientists that are all working together, all having their own skills that can, in a combined way, make real impact in this disease.
Professor Lei Zheng. Learning from nature, Lei Zheng established the basic principles of superwettability for interfacial materials systems. More than 10 superwetting interfacial material systems have been applied to various fields, including energy, health, resources, the environment, material, and chemical industry. In 2021, superwettability technology was selected by the International Union of Pure and Applied Chemistry as one of the top 10 emerging technologies in chemistry, recognising its potential to foster the well-being of society and the sustainability of the planet.
Congratulations, Lee. I welcome you as a corresponding member of the Australian Academy of Science.
Watch what happens as rain falls on lotus leaves. The drops of water simply roll off the surface with almost no resistance, allowing the lotus leaf to clean itself. It's one of many examples in nature of a phenomenon known as superwettability.
鱼为什么可以在水下保持清洁？咱们的船不行。还有蜘蛛丝、仙人掌怎么能在空气中积水？我们头发不行。 等等这些东西呢，都是这个超浸润仿生超浸润界面科学属研究的范畴。那么实际上呢，它是源于自然的一种科学研究方向。
Jiang Lei is a professor of chemistry at the Chinese Academy of Sciences. He's globally renowned for establishing the basic principles of superwettability on interfacial materials. The wettability of a material's surface is determined by a series of factors, including its chemical composition and texture. In the case of fish, Professor Jiang revealed that microstructures in their scales can trap water. That then creates a cushion effect, which repels oils and pollutants, keeping fish clean while underwater. He says expanding our knowledge on how superwettability works in nature has paved the way for innovation in industry.
超浸润呢，会使得材料有更优越的性能。纹理面料，你有在身上有这个 coating 成是超疏水的，而是超双疏，就水油和水都不沾，那你就不那个领带啊，什么西服啊就不脏了吗？还有建筑材料，自清洁玻璃，一冲就干净了。
Professor Jiang is finding many applications for the research. He currently holds more than 40 patents, with more than 50 others pending. He says he's always been inspired by the natural world and is committed to understanding it.
自然界中寻找它的奇妙的性质，然后呢，你去研究它这个原理，然后呢，在这个研究的原理之后呢，你就做到这个发明新的材料、新的技术，这是一个非常有意思的过程。
A journey that has taken him around the world and seen him receive many honours, including the UNESCO Medal for Nanoscience. He collaborates regularly with scientists in Australia and says he's deeply honoured to have been invited to join the Fellowship of the Australian Academy of Science as a corresponding member.
你一个人不可能报打天下，合作呢是非常重要的，因为实际上呢，科学不应该有国界，因为你会互相启发。
Emeritus Professor Peter Langridge. Peter Langridge is an eminent leader in the development and implementation of serial breeding technologies. He initiated the application of molecular marker technology in large cereal and legume breeding programs adopted by all major cereal breeding programs in Australia. Langridge also pioneered the introduction of plant functional genomics in Australia into crop improvement programs and was a member of a core group that initiated the International Barley Genome Sequencing Program.
Congratulations, Peter. I welcome you as a fellow of the Australian Academy of Science.
By 2050, we'll need to produce 60% more food to feed the world. But crop yields are already showing signs of slowing down.
For wheat, it's estimated that every degree rise in temperature will lead to about a 7% decline in global yields. So we've got big problems. The only way we're going to address these problems is by looking at technology, looking at the science.
Professor Peter Langridge is an agricultural scientist. He works primarily on cereals like wheat and barley, which account for more than 60% of the global population's diet. He's renowned for his research on DNA-based technologies that help to improve crop performance and ultimately yields. The technology tracks gene variants that are associated with traits such as drought tolerance and disease resistance. Breeders can then select the variants that produce new crop varieties with those superior qualities. Professor Langridge was among the first scientists to introduce this innovation to cereal breeding programs in South Australia. It's since been adopted by major breeding programs across the world.
For wheat, in the past, it took about 12 years from the time a breeder would make the first cross to the release of a new variety. With some of these technologies, we could reduce that time to 7 or 8 years. And that obviously has a big impact upon the rates at which you can achieve major advances.
Professor Langridge says that thanks to such advances over the last century, we've been able to reduce rates of world hunger despite surges in our population size. But the threats to our future food security remain large.
Declining water availability, issues around fertiliser costs and access, the impact of climate change. On the other side, there's some really good science that's out there that's being done by different groups around the world that can really tackle some of these problems.
Professor Langridge's more recent work has been about bringing those groups together. He's the International Science Coordinator at the Wheat Initiative, which unites more than 600 researchers across 47 countries to tackle food security issues. In one project, his colleagues in Italy developed a massive germplasm collection, like a library of genes for crop improvement, for durum wheat, which is used in foods like pasta. They made this publicly available, allowing scientists everywhere to access the material, as long as they then share the results of their research.
And our knowledge and information about those varieties has expanded spectacularly.
That ability to solve problems and make an impact is why Professor Langridge loves his job. As a Fellow of the Australian Academy of Science, he hopes to amplify what's possible through scientific collaboration.
Dr. Janice Loff. Janice Loff is recognised as a world leader in developing high-resolution environmental and growth histories from corals, assessing the nature and consequences of climate change for coral reefs and for people who depend upon them. She has made seminal contributions to high-resolution reconstructions of paleoclimates, the understanding the consequences of climate change for tropical coral reefs, as well as interpretation of coral calcification histories.
Congratulations, Janice.
Thank you very much.
I welcome you as a fellow of the Australian Academy of Science.
Dr. Janice Loff describes herself as an environmental historian.
I enjoyed looking and have worked over the years on historical climate records, and most specifically the records contained in massive coral skeletons.
Many coral species have growth rings, similar to those found in trees. The rings allow paleoclimate scientists, such as Dr. Loff, to reconstruct the past well beyond what we know from modern observations.
And all those records point to just how unusual the current climate changes are in terms of the past several hundred years. The system really is starting to change, and that's evident in these natural archives.
If you take a slice from a long coral core and put it under ultraviolet light, you'll see these bright luminescent lines. In this example, the lines relate to the flow of fresh water into the Great Barrier Reef.
We're in Townsville at the moment, and to the south of us, there's a great river called the Burdekin River. At some times of the year, in winter, you can walk across the riverbed. In other years, extreme wet years, there are tremendous amounts of fresh water that actually go out onto the reef. These luminescent records in the corals allow us to reconstruct the river flows, going back into the 1600s.
And that reveals that flood years are happening more frequently and becoming far more extreme.
Now, this corroborates with the theory about climate change. A warmer atmosphere can hold more moisture. As we've seen over the past few years, you're likely to get bigger flood events now than you did, say, 50 or 100 years ago. These corals provide corroborating evidence that that is in fact actually happening.
Coral reefs can only survive in a very narrow temperature range.
If it gets too extreme, the temperatures can lead to something called coral bleaching.
Something that now happens regularly along the Great Barrier Reef.
Reefs of the future are probably not going to disappear entirely, but they're going to look much simpler and provide less habitat, food sources for the many other reef-associated organisms.
Dr. Loff has spent much of her career at the Australian Institute of Marine Science, but her work has helped climate modelling around the world, including in the Pacific Islands.
We ended up explaining our results specifically to the fisheries managers from the Pacific Islands, so they got direct feedback about information that was relevant to their sector.
Her lifetime of work assessing the nature and consequences of climate change has seen Dr. Loff elected a Fellow of the Australian Academy of Science.
Professor Naomi McClure-Griffiths. Naomi McClure-Griffiths is Australia's preeminent expert on the atomic hydrogen gas distribution and evolution of our galaxy, the Milky Way, and its neighbours, the Magellanic Clouds. Her work includes the discovery of a new spiral arm within the Milky Way, the first detection of neutral gas outflowing from the nucleus of the Milky Way, and the pioneering demonstration of the importance of magnetic fields in the flow of matter into the galactic disk.
Congratulations, Naomi. welcome you as a Fellow of the Australian Academy of Science.
Professor Naomi McClure-Griffiths says her favourite class in school was always maths.
I was the sort of kid who sat in the car and would make the windows fog up and then do mathematics equations on the car window, and I just always loved doing maths. Physics is described by mathematical equations, and it's essential to have that in order to sort of build a picture of the universe or to build a picture of how nature's laws work.
Building a picture of the universe is now her full-time job.
I say I explore the Milky Way, our own galaxy, and the nearby galaxies, the Magellanic Clouds. So I think of myself as an explorer.
Professor McClure-Griffiths is a radio astronomer.
Which seemed like a brilliant idea when I was a young student because I didn't like to stay up all night. And I thought, radio astronomy, you can do it during the day. But it turns out you can do radio astronomy 24 hours a day, and therefore you get no sleep whatsoever.
She uses data from radio telescopes like the famous dish in Parkes, New South Wales.
We do a lot of fancy computer processing in order to, in the end, produce images.
It was through using these computers that Professor McClure-Griffiths made a remarkable discovery, a new arm of the Milky Way.
But I thought, surely, if it were, somebody would have found it before. So then you spend a lot of time going through the literature and trying to understand what people know. Couldn't find anything at all.
It took a year, but her findings were finally confirmed as a distant spiral arm in the fourth quadrant of our galaxy.
And nobody had found it before because we couldn't visualize data as well as we can now.
Improved visual data has given radio astronomers, including Professor McClure-Griffiths, the chance to answer bigger questions. She's now working to better understand the role of magnetic fields in the formation of galaxies.
We know that we have a magnetic field here on Earth. We know we have magnetic fields in the Sun. Most galaxies that we've been able to measure magnetic fields in, we do detect them. And we can see that they relate to the structure of the galaxy. But we don't really know where they started in the universe and how they've evolved as the universe has aged.
Professor McClure-Griffiths says she's honoured to join the Fellowship of the Australian Academy of Science, describing it as a place where curiosity is celebrated.
I think it's the definition of humanity to look up and wonder why, how, what is it? And that's what I get paid to do, is to look up and wonder.
Professor Sarah Medland. Sarah Medland is a psychiatric and statistical geneticist working on neuroimaging genetics and mental health. She was instrumental in the formation of the Enigma Brain Imaging Consortium. Her work has significantly advanced our understanding of the ways that genetics influences the structure and function of the human brain and the risk of developing psychiatric and neurological disorders.
Congratulations, Sarah. I welcome you as a Fellow of the Australian Academy of Science.
What role do genetic variants play in psychiatric and neurological disorders? That question is at the heart of Professor Sarah Medland's work.
What we're really trying to do is to understand the way that the human brain develops and the way that mental health conditions develop.
Professor Medland is a psychiatric and statistical geneticist. She works with colleagues around the world to analyse large samples of data from thousands of people with lived experiences of different mental health conditions, such as bipolar disorder or schizophrenia.
Through their participation and their generosity of time, that's enabled us to be able to actually do powerful research.
For example, her research has found that genetic variations can explain around 80% of the factors influencing whether or not someone will develop ADHD, and 40% of the factors influencing someone's risk of developing depression.
But the environmental components play a really strong role, and the genetic and environmental factors work together to influence risk or resilience to depression.
Professor Medland was instrumental in the formation of the Enigma Consortium, which unites more than 2,000 scientists across 45 countries to better understand brain structure, function, and disease. Their shared protocols mean it's now easier to analyse massive amounts of brain imaging and genomic data.
In the brain imaging field, particularly around genetic effects, a lot of groups were expecting to find that genetic variants would have extremely large effects.
But research from the Enigma Consortium revealed otherwise. Rather than finding a few variants with a large influence, the data showed that many genetic variants have a small influence.
Individually, they're very small, but cumulatively, they have significant and large impact.
Finding such small variants was only possible thanks to the use of very large data sample sets, such as those from Enigma.
What this has really done is shift the field forward and made it focus on the idea that analyses do need to have enough power and they do need to be robust and replicatable.
Identifying specific variants and understanding how they influence our brains may make it possible to predict those most at risk of developing certain disorders. That could then pave the way for earlier interventions. Professor Medland's group are also investigating which genetic variants influence side effects from medication, ensuring people get the most suitable treatments.
One of the fundamental questions in the type of work we do is really gaining a better understanding of our bodies and ourselves and the way in which biology is working.
Professor Medland says she's honoured to join other passionate fellows of the Australian Academy of Science in advancing human knowledge.
Professor Ute Rosner. Ute Rosner is a world leader in the development and application of metabolomics and lipidomics in plant science and biotechnology. Her pioneering work established frontier technologies that have uncovered mechanisms that describe how plants respond to a variety of abiotic stresses. Her work has led to the development of more stress-resistant crops and enhanced plant performance through improved nutrients and water.
Congratulations, Ute. Please.
Professor Ute Rosner grew up in East Germany. She was 17 when the Berlin Wall came down.
I will remember it like it was yesterday on our first trip to West Berlin. We just crossed the border and there was a lot of business. West Berlin selling bananas and all the things we East Germans didn't have. So we took the first bus which came by and it took us to the rich area of West Berlin. And I remember people sitting on the floor begging for money. That did not exist in East Germany.
She studied nursing in a hospital as part of her dream to become a doctor. But a few weeks in, she knew medicine wasn't right for her.
It's a tough job. I took every patient home with me. I was worried when I left the hospital what happened for the other 16 hours until you're back for the next shift. And I thought I just couldn't be a doctor.
She still completed her 3-year nursing course before shifting focus to biochemistry at the newly founded University of Potsdam. Not long after, the Max Planck Institute for Molecular Plant Physiology moved to the campus. She knocked on the door asking to be an intern and was soon conducting analytical measurements of single metabolites, small molecules, such as glucose and fructose. Each metabolite had to be measured individually, which was slow and laborious work. But then the Institute purchased what Professor Rusner describes as a new toy, a gas chromatograph coupled to a mass spectrometer which had the potential to measure all those metabolites in one go. She was invited to do her PhD on developing the best ways of using the instruments to study plants.
The most significant contribution, and it was a team effort at the Max Planck, was to develop those technologies in the biological sciences and get the community to understand the value of those new technologies.
It was pioneering work which helped establish the field of metabolomics, the large-scale study of small molecules. Thanks to her original research, metabolomics is now used across multiple disciplines, including plant science, biomedicine, food chemistry, and microbiology.
So across the globe, many institutions then bought the same instrumentation and adopted our methods very quickly.
In 2003, Professor Rusner emigrated to Australia to create a metabolomics platform for the Australian Centre for Plant Functional Genomics at the University of Melbourne.
Being invited to set up a metabolomics facility in Australia was a huge opportunity because I knew I was the first one here to do it. I could purchase the right instrumentation. I could build a team who for Australia set up this platform.
A platform used by plant scientists across the country. After 18 years in Melbourne, during which she ran her own research program, Professor Rusner recently made the move to the Australian National University in Canberra. Her research uses metabolomics to increase a plant's climate tolerance and fertilizer intake, not only improving agricultural yield, but reducing the environmental impact. Her latest project is aimed at better understanding how plants interact with soil microbes.
My biggest question no one yet could answer is how a plant recruits those bacteria or microbes which are beneficial as opposed to those which are pathogenic, which they repel.
Professor Rusner says she's proud and humbled to become a Fellow of the Australian Academy of Science and hopes it inspires others to study what she calls the wonderful world of metabolomics.
Professor Craig Symonds. Craig Symonds is internationally recognised as revolutionising understanding of groundwater. He drove development of new mathematical models that address the limitations of classical fluid mechanics in groundwater geoscience and made the first direct observation of gravitational instabilities in a natural groundwater setting. Symonds has established a new modelling paradigm to inform environmental management and policy issues as diverse as food and water security, coal seam gas, fracking, nuclear waste disposal, mining and energy.
Congratulations, Craig. I welcome you as a Fellow of the Australian Academy of Science.
One of our greatest resources is often hidden from view.
It turns out that 97% of the fresh liquid water stored on the planet at any given time is stored underground beneath our very feet.
And that's something that Professor Craig Simmons says we should never take for granted.
Groundwater is a huge resource for humans, for food production, for industry, for mining, for drinking and water security.
Professor Simmons is globally recognised as revolutionising our understanding of groundwater processes.
We use computer models that are based on physics, that are based on mathematics to make predictions about how much water is stored, but vitally which direction that water is moving in and also how fast that water is moving.
Crucial information when you consider that in Australia alone, around 30% of our water usage comes from groundwater.
Groundwater supports a conservatively estimated $34 billion worth of economic activity per year across agriculture, mining, industry and water supplies in rural and remote regions.
The mathematical models that Professor Simmons developed offer improved accuracy and deeper insights than the traditional methods of classical fluid mechanics. That's meant we're better equipped to source and preserve fresh water supplies. But he says the pressures on groundwater have never been greater.
One thing I think we can say for sure is that with climate change and also population growth, that those two things when combined will almost certainly mean an increased pressure and reliance on groundwater systems. So the importance of groundwater is set to only increase into the future.
Professor Simmons established the ARC National Centre for Groundwater Research and Training, ensuring more scientists are now tackling those future challenges.
There are students from the Groundwater Centre that are working not only through almost every part of Australia, but in so many countries around the world.
He describes becoming a Fellow of the Australian Academy of Science as surreal and is humbled by what it means.
Probably most importantly, I think that it's an opportunity to really help advance science in Australia, but also internationally.
Professor Kate Stewart-Miles. Kate Stewart-Miles is renowned for spearheading a new paradigm in reliable algorithm testing, including innovative techniques for generating unbiased test instances and the visualisation of insights into algorithm reliability. Her instance space analysis methodologies is a much-needed solution to the long-standing problem of algorithmic trust and is transforming academic research practice across many fields and supporting industry partners keen to avoid disasters when developing critical algorithms.
Congratulations, Kate. I welcome you as a Fellow of the Australian Academy of Science.
Algorithms are at the heart of everyday life. From online search engines to traffic control systems, there seems to be no end to their use.
We're becoming increasingly dependent on them as a society. It's really important for us to be able to figure out how we can trust them.
Professor Kate Smith-Miles is an applied mathematician.
The way we learn to trust an algorithm is typically by giving it test examples where we know the answer. If the algorithm gets the right answer enough times, we start to build confidence that we can trust the algorithm.
But how many times is enough? That's a critical question, especially if you're relying on algorithms for things such as facial recognition or self-driving cars.
Just because an algorithm is good on average doesn't mean it's good all the time and that you should use it.
Professor Smith-Miles has been determined to find a better way to test algorithms. Her answer is instance space analysis.
And what instance space analysis is trying to do is use mathematical techniques to be able to visualise on a 2D map the space of all possible test instances for a problem with a mathematical boundary that defines where we need to test within.
By using mathematical testing, researchers can better identify any shortcomings with the algorithm or bias in datasets. It's an idea 15 years in the making.
I was an editor of a journal, and every week I'd receive submissions from researchers around the world wanting their paper published. They developed an algorithm, and the narrative was along the lines of, here's my new algorithm, and I tested it on these 10 problems, 20 problems, so please publish my paper. I started to ask questions like, well, how do I know that those 10 or 20 examples that they chose to share with me weren't just cherry-picked to make the algorithm look good?
Her techniques are now used by researchers across a range of fields, including machine learning and medical diagnostics. And her team has partnered with industry on things such as making sure autopilots can better respond to all sorts of conditions faced by planes.
Mathematics is a powerful language to be able to model how the world is, to be able to think about the goals and the targets of what we want something to be, and then to use mathematics to make decisions about how we can actually change.
The impact of her research has seen Professor Smith-Miles elected a Fellow of the Australian Academy of Science.
Professor Huizheng Zhao. Huizheng Zhao has made significant contributions to the development of electrocatalysis, photoelectrocatalysis, and thermocatalysis principles, and nanostructured catalysis. He has successfully transformed a suite of his principles into commercial sensing applications, including for environmental remediation, which has led to paradigm shifts in the monitoring and assessment of aquatic organic pollutants.
Congratulations, Vision. Welcome you as a Fellow of the Australian Academy of Science.
Professor Huizheng Zhao says it's not hard to find motivation for his work.
We know that energy and environmental sustainability is the pressing issue for human beings into this century and probably long into the future.
Professor Zhao is director of the Centre for Catalysis and Clean Energy at Griffith University.
I think we now have a political will to develop a sustainable future energy and environment, but we still need enabling scientific and technological solutions to really resolve this issue.
And that's where his team comes in. They're researching catalyst principles and developing new catalysts that can be used to produce chemicals and hydrogen fuels. Right now, precious materials such as platinum are the most commonly used.
But for sustainable future, for large-scale application of hydrogen energies, it just cannot continue to use platinum because we have limited resource.
So instead, Professor Zhao is experimenting with more affordable, non-precious alternatives, such as transition metals.
They can perform as good as platinum for hydrogen production.
Professor Zhao's research is highly cited and used around the world for a variety of applications beyond clean energy generation. For example, his team developed a patent and sensing technology, now used commercially in more than 50 countries, to assess the quality of drinking water, wastewater, and broader aquatic environments.
It basically provides a real-time continuous monitoring capacities for organic pollutant.
The method replaces a process that took about 4 hours and generated toxic matters. Those types of practical advances have come to define Professor Zhao's work since he moved to Australia from China in 1998 to complete his PhD. He says becoming a Fellow of the Australian Academy of Science is a recognition of not just his own journey, but all those he's collaborated with.
And the other things that really gives you a better platform and for you to do a better science into the future.
Professor Albert Zamaya. Albert Zamaya is a well-renowned computer scientist who has made significant contributions to the field of parallel and distributed systems. His work is influential, of high impact, and of great practical value. Albert is also an excellent leader, passionate educator, skilled communicator, and committed mentor.
Congratulations, Albert. I welcome you as a fellow of the Australian Academy of Science. Thank you.
The Chinese city of Wuhan was where COVID-19 was first detected. As patient numbers grew, staff at the region's biggest hospital turned to computer scientists for help. Among them was Professor Albert Zamaya from the University of Sydney.
And the idea was, can you do the number crunching that will allow us to predict when a patient is going to go into the ICU?
That information would help the hospital effectively allocate resources. Professor Zamaya's team set up what is known as an edge computer network. Like cloud computing, it uses more than one device to process data, but it has one big difference.
You're moving the capability of the cloud closer to where data is being ingested or generated, so closer to the user.
That allows for faster, near real-time insights at the data source. Combined with machine learning, the network delivered on its mission.
We were able to come up with more than 90% type of prediction that a certain patient will go into ICU.
Soon, the brief was expanded. Could they also create a predictive model for sepsis, one of the major causes of death among people with COVID-19? Their edge network used data from patient medical records to successfully predict who might develop the condition, leading to improved treatments.
That, again, was made possible because we're able to deploy edge devices closer in the hospital.
Edge computing isn't just faster than cloud computing, it's also more private because the data isn't sent off to a distant data centre. It's a rapidly developing frontier that Professor Zamaya is playing an active role in as Director of the University of Sydney's Centre for Distributed and High Performance Computing. The team here is designing the algorithms and protocols needed to ensure edge computer networks are stable, secure and energy efficient.
How do you really measure the performance of a given edge or a given distributed system environment doing a certain task?
That question will become more urgent as edge computer networks increasingly form part of our critical infrastructure across areas such as health, finance and military. By 2025, it's estimated that 75% of the world's data will be processed outside of traditional data centres. This isn't the first time Professor Zamaya has been at the forefront of computer innovation. In a career spanning nearly 3 decades, he has authored more than 700 scientific papers. He says being elected a Fellow of the Australian Academy of Science will allow computer scientists to have a louder voice.
As a field, we're much younger than these other sciences. As I see more representation of computing or computer scientists, I think it's a very positive thing. And I'm sure we're going to see more of that in the coming years.
What a day. What an inspirational day. I've learned a lot today, and I'm sure that all your videos will be inspiring the next generation of young scientists as well. Those are here, those are online as well. Thank you, Malcolm and Helene, and welcoming our 2022 fellows. It's been a marathon day for both of you. Thank you for reading citations of 68 fellows. Could you please join me to thanking our secretaries for doing a great job? I stand here today officially welcoming our 2021, 2020, 2022, 2021, 2022, okay, too many of them, right? So, and I cast my mind back to my own election in 2005. 2005 was the year that I stood where you all are now and made my own solemn promise to promote, declare, and disseminate scientific knowledge and to serve the Academy according to its charter and bylaws. 17 years later, I look back on that day and reflect on the importance of upholding that promise now and more than ever. Historically, Academy has been a symbol of scientific excellence, delivering on our remit to advance Australian science and showcase excellence at home and abroad. The Academy has always been a trusted source of evidence-based counsel. It has been science that has propelled our community forward, whether through medicine, technology, defense capability, environmental studies, and so much more. There's not one part of our history or our future that is not touched by science. This is as true today as it was on the foundation of the Academy in 1954. We need only to look over our shoulders at the past 3 years and the advent of COVID-19 to see the importance of science in everyday life. It was science that illuminated a pathway through the pandemic, and it will be science that will help us navigate the future. In my youth, studying by the light of a kerosene lamp in India, I had no idea that my love of learning would one day see me standing here in front of you. But I'm thankful that it did. It is wonderful to be in the company of so many outstanding scientists. Those are passionate about science and love of learning. It's not only our responsibility, but also it's our privilege as fellows of the Australian Academy of Science to extend that joy for the benefit of all and to celebrate, promote, and honor science as a keystone of each and every community. Today is a reminder to all fellows, old and new, of our commitment. This is a promise that we make as fellows, and I encourage you to engage with the Academy to pursue this cause. There are many opportunities to engage, including through the Academy's National Committees for Science, sectional and award committees, and through regional, state, and territory-based activities. The latter in particular is an area that we are looking to grow, and we welcome your thoughts, insights, and ideas on ways the Academy can support you to champion science in your region. Many of you have already made significant contributions in few years since your election, and for that, I thank you, and I look forward to working with you for many years to come. We will now watch a short video on ways you can be involved in the Academy activities.
Congratulations on your election as a Fellow of the Australian Academy of Science. You join approximately 590 Fellows who represent excellence in science. A good place to become familiar with the activities of the Academy is through its annual report, released at the AGM in May each year. You can download a copy by scanning the QR code on your screen. The governance structure of the Academy includes 17 Fellows on Council, and among them 7 Fellows on the Executive Committee. ExCom, as it's known, includes the President, the Vice Presidents, who are the Secretary for Physical Sciences and the Secretary for Biological Sciences, Foreign Secretary, Secretary for Science Policy, Secretary for Education and Public Awareness of Science, the Treasurer,
and the spokesperson for integrity. The Fellowship team collects and maintains all the information about Academy Fellows, including the database, personal records, obituary notices, biographical memoirs, website profiles, and other material. It's very important to keep your information up to date. Let the team know if your contact details change, or if you move into a new position, and also about any significant award or prize you receive, as they are publicly acknowledged by the Academy. To update the team, email fellowship@science.org.au. The Fellowship portal on the Academy's website is where most confidential information is located, including the AGM papers, council papers, updates from the President, the place to pay your annual subscription, and the Fellowship election material. There are many opportunities for you to engage with Academy activities. These include nominating and assessing candidates for Fellowship and the Academy's awards, serving on council or committees of council, joining the Reconciliation Action Plan Working Group, contributing to policy and international work, engaging with fellows in your region or state-based activities, consulting for the Academy's education programs, national committees, which are made up of fellows and other experts within a field and help to steer engagement with their research communities and connect to the international science unions. Every day, the Academy publishes scientific information on its social media channels with over 2.4 million followers to engage, inform and influence. The information can be in the form of short articles, videos and images with detailed descriptions. Fellows are involved in the review of content and in providing scientific material that may be used. If you have questions about any of these opportunities, please get in touch by emailing fellowship@science.org.au. We're looking forward to working with you to make the most of your election to the Australian Academy of Science.
This video can be found on the Fellows portal, which you can log into on the Academy's website. The Academy is its fellows, and I know I speak on behalf of my colleagues on the Academy's Executive Council and the Executive Committee and Council, and also Anna Maria Arabia, when I say that our doors are always open. We want to work with you so that Academy can continue to grow now and into the future. I will end by offering once again my heartfelt congratulations and welcome our new fellows of 2022 as well as 2021 and 2020 and 2019, and thank you to everyone here today for joining us to celebrate this election of so many of the fellows. We'll be hosting a cocktail reception from 6 p.m. this evening in the marquee near the recently restored Ian Potter House, and I invite you all to join us for celebratory drinks, and it promises to be a lovely evening, though we have organized a bit cold weather for discomfort of the Queenslanders, and we apologize for that. With that, now I hand over the podium to Anna Maria Arabia. Please.
Can you please keep the round of applause going for Jagadish, who has... Thank you, Jagadish, for admitting all of our fellows today. It's a very, very special occasion for everyone. You've served a wonderful honour for them. And congratulations from me too to our 2022 fellows. It's been so wonderful to meet you and hear about your research. You officially elected a Fellow of the Academy in May, so I suspect we've already engaged you in lots of activities and you would have met some of our team. But I'd like to use this opportunity to introduce you to the senior management team of the Academy. So if you could come forward.
Good afternoon or evening. My name is Chris Anderson. I'm Director of Science Policy.
Hello, my name is Paul Richards. I'm Director of Communications and Outreach.
Hello, my name's Karen Holt. I'm the Fellowship Director and Director of the Archives.
Good afternoon, everyone. My name's Andrew Hood. I'm Head of IT.
Good afternoon. My name is Zach Uridello. I'm the Director of Diversity and Inclusion.
Hello, my name is Claudette Baitup and I'm the Director of Education.
Good afternoon. I'm Nancy Pritchard. I'm the Director of International Awards and National Committees.
Good afternoon. I'm Melissa Abberton and I'm the Chief Operating Officer of the Academy.
Thank you. Thanks ever so much. These faces will become familiar to you, so please do reach out and stay in touch. We are happy to help in any way. And indeed, do visit us at Ian Potter House or here at the Shine Dome whenever you're in Canberra. Whether that's on Academy business or not, you are always welcome at the Academy. Over at Ian Potter House, since its refurbishment, we now have offices and meeting spaces and things for you. There's also a Fellows Lounge, so do pop in. Our staff in our annual staff survey always say that one of the highlights of their job at the Academy of Science is meeting with fellows. So we do encourage you to visit us. We love working with you and we'd like to see you often. Before I bring to a close formal proceedings, I did want to shout out to Professor Trevor McDougall, who yesterday was given the Prime Minister's Prize for Science. Congratulations, Trevor. Trevor was elected to the Australian Academy of Science in 1997. So congratulations again, it's been a very big week for you. So that brings to a close our formal proceedings. I ask that new fellows make their way to the Becker Room so your official Academy portrait can be taken over the coming days, whether that be today or tomorrow. For those joining us this evening, I look forward to seeing you at 6 p.m. in the marquee near Ian Potter House. And we thank you for your efforts today and for being with us, and good evening.
I'm Trevor McDougall. I'm Scientific Professor of Ocean Physics at UNSW in Sydney. I do research in the ocean's role in climate and climate change, and I work on ocean mixing processes and the thermodynamics of seawater. So ocean mixing is like stirring milk into your coffee. It's turbulence, and the ocean has a variety of different processes at work. And thermodynamics is the study of where heat goes, how the ocean interacts with the atmosphere and where that heat goes inside the ocean. So an example of that is that we need to keep track of the heat transfer around the ocean, and we've always done that for a century using potential temperature, which is the temperature a parcel of seawater would have when moved to the sea surface. One day I was swimming before breakfast and it came to me to try a different variable. And now that temperature variable has been adopted internationally as the way of representing temperature and heat in marine science, and it's a factor of 100 times better at doing that than our previous potential temperature. With colleagues, I've also developed software which enables oceanographers around the world to determine these mixing directions in their own data. To receive the Prime Minister's Prize for Science is an incredible honour. It also is an honour for the early career researchers that I've been working with the last 10 years, and they've been really integral to some of the results that have been recognised in this prize. It's really great that the field of oceanography and climate science has been recognised in this way, because we need these sciences more than ever in the future to understand how the planet is and will evolve with time.